Państwo, nazywam się Jarosław Stelmach i witam Was bardzo serdecznie w drugim dniu konferencji w imieniu organizatorów, swoim własnym, w imieniu naszych tutaj zgromadzonych prelegentów. Witam Was na panelu pod tytułem Nowe technologie, a bezpieczeństwo obiektów sektora energetycznego wobec współczesnych zagrożeń sabotażowych i terrorystycznych. Bez wątpienia jest tak, że żyjemy w dobie różnego rodzaju zagrożeń, a w ostatnich latach zagrożenia hybrydowe, sabotażowe, no może mniej terrorystyczne, są mocno eksponowane w wielorakich dokumentach planistycznych, strategiach bezpieczeństwa. Dotyczą one nie...
Strategies for security, they focus on critical infrastructure, facilities of importance to the safety of the state, especially various energy sector facilities. So we are going to talk about new technologies in response to the new technologies applied by perpetrators. They look for methods and tools they can use in a conflict which is asymmetrical. So we are beginning with a presentation by Professor Jarosław Gryz from War Studies University about the prospect of 2050 and new technologies in this context. Professor.
Czy mogę prosić o prezentację?
Please switch on my presentation. Ladies and gentlemen, I'd like to discuss certain forms connected to developments of the energy sector by 2050, and I want to focus on certain processes and trends which model and show to us how energy transmission, energy consumption and energy production are going to be organized. So let me just say the following. In what areas all these elements will take place? These areas will be defined by development of the technology or technologies which are already in place, but also the ones which are now in the labs, or now they are in the form or at the stage of ideas and concepts, and they will be implemented in the coming years and decades. So here we are talking not only about IT, ICT, biotechnology or environmental engineering, but we talk about application of AI, which will allow to bring together various kinds of technologies and using the knowledge that can be used for various purposes, both peaceful purposes, but not necessarily peaceful purposes, so military purposes perhaps. So if we want to think about breaking down these technologies, well, there are three elements which will be very important here. Number one is the network. The network, both energy grids and computer network will be identical because the network will be used for information transmission, and it will build it will be also energy grid. It will provide energy as well. So, if you ask how it will be used, a form of impulse, electrons, photons, which will be used in such a network. Here, we can talk about several elements: the infrastructure, the Internet of Things, and mobile manufacturing and recreation of elements of equipment, but also elements of the network, so replication. If we think about AI in this context, we can talk about replicators, so replaceability of equipment and devices, which will spontaneously repair themselves, and that's important. Another important element, building a narrative like that, connected with forms of obtaining energy, is using the energy from the cosmic space. I'm thinking about the solar energy especially, because even now it is modeled and sent to the surface of the Earth, but now it is in a test form. At the moment, I would say that the Chinese are the leaders here, and they want to launch the network like that. Let me call it like wind farms in the space, providing energy to some elements of infrastructure here on the Earth. And the third element is a link or connectivity of states, communities, societies, units, and entities, as well as individuals. And the sequences of structure of human genes will be used for that. We are designed in a perfect way. If you think about where ears are located, where eyes are located, where the brain is located, it creates a great simplicity from the perspective of correlating us, humans, with machines and devices. And then one more item, which is being developed at the moment, but it is happening on a limited scale now. It is reparative medicine. And in this context, I'm thinking about biomolecular revolution and using nano-robots, not only nano, but also organs which can be created by nanorobots inside of human bodies. It is being tested, and it is at the stage of experiments, let me put it like that. What is of key importance in this revolution if we think about energy transmission, quantum machines, and digital communication? Here we see the leading elements. So, if we want to focus on quantum machines and how they can be used, there are three elements here that I connected with the methods of obtaining and manufacturing and generating energy here. So number one is cloud, using the properties of the matter in order to increase the capacity for processing data. Then the hybrids, so photons, optic waves, electromagnetic waves, and that's the key when you think about the form of energy transmission by machines and devices. And then conductors, so that's traditional, and then mixed approach, so properties of the clouds and the hybrid. So what's the formula of progress? Here, there is the whole table. I'm not going to discuss it in detail, but let me just say that forms of obtaining energy from oriented on the network, then distributed, then mixed. And for each, I've mentioned the form of energy distribution, characteristics, the method of obtaining, distribution, and the formula of application. We can also talk about the formulas of obtaining energy. You may read out what is written down on the slide, because it is about, again, oriented on the network, distributed, and a mixed one. So these three forms of obtaining energy, even now, are applied in practice at the moment. But the scale is highly limited. We are talking about new forms of obtaining energy, not the traditional ones. So, the things I'm discussing here on the slide, well, are the things which are happening right now. Very many of them are in the experimental stage. So, it will happen on a larger scale in the future. And where can it be applied? In three areas, which are mentioned here. So there is the macro scale, supplying the infrastructure, equipment, devices. Then in the micro scale, which is connected with limited access to infrastructural connections, like in the macro scale, like the clouds, and the mini scale, which is the one connected with micro devices and engineering. So these are the elements which can be mentioned here. Combination of the technologies. For me, it is the division into two groups. That's my approach, but obviously there might be other approaches. From my perspective, it brings some order into this information. The first group is non-living matter. So there is combination of the technologies from the first area, so photovoltaic power plants, water power plants, hydro power plants, wind power plants, something which will be used, so mobile nuclear reactors, which means these are mobile energy sources, like for military purposes. It is definitely tested in the US, and traditional power plants that we know. And they've actually been discussed previously, so perhaps I should not repeat the information here. And there is group number 2 of combination of technologies connected with living matter. And here we may mention the biomechanics of the body and biomechanics of devices. Biomechanics of the human body is connected with the following. We are going to create new hybrid animals, the animals which will be adjusted to specific conditions, where, for various reasons, they would be considered to be indispensable. Biomolecular organs of the body, I've mentioned that. So it is connected with both people and animals. Even today, a simple combination like replication of animals is happening, I would say, on a commercial scale. South Korea, China, if you are interested in that, if you want to like recreate your pets after they die, that's possible. That's possible. There are companies that bring your pets back to life on the basis of the genes which were stored. So perhaps let me move on to my conclusions. So that's my perspective, that's how I see it. And I believe what is of key importance here is development of new editions of computers, quantum computers, and quantum transmission of information, vehicles which can communicate between each other, and uniformity of cybersecurity, critical infrastructure, manufacturing infrastructure, transmission infrastructure, distribution infrastructure, and from macro to micro scale, implementation of various smart materials which assess their properties themselves, carbohydrates. Synthesis is, in my opinion, of key importance for development of the energy sector from the perspective I'm presenting. And the last thing connected with biomechanics of the human body, double DNA helix and replacing the helix, elimination of properties of the helix, and creating a new human being, if I want to simplify the message. Ladies and gentlemen, I guess that's all from me. If you have any questions, I will try to answer them. Thank you very much for your attention. Thank you.
Sir, thank you so much. I will initiate the round of applause to wake you up in the morning. So it's so interesting to speak about the future, but actually in my mind, well, I have this some doubts and concern when I hear about new hybrid animals. It's scary. I think we'll go back to this concept at the time for Q&A. And now I would like to invite our next panelist, Jarosław Jaźwiński from DFE Security. He will tell us about entrance control as an important element of securing critical infrastructure. Well, good afternoon. I'm here to tell you about very basic concepts. I think you deal with the so-called access control on a daily basis. These are access cards. And I don't think you realize how important it is when combined with cybersecurity and the entire concept of functionality required to achieve security of buildings. I will tell you briefly about the current market trends and trends in technical security, anti-terrorist security, and prevention of filtration in critical infrastructure and in other buildings which are not included in the critical infrastructure. On this slide, you can see a building in Warsaw. It's a hub. It's a state-of-the-art building. And in terms of the number of its users, it is very likely that that building will become a part of critical infrastructure. Well, actually, my presentation has just disappeared. Help! Critical infrastructure failed, apparently. So, anyway, it is a very important element because the right security plan and the right concept for it guarantee proper level of security. We need the right standards for it. And these standards are managed by the security people. I'm just inquiring about my presentation, which disappeared. Okay, here it comes, and it's gone again.
Sama koncepcja infrastruktury krytycznej pozwala na podział obiektu na różne sfery.
So the very concept of the critical infrastructure is a concept. There is a zone, a peripheral zone with many devices and pieces of equipment, bollards, entrances, and here we can select the right devices protecting against terrorist attack with use of vehicles. Then we have peripheral barrier and access routes. We need to protect people who come with bicycles or pass with bicycles. And this is an important element to avoid holes in the system. Then we have the start of the administrative system, administrative zone. Here we have revolving doors, we have revolving locks, which in the longer run prevent unauthorized access. And then we have other solutions. We have gates and locks which prevent mixing unauthorized and authorized persons. So we have entrance control solutions here. Note that no hardware solution cannot operate without an efficient access control system. Today, I will focus on hardware. So these are solutions which allow only for sorting people, and then medium and high level protection measures allow to check whether one or more person use the same card to entrance. And then we have a log for limited access zones, and then we have boarding gates. This is an automatic passage identifying one person, and only one person may enter. And then we have anti-terrorist bollards with standards, well, compliant with certain standards. And then technical solutions, various types of gates from the low cost to high cost gates. A gate has many sensors which can read whether there is one person entering with a card or more persons. And these are examples of standard airport solutions which are used in Poland and in other EU countries and outside the EU countries. And here we have the most advanced solutions, so the mechanics of passage and transit of persons on bicycles. Here we have locks, so one card, one person, and this is a device equipped with the ultrasound system, identifying the number of persons in the lock. If we have a server room with a data center, which is a sensitive element, it allows access of 15 persons only. And here we have biometric system involved as well. Then anti-terrorist barrier, it's another topic I would like to cover. So there are some standard solutions such as anti-terrorist prevention mobile system. Then we have barriers, and such a concrete barrier stops effectively a car with a mass of 7.5 ton, and such products are certified and analyzed. So an effective barrier is a barrier which allows to stop a vehicle and protect people who are out behind the barrier. Then we have access control devices, and we have standards which are based on two sets of standards. So we have respective European standards, and then the next topic, which is very well known, is resistance to break-in. So when we have tests, these tests must guarantee certain level of security and protection against an attack. So that allows decision makers to choose the right product. And then we have the standard PN standard 1627, robbery or burglary prevention. Well, actually, this is not burglary prevention. This is resistance to breaking in. Such devices not necessarily need to be 100% resistant to break-in. They allow certain time or period before burglars or robbers enter a building. Now about new technologies that you saw at the entrance. So it's identification in access control devices. So it's scanning QR codes of vaccinated person, measurement of temperature, etc., etc. So these devices have been used for quite some time, but they grow now. Their popularity is growing rapidly. That's all from me. As a company, we support various types of projects related with to critical infrastructure and protection. Thank you. Ladies and gentlemen, you may have noticed that owing to the commitment or engagement of DFE security, our QR codes could be scanned, and we could you could have your vaccination passports, COVID passports checked. The third speaker is Maciej Lipkan with this great experience in security area, in security of buildings and critical infrastructure. Now, he is in the security department in the leading network of mobile telephones. Now my question is about the technologies of the future. Which technologies, in your opinion, will be driving development of security systems in this area? Well, good morning, ladies and gentlemen. To answer this question, let me start by defining the technologies which are necessary to protect buildings which are parts of critical infrastructure. So we need effective technologies. They must be effective in the sense that they must work, that must be cost effective, and they must work to the advantage of their users. Well, effectiveness in this sense guarantees the highest level of security. They identify intruders, they detect intruders, but then their effectiveness also comes from the period of their operation, so their lifespan, and then peripheral security systems mentioned by the previous panelists includes the phenomenon of false alarms. So we have certain buildings and structures distributed across the country. Quite often there are some animals, insects in the area, plus variable environmental conditions in our climate. So nowadays, false alarms are the buzzword on the critical infrastructure market. So false alarms would be caused by animals or through inappropriate use or applications. And here, prevention of false alarms comes from solutions like coincidence of two systems. So there should be two systems that must be triggered at the same time, which show a trespassing event. As an operator of critical infrastructure must first plan the lifespan of a system, and over that lifespan, the investor must consider CAPEX and OPEX systems. So availability, the reliability, access to maintenance and service, distance from populated areas. So that is quite substantial here, and that works for the legal requirements, like guaranteeing technical security. So if such technical security is not guaranteed, we must ensure physical security. So in real life terms, we must have security people present in that in the critical infrastructure locations on site. And physical protection, the cost of physical protection is 10 times higher than protection through alarms. So that's critical in order to guarantee the right level of security for operators. So your question was about the state-of-the-art solutions. As I said, we need innovative solutions for the peripheral security. So here we can respond by offering new edge computing technology So that is processing data from system sensors, then cloud computing to predict incidents. So we may assume that we will teach the system to recognize and identify potential events that may result in adverse events for the technical infrastructure sites and structures. For the time being, it's difficult to predict the new solutions that might be up and coming with the 5G technology, but certainly that is going to be a breakthrough. On the one hand, that technology will support transfer of huge data bundles and critical connectivity security. It is important because the truth is that each and every operator of critical infrastructure should think initially about a well-planned and well-structured strategy for protecting the critical infrastructure, connecting or the security areas which are complementary. When we speak about the security areas, this is not only physical security, but it's personal security, and then technical security, fire prevention. I believe that in the near future, all these systems will be integrated in real time. We'll have this direct connection and supervision of employees and monitoring by the personnel monitoring critical infrastructure complexes. In case of a security incident or a potential hazardous incident, we have certain response procedures which are based on the existing legislation, and then armed groups are dispatched to such sites. As for protection of protected distributed infrastructure, I think it's important when we look at the infrastructure of transmission of energy. We have many power transmission and transformer stations. So according to studies, according to theoretical works, we know that such power infrastructure is highly exposed to incidents caused by human errors, intentional attacks. So there is a publication going, well, there is a study dated 2013, 30 key power stations or critical power stations in the US were identified, and it was calculated that the shutdown of 9 of these stations at the same time could could bring down the entire power system in the US. So that the infrastructure has a critical role in guaranteeing the security of distributed objects. So in case of an attack directed at one or more than one site or structures, the security of such objects can be increased. These structures, these physical critical infrastructure sites are not only sensitive to attacks, physical attacks. They can be effectively attacked from the outside. We have a case study from the US, the Metcalf power station. So there is this So the machine gun was used to fire at transformers and the entire site that was responsible for transmission of power transmission to the Silicon Valley was down. So there are so many doubts, there are so many question marks. Let me use my experience from the Polish power electrical grid to ask about similar incidents in Poland, but I have the impression that the hundreds or thousands of kilometers of transmission lines, can we protect them? Can we protect our power lines by using the state-of-the-art security measures? Well, I understand that there are some parts of the critical network that are routed across the woods, and there are parts of the critical infrastructure. As I said, every single operator should have a well-planned protection and security strategy with a critical analysis of risks and hazards. Security measures should be introduced, at physical and soft technical measures should be introduced. And that should be referred to the risk assessment, and there is always this residual risk that must be accepted by the operator. It is not always like that every single element of the infrastructure must be protected with technical security systems. Well, we may accept the risk of a power mast being damaged, but we must be prepared to be able to restore its operational capacity without a delay. But then, of course, there are some system solutions to bypass some power transmission stations. So there is this concept of redundancy. If one element is out, or if one component is off, well, other components of the system take over. So all that must be based on the risk analysis, and preparation of such risk analysis should be based on careful planning with persons who understand the operational aspects of such systems. And I must say that, in my opinion, it is a mistake not to segment the grid. I'm speaking about the case when systems, security systems, they use the same connectivity systems which are to protect the grid. So very often, well, this is a common error, and that can be easily prevented. And in the context of state-of-the-art technologies, my question is about the operators of the critical infrastructure, liquid fuels, standard fuels, gas, etc. What should be their source of good practices? Well, there might be unmanned system used by the perpetrators, but actually I personally haven't heard about the recommendation or solutions dedicated to critical infrastructure that would be proper for introducing. I remember moderating a panel at a conference devoted to unmanned system, and an airport operator. There were people, gas pipeline people and gas infrastructure people, and they said that we're unable to prevent attacks via drone or suspended devices. So are the systems able to respond to such unmanned threats and hazards? So why is that we do not have specific solutions dedicated to the critical infrastructure unless we do? So on the website of the National Security Center, I haven't found a tool that would be dedicated to that.
Perhaps my answer will not be straightforward, but let me just say that professional protection, physical or technological, should be about information protection. There are certain things which are published for everyone and made available for everyone. But if we talk about the approach to this system of safeguards and protective measures, every operator comes up with their own protection standards, technological protection standards, and they describe protection standards responding to identified risks. And these standards are already protected. I mean, it is protected information. Obviously, installators have access to them after the public procurement or tender process is completed, but installator must keep confidentiality. In my opinion, information protection clause should be even broader when we talk about the information about the technological solutions which are in place and all the logical connections of the protection systems, because well, it is the first line of defense. And the truth is that there is an area of knowledge which should be protected. It is not to be disclosed to anyone. There are solutions. Well, there is an external company which installs the security system in the facility, and then the operator has the personnel and qualified technicians, and they add various technological solutions which increase the level of security. And it is the operator's knowledge that additional elements were added to the system. So the problem connected with drones is, well, it is a hot topic at the moment. It is being discussed. It is a huge challenge, undoubtedly, a huge challenge for operators of critical infrastructure. And I think that everyone is looking for good solutions. I would say the facility which is actually threatened by using a drone is our gas port. During transshipment of gas, if a drone flies there, I don't think it would need to have an explosive attached to it. A spark would be sufficient from electrical engines of the drone. But from what I know, this particular facility was very well protected with anti-drone solutions. Yes. All right. So you say it is based on self-discipline of the operator, high awareness of the operator. And I'm thinking to myself that life usually shows and audits usually prove that if you leave it to the goodwill or the initiative of the facility administrator, well, it is not always the best solution. Perhaps we should have some time for reaction, or we should have an obligation that there must be systems of fast reaction, and there must be specific time for reaction. Perhaps it would be advisable. Obviously, particular methods could be up to the facilities, but let's leave it. All right. And the next speaker is joining us online. It is Maciej Grunt. from Electronic Power and Market Ltd, and Maciej will tell us about innovative monitoring system for technical facilities. Please stick to your time limits. You have 10 minutes for your presentation. Unfortunately, we can't hear the speaker. All right, now it's okay. Good morning. Thank you for inviting me. Welcome to everyone. Hello to all the previous speakers. Now I'm waiting. Okay, I'm trying to share the screen. I will refer to some statements by previous speakers. I just wanted to tell you a bit more about R&D work in our organization on innovative monitoring system for technical facilities. We think it mitigates parts of the risks discussed at today's panel. My starting point is, well, an anecdote. During our R&D work, we made a study visit to one of airports, aviation bases. Minute devices were there, and we were talking to an expert there. He said, I'm retiring now, but I remember that there were various interventions, and some of them were like pointless or were not justified because simply there were some impulses and some, well, so there were some unjustified interventions due to the lack of certain elements of monitoring infrastructure. So I guess our monitoring system will simplify their lives, and I hope our solution will mitigate some risks of attacks against the server systems. And well, basically we identified several trends in the sector. I think they are quite well known, like a trend to have local integration of low-level devices, autonomous devices in critical elements of infrastructure. On the other hand, flexibility and scalability of the systems, because we have mentioned that there are various zones, temporary zones, and the system has to handle that, has to take it into account. But there is another trend, namely application of geolocation, then authentication of identity via mobile devices, a trusted third party, and bring your own device. It is also a trend. So if we can't do anything about that, I mean, we have to accept that, but at least we have to manage access to various zones easily, or authorization has to be managed easily. We have to take advantage of the systems which are already in place, systems for monitoring of various parameters for correlation, for coincidence of events, because we want to minimize the number of false alarms, because it also brings down costs of reaction teams. So we can use knowledge from various systems in order to verify whether we really face a real and significant incident or not. We can use the Internet of Things in order to carry out an in-depth analysis of the data, so that AI algorithms and data mining algorithms should enable us to have a more in-depth data analysis and should help us to make a decision whether a response team is needed or not, whether it is a real threat or not. We've worked for 2 years on that. Let me emphasize parts of our research which were connected with the biggest challenges, like building correlation algorithms, building low-level API and integration between systems, where we can build hierarchical algorithms to correlate events between systems. So in a nutshell, the point is that we can use even the data connected with temperature or humidity in technological infrastructure facilities, data from CCTV, microwave barriers, movement sensors, in order to come up with certain scenario of access and verification of the incident, and whether the incident should be considered as something real, a real threat, or should be perhaps considered as insignificant, not requiring a response team intervention. We are thinking about the saturation mechanisms, saturation of existing elements of infrastructure. How can we cheat the system? How can we burden the system, overload the system? How can we help algorithms which should support a human being, because human beings are actually making mistakes. So we wanted to use algorithms of AI, and we wanted to have local implementation of the tasks without the necessity of constant connection with superior systems, and we've managed to succeed. So it monitors the infrastructure. It is a system of technical protection with various grades, and its architecture is based on services. That is why we can add various business requirements or various safety requirements which are not defined now, but I guess many modules will be added to that in the future. Interestingly, there is an in-depth data analysis using prediction models, building heat maps, maps of threats for individual elements of infrastructure, in order to separate our teams in a reasonable way to provide constant protection. So it is like AI for technological protection systems, a standard structure, customer, server. But it was our assumption that our facilities monitored by the system need to have an autonomous logic. So even if there is a case of sabotage and lack of communication, they need to have a large autonomy in terms of energy, and even bigger decision-making autonomy, because when we have autonomous authorization between systems, our controller can control or propagate various rights to other local systems, or they can make decisions about sending alarm signals or not. They don't need the cloud for that. After the connection is regained, the data is integrated, correlated, our prediction algorithms or threat heat maps can help us in that. Let me emphasize the following. It is like a holistic approach to the threat of continuity of business processes or key processes on the technological infrastructure, which is often the critical infrastructure. So we should have a broader approach to that, not only detection of intrusion incidents or unauthorized usage of cards and all the quasi-sabotage incidents like interference in the supply energy sources, attempts to decrease energy autonomy. So thanks to correlation of events and using the knowledge from the data for that, because the data is already in the organization. I mean the data from monitoring of environmental parameters or from the protocols of existing devices, about the alarms, about the resources. And thanks to the data, we can have a full body of knowledge, and we can make a decision whether it is a real threat, and we should resort to, I don't know, reaction team or response team, or whether it is caused by several mistakes from various systems. And thanks to such an analysis, we can decrease the costs of maintenance and change the paradigm. We pay not a lump sum, but we pay for a real intervention. There is also a full integration of existing systems. We assume that exchange of the whole system of devices and technologies and pieces of equipment, well, it is not very cheap, so we wanted to integrate existing systems, and we wanted to provide them with technological protection. We wanted to monitor environmental parameters, to bring all this data together, and to use the broadest pool of data to make decisions, to minimize the overburdening with reception of data for the operators of such a system. False alarms caused by animals, that's one thing. There is a simple algorithm for correlation data from motion sensors, algorithm checking the size of animals, the access route of animals. Such an incident is registered somewhere in the system, but it is not considered to be the incident requiring a response team intervention. Our system was built with the support of the regional program, operational program, so many thanks for giving me an opportunity to talk to you. I was listening to previous speakers, highly interesting, and I guess there will be plenty of changes in this sector of the market because IoT has been developing and there is a lot of cost pressure. The ratio 10:1, I think it will be growing, so we only hope the technology will not fail us. Thank you very much for your attention. Thank you.
Thank you. When I hear such promises that everything can be solved through technology and technical solutions, I'm more for physical security. The human factor is the key here, but the data saturation needs to be adequate. Why I agree with Maciej that we should go for the golden means. So when we have the operator with more than 100 monitors monitoring this physical security, well, that effectiveness is exactly zero. We need to support such physical monitoring with analytical capacities, etc. Now my question goes to our audience here in the theater and to our internet online participants. We still have time for questions. If you have questions or contributions, no questions, no comments. So I suggest some topics. Some of you have mentioned them. So, Professor, you talked about network future in the context of computer. When we talk about integrating systems, there are some security threats and security challenges. So in the context of the networks, what threats do you foresee in terms of building security and critical infrastructure? Well, the physical infrastructure is going to be autonomous. They'll have the capacity to be sustainable in the sense that they will keep on operating. So say we have a high-rise building. And imagine that the energy and it's shut down. So everything will be off except for the important elements like lifts or water will be still supplied to the top floor to for the fire prevention. So it could be that the part of the building will not be supplied with power, because the system will decide that the power should go to the top 15 or 50 floors. As for critical infrastructure hazards, they will remain as they are. We may look at human error, IT error, and there could be potential errors in the structure, design, or operational concept. So here, I don't think I would come up with identification of new threats. If we have new technologies, these new technologies will have a new formula of hazards. If there are drones can be shot down with electromagnetic shots, and that electromagnetic shooting can prevent them from flying. So there are certain aspects which do not exist right now because it's not necessary. But the things I'm talking about are incidental, are not common. So we'll have the threats that exist right now, plus new potential concepts. My question to you then is, do we really need hybrid animals? I will share my reflection. The reflection I had in 2019. I had the opportunity to visit the US twice. And actually, this is why I quite liked your the presentation on security measures. Before 2019, when I had been traveling to the US, everything looked like as you showed us. And in 2019, I didn't notice any telemetry gates. So we were waiting in two lines over a hall of about 20 meters, and we were just passing slowly, and we were followed by 3 different dogs of a different color and different breed, and that was it. And that was 2019, before COVID. So considering like the senses of these animals, I think people will be trying to use that, or perhaps there are some aspects that would make that animal effective for, say, 2 hours. That might be some elements that will will enhance their capacities. Well, some animals, there might be potentially other animals that can be, well, engaged, involved. And bear in mind, there's one more thing that you should bear in mind. Our understanding of ethics when compared to the catalog of values of Far Eastern culture has nothing in common. We use a very different mental space. We live in a very different mental space, and that is going to determine development of various technologies in the future. So the so-called Western world is not the leader here, and we don't have the Western world. It doesn't have the dominance in this area, including mental dominance. And that is going to cause a major disproportion between different regions of the world. Well, Jarosław, I would like to go back to the concept of barriers that you mentioned. So let's say we define a vehicle as a tool of terrorist attacks of the future. It's easily accessible. And this is why it is vehicles are very often, cars that are very often used as terrorist attack perpetrators. Well, we can protect ourselves effectively in energy complexes and on sites, etc. But it's so important to build the awareness. So among the organizers of mass events, of mass nature, and then let's imagine we're in this beautiful, wonderful city of Rzeszów, and during an open air event, there is actually an unlimited access to some open air events. So, Jarosław, my question to you is, about high quality, high class products available to organizers of mass events. So it is not about advertising, it's not about promoting products of a company. It is more about the concept of protecting an event or a space. So it's like a river, which is flooding the area during the flood, and it is only then that some flooding prevention measures are taken. So Nice, Berlin, Stockholm, well, incidents in these countries showed that no preventive measures were employed there. So the devices that should be used in such cases, they must meet certain standards. And the worst practice which is on the market for those who do not have such knowledge is that companies, businesses declare that their devices, their products, they protect against vehicle attack, but they haven't been through crash tests. They haven't been crash tested. And actually, be it an open air event or a shopping mall, or, well, when choosing the right solutions, one should make sure whether these are engineered solutions, so properly designed, or whether it's a tested solution, tested in the sense that it's standard compliant. And then we have certain devices, but it's important to check whether such a device works in a whole system. So let's say in Nice there are some devices that prevent such system, and the procedure for opening the system for emergency vehicles like a medical emergency vehicle or fire brigade, these procedures are confidential because terrorists cannot have such knowledge. The second thing is to choose companies that protect, which are security company. So the companies, the security companies that we employ should have proper licenses. They should be licensed, and they should have industrial security permits from the Agency of Internal Security. Ladies and gentlemen, we're about to close this very interesting panel. I would like to thank all our panelists or our speakers, Maciej joining us online, Professor And well, gentlemen, panelists, I thank you so much for your participation. The organizer decided to follow the convention that after each panel, the most important presentation is selected. And here I would like to join the initiative of the organizer, and I would like to give a book that I was the editor of about terrorism, a book written on the 20th anniversary of 9/11 events. It's came fresh from the press, so this book goes to Marcin Lipka, PhD. Congratulations. And we invite the representative of the organizer to give this prestigious award to our panelists. I'm deeply honored. Thank you very much. I would like to thank our online followers and you, ladies and gentlemen, and our moderator. Thank you very much for arranging this panel. So let's have a family photo right now. Thank you very much for this panel.
System. Zmieniamy świat dla przyszłych pokoleń. Natura to skarb. Dbamy o środowisko. Podejmujemy działania, aby przyszłe pokolenia cieszyły się światem, jaki znamy. Niezbędna jest transformacja energetyczna i my jesteśmy jej częścią. W Centrum Badawczo-Rozwojowym tworzymy innowacje w skali świata. W naszej fabryce produkujemy ogniwa, moduły fotowoltaiczne, systemy mocowań, szyby z powłokami kwantowymi. Szyby, które świecą. Fotowoltaiczne żaluzje. Fotowoltaiczne fasady wentylowane. Fotowoltaiczne fasady. Fotowoltaiczne świetliki. Kolorowe moduły fotowoltaiczne. Rozwiązania Smart City. Dostarczamy kompletne rozwiązania systemów fotowoltaicznych zintegrowanych z budynkami. Szyby, które grzeją. Parapety, które grzeją i ładują. Szklane grzejniki. Szyby ze zmienną przeziernością. Chronimy zdrowie. Wirusobójcze przegrody szklane. UV-Box. COVID-detektor. Przyczyniamy się do ochrony planety i ograniczenia efektu cieplarnianego. ML System. Zmieniamy świat dla przyszłych pokoleń.
Od tysiącleci człowiek odkrywa świat oraz mechanizmy nim rządzące. Napędza nas pragnienie poszerzania wiedzy i lepszego zrozumienia świata. Potrzebna jest do tego odwaga, która pozwala nam docierać tam, gdzie nikt wcześniej nie dotarł. I odpowiedzialność, która sprawia, że naszą wiedzę wykorzystujemy dla wspólnego dobra. Podstawowym obszarem naszej działalności jest wydobycie gazu ziemnego, ropy naftowej oraz sprzedaż tych surowców. Jesteśmy liderem rynku gazu w Polsce, notowanym na GPW. Działamy globalnie. Stale poszerzamy wiedzę, prowadzimy badania i inwestujemy w nowe technologie. Ma to kluczowe znaczenie dla ekspansji i przyszłości naszego przedsiębiorstwa. Jesteśmy wiarygodnym i pewnym dostawcą dla naszych partnerów biznesowych i klientów. Gwarantujemy stałość dostaw i najwyższą jakość produktów. Zapewnia to naszym kontrahentom poczucie bezpieczeństwa i warunki stabilnego rozwoju. Strategia działania PGNiG opiera się przede wszystkim na poszukiwaniu i eksploatacji złóż znajdujących się na terenie kraju i za granicą. Dzięki temu Polska wzmacnia swoją niezależność energetyczną. Chcąc dywersyfikować źródła pozyskiwania surowców, importujemy gaz z rynków zagranicznych. Istotna część przyszłych dostaw będzie pochodzić z Ameryki Północnej. Poszukujemy i eksploatujemy złoża ropy naftowej i gazu ziemnego na norweskim szelfie kontynentalnym, a także w Pakistanie i innych częściach świata. Całość tych działań sprawia, że jesteśmy kluczowym gwarantem bezpieczeństwa energetycznego Polski. Gaz ziemny jest najlepszym rozwiązaniem dla każdego przedsiębiorstwa, które pragnie działać w zgodzie ze środowiskiem naturalnym. Wykorzystując zasoby ukryte w naszej ziemi, troszczymy się jednocześnie o przyszłe pokolenia. Naszym celem jest ciągły rozwój i dostarczanie efektywnych rozwiązań energetycznych. To dzięki temu jesteśmy dzisiaj obecni niemal w każdym polskim domu. PGNiG. Odkrywamy przyjazną energię.
Sieć LTE 450 to niezawodna i bezpieczna, szerokopasmowa transmisja danych na potrzeby energetyki. To nowoczesne możliwości komunikacyjne, które możemy porównać do tych wykorzystywanych na smartfonie. LTE 450 umożliwia monitoring dużej liczby urządzeń, transmisję danych, przesłanie dokumentacji technicznej, map, zdjęć, obrazu wideo i komunikację głosową. LTE 450 to system wykorzystujący częstotliwość 450 MHz. Specjalne pasmo dedykowane sektorowi energetycznemu. To odejście od ograniczeń radiowych systemów wąskopasmowych na rzecz sieci wielousługowej LTE, gdzie pojemność sieci i zdolność transmisji danych jest nawet kilkaset razy wyższa. Jakie są główne korzyści sieci LTE 450? To podniesienie bezpieczeństwa poprzez efektywne wsparcie służb dystrybucyjnych w przypadku awarii, tak aby szybciej reagować i usuwać ich skutki. To zdalne zarządzanie infrastrukturą energetyczną w celu poprawy ciągłości dostaw energii, czy też zdalny odczyt liczników energii umożliwiający tworzenie lepszych taryf dla odbiorców. To wsparcie rozwoju odnawialnych źródeł energii OZE. LTE 450. Nowoczesna technologia, bezpieczeństwo, niezawodność, przyszłość.
Energia elektryczna towarzyszy nam w każdej chwili życia. Za stały i bezpieczny przesył energii elektrycznej w całej Polsce oraz bilansowanie krajowego systemu elektroenergetycznego odpowiadają pracownicy polskich sieci elektroenergetycznych. Energii elektrycznej nie da się przechowywać, dlatego w każdej chwili należy produkować jej dokładnie tyle, ile zostanie zużyte. Oszacowanie zapotrzebowania na energię elektryczną i jej bilansowanie to jedno z najtrudniejszych i najważniejszych wyzwań, z którymi polskie sieci elektroenergetyczne mierzą się każdego dnia. Nasza sieć to ponad 14 600 km linii 220 i 400 kV. Wraz z dynamicznym wzrostem zapotrzebowania na energię elektryczną rozwijamy sieć elektroenergetyczną, by sprostać wyzwaniom nadchodzącym w kolejnych dziesięcioleciach. Przy wszystkich naszych inwestycjach minimalizujemy wpływ na środowisko naturalne i otoczenie. Wspieramy społeczności lokalne i naszych sąsiadów. W naszych prognozach dotyczących zapotrzebowania i popytu uwzględniamy zmiany zachodzące na rynku energii. Wyprzedzamy je, aby zapewnić bezpieczeństwo energetyczne naszego kraju. Bierzemy aktywny udział w transformacji energetycznej Europy. Jesteśmy częścią jednolitego, zintegrowanego europejskiego rynku energii elektrycznej. Krajowy system elektroenergetyczny jest szczególnie ważny dla bezpieczeństwa państwa. Dlatego przykładamy ogromną wagę do fizycznej ochrony naszej infrastruktury i cyberbezpieczeństwa systemów. Polskie sieci elektroenergetyczne realnie wpływają na polską gospodarkę. Polskie sieci elektroenergetyczne. Energia w dobrych rękach.
Życie to energia. Być może nie zastanawiałeś się, skąd się bierze, jaką drogę musi przebyć. Ale dzięki nam masz pewność, że zawsze będzie tam, gdzie jej potrzebujesz. Już od ponad 15 lat Gaz-System zarządza siecią przesyłową w Polsce. Zapewniamy bezpieczeństwo i ciągłość dostaw. Co roku przesyłamy miliardy metrów sześciennych gazu. Stale rozwijamy się, budując tysiące kilometrów nowych gazociągów. Współtworzymy zintegrowane systemy przesyłowe w Europie, dzięki takim projektom jak dwukierunkowy gazociąg łączący Polskę i Danię, korytarz północ-południe czy interkonektory. Będąc filarem bezpieczeństwa energetycznego kraju i regionu, rozwijamy inwestycje umożliwiające dostawy gazu z nowych źródeł i kierunków. Rozbudowujemy terminal LNG w Świnoujściu. Jesteśmy też odpowiedzialni za powstanie terminalu pływającego w Zatoce Gdańskiej. Zatrudniamy ponad 3000 pracowników, których łączy pasja i profesjonalizm w dostarczaniu czystej, konkurencyjnej cenowo i stabilnej energii. Dążymy do zrównoważonego rozwoju, wspierając lokalne społeczności i chroniąc środowisko. Ponad wszystko zmieniamy oblicze polskiego gazownictwa oraz integrujemy rynek gazu w Europie. Gaz-System. System, który łączy.
Polska Spółka Gazownictwa to największa spółka grupy kapitałowej PGNiG. Jako narodowy operator systemu dystrybucyjnego i europejski lider tej branży, przez prawie 200 000 kilometrów gazociągów codziennie dostarczamy gaz do ponad 7 milionów odbiorców. Stale czuwamy nad bezpieczeństwem i ciągłością jego dostaw. Chcemy, by z błękitnego paliwa korzystało jeszcze więcej mieszkańców Polski. Dlatego realizujemy strategiczny program rozbudowy infrastruktury dystrybucyjnej.
Inwestujemy w tworzenie nowych gazociągów, rozwijamy nowoczesne technologie i podnosimy efektywność podejmowanych działań.
Stawiamy także na gazyfikację wyspową. Dzięki stacjom regazyfikacji skroplonego gazu LNG zapewniamy szybki i bezpieczny dostęp do tego paliwa tam, gdzie go wcześniej nie było. Dzięki naszym działaniom wzrasta liczba odbiorców gazu, a proces przyłączenia do sieci dystrybucyjnej PSG jest łatwiejszy niż kiedykolwiek wcześniej.
Wystarczy zgłosić się do jednego z prawie 200 miejsc obsługi klienta w całym kraju lub skorzystać z internetowego portalu przyłączeniowego.
Polska Spółka Gazownictwa. Dostarczamy paliwo gazowe w sposób ciągły, bezpieczny, z poszanowaniem środowiska naturalnego. Polska Spółka Gazownictwa. Wybieram gaz.
Dzień dobry, witam wszystkich serdecznie. Szanowni Państwo, rozpoczynamy panel tematyczny pod tytułem Energetyka i jego
to the next panel, we are going to talk about the following topic: energy and the circular economy. We are going to talk about various sources of waste in the energy sector. The first speaker will be Mateusz Jagieła, member of the board of EuroEco from Mielec. He is going to talk about legal conditions for the use of RDF fuels in power generation. So the floor is yours.
Dzień dobry Państwu.
Good morning, ladies and gentlemen.
Miło mi Państwa widzieć.
It is my pleasure to be here.
Lekkie zdenerwowanie czy stres.
If I'm a bit under stress, I want to apologize for that, but I have such eminent members on the same panel, so that's not what I do on an everyday basis, so please forgive me if I'm not a perfect speaker. I will present the topic of legal conditions for the use of RDF fuels in the power generation. As for an RDF fuel, it is a refuse-derived fuel. It is alternative fuel, which is the result of sorting out and the right preparation of a fraction of municipal waste, also industrial waste. And it has quite a high calorific value according to the regulation of the Minister of Climate of January 2020. RDF is waste with the code 191210, so it is combustible waste. If we talk about the application of RDF fuel, we have a certain hierarchy of handling the waste, including municipal waste. And the first element is prevention of waste generation, so limitation of the amount of packaging, reusable, recyclable packaging.
Nasze społeczeństwo jednak korzysta z opakowań. Właściwie wszystko jest pakowane, więc tutaj pewnie jeszcze dość dużo pracy.
A lot needs to be done in this respect. Then we have reusage of the packaging and then recycling. The next method is recovery of energy. Energy recovery and combustion of waste, or RDF fuel combustion, is precisely about that. And towards the end, there is a process of annihilation of waste by storing them in landfills, for example. So here we have energy and climate policy of the European Union, which is quite adequate, and we also try to reduce the volume of hard coal. So we have to move away from coal, but then coal needs to be replaced with something. And one of the alternatives is RDF fuel, because it has quite a lot of calorific fraction, and it can supplement our energy mix thanks to that. What are legal conditions connected with that? So all the legal regulations related to that. Number one is the law of December 2012 on waste. Then we have a document by the Minister of Development of January 2016. And here there are some guidelines connected with temperature of combustion gases, some specifics of specific information about the installation for thermal processing of the waste, and requirements as to the installations which will be used to protect soil and groundwaters against sewage waters in the process of using these fuels. And then we have a decision by the Minister of Environment of 2014, and it includes requirements on measurements of the amount of emission and the measurements on the amount of water used in the process, because it is about the frequency of such measurements. And it is about the frequency of checking the amounts of emission generated in the process of RDF fuel combustion. There is a principle that it is at least every 3 months. It is checked every 3 months. Then once in 3 months, emission to the air is also checked in the first year. Later on, it is once in 6 months. As for emission standards, there is quite a significant document issued by the Minister of Climate in 2020 as for emission standards for the installations in which RDF fuel is incinerated. And then we have the European Parliament and Council Directive of 2010, which mentions PPK. It is a national plan of moving towards next stages. So, well, there are some transitional periods provided in this directive. As for emission standards for waste co-combustion installation, there are certain brackets depending on the power of a given installation, between 50 and 100 megawatts. There are values for various compounds that you can see here in the slide. So like for sulfur dioxide, and you can see these brackets between 50 and 100, between 100 and 300, and for sulfur dioxide it is 200 milligrams for a cubic meter, and above 300 these standards are actually the same, but as for dust, you can see it is only 20 milligrams. As for heavy metals, they are quite significant, dioxins. And these standards are very strict, I would say. As for cadmium, you can see it is only 0.05. For mercury, the amount is the same. Dioxins, 0.1. So quite strict limits, I would say. For furans, the same. So the standards are prepared in such a way that if we exceed these amounts, Or let me rephrase it. If we stay within these limits, our processes are not toxic for the environment, are not toxic for humans, because actually these are dangerous substances, and we don't want to pollute the environment. If we compare a coal-fired boiler emission and RDF fuel combustion installation, you can see the comparison in the table, and there is a comparison which shows that some parameters are much more beneficial in the case of RDF. If you look at the calorific power or thermal power of coal-fired installation, it is 30 megawatts, and there is also 30 megawatts for RDF installation, but you may notice that fuel consumption is significantly higher for RDF installation. But it is not a bit of criticism, I would say, because RDF fuel is based on waste. So we can simply combust more waste. That's okay. As for the amount of flue gases, it is comparable. But if you compare SO2 emission, you can see a significant difference. And you can see for RDF the number is much lower. It is line 4. And the same goes for line 5, NOx emission. And then you can see the last 3 lines, and there are significant differences there. So dust emission, again, lower for RDF. So I would say RDF seems much more convenient and should be favored, but you can just have a look at the table. So perhaps we should come up with a modified fuel, the fuel which will lower the values for heavy metals in the process of production of RDF fuel. We may have the fuel which will remove the fractions which are carriers of heavy metals. We as the company work on such a solution, and I hope very soon we'll come up with the final answer. So we'll have the fuel which will be like clean fuel with lower parameters for emission. As for co-combustion of waste, in our country, the main installations that receive RDF fuel, so based on waste, are cement plants. But there is inequality in terms of structure in the market, because as the society we produce about 5.5 million tons of calorific value in waste, whereas installations in the cement plants combust 1.5 million tons, and some of the fuel is combusted in thermal power plants. As for the remaining amount of fuel, it is exported. So it leads to a situation when we have quite high quotas of waste management in households or companies, but there is lack of balance in the market. Cement plants want to have subsidies for utilization of waste at the level of 200 zloty per ton. So they don't use coal for the combustion, but they use RDF fuel, and they don't have to pay for coal. They receive a subsidy for using RDF fuel, which is like processing the waste. What about other countries and solutions in other countries, especially Germany? There is an electrical power plant in Jędrzwalde, which is lignite-fired, and there is co-combustion of RDF and lignite. This solution is in line with the EU legal regulations because a method of designing the right levels of emission followed a mixed principle which takes into account the values of both fuels, and the average value is calculated so they do not exceed any limits for emission. What is significant here is that co-combustion of RDF did not require any rebuilding of the installations there, so emissions are still at the accepted level. It is just an example of a certain method that can be chosen. It is the way which was selected, which was chosen in Germany among other countries, because I want to show that the EU law or Polish law is not or doesn't have to be as restrictive as to limit solutions like that. So, co-combustion of RDF on a larger scale would lead to a change in the market, lowering subsidies or giving up on them, because RDF could become a product. Well, it is definitely a beneficial solution. It is beneficial for an average person, for Mr. Smith, for all of us actually. So what are possible solutions? As for the first solution, it would be losing the status of waste by RDF fuel. It is possible if RDF is a stable fuel with repeatable parameters, and there are also other requirements which are defined in the waste law. There is definitely a demand for this product, and it is quite easily available, and as the society will produce the fuel in bigger and bigger amounts, I would say. We can also mention another option, like adjusting some of energy sector units, to adjust them so that they can co-combust RDF, and some installations need to be rebuilt. But it doesn't mean that every installation would have to be a co-combustion installation for RDF fuel. When we talk about the professional energy sector, we talk about several units that could be transformed in such a way or adjusted in such a way. Obviously, the costs are quite high if you need to adjust it to RDF co-combustion, but RDF has like 50% of biofraction, and due to that, fees for CO2 emission are much lower, and there is a difference in costs of obtaining an energy carrier if you compare it with lignite or hard coal. So economically speaking, it would be justified. And another option that I can see here is RDF combustion in small installations in thermal power plants. It is happening, but these installations need to be simply built. They need to appear. And as for the last suggestion, or the last option here on the slide, or possible solutions that might be proposed, it is co-combustion of RDF fuel in installations without the necessity of obtaining an without the necessity to obtain an integrated permit. It is quite controversial for some. I'm not a proponent of this solution, but some people suggest it is one of the ways to go. So when we talk about RDF application, it is definitely an energy carrier which is worth our attention. We should not just export it, because it is quite a big cost generator, living cost generator. I've heard opinions that the price of waste management is quite significant when you think about the inflation pressure, and solving this problem is definitely beneficial, or will be beneficial for all of us. What is significant is that co-combustion of the RDF fuel, or combustion of RDF fuel, will decrease CO2 emission, which is calculated into the costs of obtaining energy. So we have two goals at the same time: lowering costs of waste management in households, in companies as well, in businesses. On the other hand, lowering the costs of energy, electrical energy generation. I guess that's all from me. Many thanks for your attention, and thank you for bearing with me, for your patience and attention. I will participate in the panel, but for now, thank you.
Thank you very much for this very interesting presentation. And the next speaker is Dr. Engineer Aleksander Sobolewski, who is the director of the Institute for Chemical Processing of Coal from the city of Zabrze. Mr. Chairman, ladies and gentlemen, I'll follow up on what Professor Jagiełło has said. I was requested to give a presentation on the construction of energy until energy unit fired with fuel produced from municipal waste sorting residues. So we want the circular economy to work perfectly, and when we look at this nice circle, we can see that it's a perpetual cycle. It's a never-ending circular economy. So we have the materials that are fed into the system and come out of the system. So what about the closed-circuit economy and how it operates? Actually, we have two loops. So first we consume, and then our waste goes to the recycling systems, and we have two loops. So first we have the expectation loop, and the product, recycled product must be of the same quality, and everything should be nice and green. And on the left side, we have the unwanted circle. We move on to the heat and energy producing circle, and at the very end we have that arrow of shame. So actually we don't want that landfilling, we don't want the waste to be dumped in the landfill. But let us look at the mega trends in the civilization. Well, so first, the consumption level is shows our social status, and the life according to the eco trend is not necessarily the earmark of your social status. And then, obviously, on the other hand, it is becoming harder and harder to generate energy and raw materials, so we need to recover it. And again, well, contrary to popular belief, selective waste collection does not solve the issue of waste recycling. So if you have 20 piles of waste, nothing changes. Only when we have the right technology to manage the waste and have the waste fully recycled, only then we're successful. So what is very important and what is not what is beyond comprehension of most of the society, waste energy generation from waste is not contrary to the circular collection. So on the one hand side we have households and local business, and on the other hand we have municipal systems for waste processing, and then heat and power cogeneration. So these are attractive solutions for the local communities. And now realistically in Poland, unfortunately, we have two solutions. So it's either garbage waste dumped in the forest, or we burn waste. We have about 3 million tons of waste that disappear. They disappear in home, local, furnaces or boilers, and I think it's a burning issue. Something needs to be done. The question is very simple. How to get rid of waste? We don't want the waste to occupy our thoughts, but there is a social cost. If you look at the municipal waste and the collection system, we have two lines. So we bear with recycling. So we have recyclable waste, scrap and glass. The question is, why can we recycle them? We have the right high temperature technologies. So we go through glassworks or steelworks, and on the other hand, as long as we do not have the right technological solution for plastic, including mechanical recycling and restoration of functionality 100%, we'll have to look for other solutions. And we have three options here. Incineration, so incineration is a well-known technology, requires social acceptance. Then we have chemical recycling. About 2050, I think it will dominate in the technological processes. But when we look at Germany, Japan, that's their direction, but it's a very costly and large-scale solution. And then we can go towards enhanced segregation, improving ecological awareness, but it's going to be difficult. So if we can have if we cannot have an effective recycling of most waste, well, we should perhaps work on the recycling. So we need to think about recycling and how to improve it. As for incineration of waste in Europe, on the first graph is the EU average, then we have German economy, and then Poland. Note two things. Follow my pointer. Is 600 kilograms in Germany and 300 kilograms in Poland? Well, that's the major difference. So we can see the home incineration, which is illegal in Poland. So we would like the landfilling part to go down, and I think it's a shame that we have so much landfilling. Look at Germany. So we have twice the distance to cover. Now, what about the incineration plan? When you look at the map of Poland, the entire southern part of Poland, we have cement plants. In the northern part of Poland, we have incineration plants. And actually, in the center of Poland, like around Łódź, the city of Łódź, there's nothing. And then we have southeastern Poland. So actually, in smaller towns and cities, there are issues. We are missing 3 million tons of waste generated every year, and which go unincinerated. So what are solutions here? A technological model, it's co-combustion or combustion. Would we like to have power and heating generation, or would we like to have just heating generation for local governments? Heating generation is a less expensive solution. Now the question is whether we need smaller units in local communities, or should we go for large units? And the final question is, should we use local technologies or should we use imported technologies? And then options. We may have a local boiler, RDF operated boiler outside the ETS, so that's below 20,000 tons per year. And then like a larger size RDF powered boiler, then we have a multi-fuel unit and other solutions. And as for waste incineration or RDF, it's that solution, and I'm very happy that this concept is taken seriously by the Ministry of Climate in Poland, and I'm looking forward to having the right legislation supporting it. So we need to introduce it in practice. Why hasn't it been introduced in practice for the past 30 years? So speaking about the heating generation, the first high revenue from RDF receipt, well, that fuels the concept where we paid and we get high quality fuel. We all would like to be included in the larger scale heating generation, but we need to have quality standards for the RDF to protect our boilers, and then we need to have the right administrative decisions. And as long as our administration is not friendly, as long as the local governments oppose waste incineration, we'll have an issue here. And then we need to have subsidies supporting our capex. And then I wrote RDF among heat generators is associated with technical and formal issues. So everyone wants to operate gas-powered boilers. Everyone wants to be exempt from ETS. Then boiler operation, quality standard for RDF, very high cost requirements, ash as byproduct. So it's very difficult to come up with a reliable business plan for a system like that. Should that be self-financing investment? Should there be a proper return generated on this business? Well, I think that should involve a social mission. But if it's not, if its balance doesn't close, then we won't get any bank financing. How to attract, how to have financing? We need to have ETS and RSC related regulations. And then finally, I wrote that we need to convince the local community. It takes time. Local governments put a lot of effort into convincing the local community that such boilers, such systems and units are the opportunity and not a threat. The exhaust gases from boilers are not poisonous. So I thank you very much for your attention. I thank you very much for this very interesting presentation. So these two presentations were just an introduction to our panel. Then we have Mr. Zdzisław Systek, who is a member of the management board of MPGK Krosno Municipal Holding, and he will tell us about construction of an energy unit fired with fuel produced from municipal waste. Thank you.
Thank you for inviting me here. The previous speakers have discussed some theories, and I would like to show the practical side, how we are trying to do that in Krosno. So I'm going to talk about the construction of an energy unit fired with fuel produced from municipal waste, sorting residues in Krosno. So all the goals mentioned by Dr. Sobolewski are our goals as well, and I will try to show it in practice. I went so far, so perhaps just a few words about the municipal waste company. Krośnieński Holding Komunalny, Limited Liability Company, capital almost 114 million zloty. We have a subsidiary with 100% of shares. It is a municipal transportation company. We have 49% of shares in Remondis, which deals with waste collection. As for our revenue, the largest share is from water supplies and thermal power plant, 16%, waste processing plant, 33%. You will see that this breakdown into our revenues is significant because it is not focused on one kind of activity only now. The photo, old boiler room in the front, at the back, biomass plants, biomass, closer photo, lower stack. You can see that there is just a small pile of coal, much more biomass, because we use biomass for combustion, our turbo generator. And what do we have in thermal power plant? Krosno, we have 3 coal-fired boilers, and 3 of them are WR10, 1 WR48. We have biomass boiler, co-working with turbo generator ORC with thermal power 3.7 megawatts. It is the installation operating in cogeneration, highly efficient cogeneration. Last year we added biomass boiler with the power of 7 megawatts, installed power almost 48.5 megawatts. And as for thermal network, the length of it is more than 32 kilometers. Thermal network is significant because there is heat reception as well in the base. There is ORC installation, so it means that there is cogeneration of electricity and heat. Operates throughout the year. If there are peaks, so peak demands for heat, there is biomass boiler added in the peak times. We also launch coal-fired boilers only in these peak demand periods. Thermal power plant, yesterday, today and tomorrow in 2012, there was only coal which was fired there. Starting from 2013, as you can see, heat generation, it is mostly in cogeneration from wood pellets, and then you can see in 2020 a new biomass boiler, and by 2024 we want to have an installation based on what remains after waste sorting. It will work in cogeneration, and the other cogeneration installation will be for wood pellets, and in the peak biomass boiler will be added. And I think we will not use a coal-fired boiler at all. The structure of production of thermal power, you can see 2012, 100% was from coal. Now in 2021, 56% of energy is green energy in cogeneration from wood pellets, 32 biomass boiler, and coal-fired in peak periods are responsible for 12%. By 2024 we will have the remnants from the waste sorting processes. The name of our project that we are carrying out now is Integrated System of Waste and Energy Process. It is the second stage, and energy unit which is fired by remnants from sorting process. Thermal power 6.4, electrical power 1.6, the amount of fuel 22,000 mg per year, not that much. Average calorific value 13,000 kilojoules per kilo, combustion technology, and generation of electrical energy. So there was a tender and there was a contractor who decided to come up with the technology like that. So there will be a turbine applied there. the best offer in the tender, 110 million Polish zloty net. It was the most beneficial offer. It is the consortium of the following companies. You have the names on the slide. The leader is Install Warszawa SA, and Dalkia Waste Energy is a partner to consortium. They've had many installations built in Europe so far. And then financing our national funds. We received the funds from the national funds of environmental protection and water management from the program entitled Rational Waste Management. We signed a contract for 50 million Polish zlotys of a subsidy, and so there is one contract, one agreement for a subsidy and the other one for a loan, 61 million of Polish zloty net, and it is 100% of investment costs of our installation. On our side, we have to cover VAT, tax value, we'll regain it because we'll account for it and we'll receive a return later on, and we also pay for the contract engineer. So it is another cost on our side. Let me take a step back. Integrated waste management system, the first stage, so what we have already completed. It is also significant from the perspective of the whole project. We have 27 municipalities and rural communes participating in our project, and the leading role belongs to the municipality of Krosno. So we have waste from 27 municipalities and rural communes, and the project that has already been completed from the cohesion funds and the operational program Infrastructure Environment. We received almost 58 million Polish zloty of subsidies, almost 19 million Polish zloty of a loan to supplement the funds. And under the first stage, we built installations which were PV installations, 650 kilowatts on the old landfill, which was regenerated, and the subsidy covers 1/3, and 2/3 is a loan from the national funds, from the National Fund of Environmental Protection. So what are the results of the first stage? The sorting space, the sorting room with state-of-the-art technological line for sorting waste, picking up all the useful parts, whatever can be sold. So you can see a photo from there. There are many separators of ferrous metals, non-ferrous metals, 2D separators, 3D separators, optical separators, and we can pick up whatever is useful in the body of waste, what can be sold further on and can be recycled. A photo of the building, and the other installation is biological processing of waste, so stabilization of and bio-drying. Then here more photos, bunkers, airtight, closed, hermetic space, another investment, selective waste collection outlet, very convenient for inhabitants, very popular with local residents, and photovoltaic installation on the regenerated landfill location. Gross value of all the projects is 109 million Polish zlotys. What about the story of the waste in the past? The basis was storage. Now the basis is prevention, recycling. Energy recovery is now number 4, more or less, in this hierarchy, but as the previous speaker has said, you cannot close the circulation and the circuit without energy recovery. And experts say that we process more than 40,000 tons of municipal waste. We have 22 tons of certain fractions, I mean the fractions that we can use for generation of alternative fuel or for combustion, and we have 13 million of costs at the moment. And what is the perspective of energy experts? When waste experts see costs, we as energy experts see energy and we see potential revenues. avoided costs of purchase of fuel, thermal energy, because we have our own thermal network, we can sell it, we have our own recipients. If we use waste fuel, we don't have to buy coal, we can limit purchase of biomass. So economic answer, does it pay off? Is it profitable in a small installation? So you can see management and dealing with the remnants from the sorting plant. Well, to sum it up, we can save 13 million every year on these two elements. And in the base, the fuel will be remnants from the sorting plants, then cogeneration of the second part, and biomass boiler and peak periods. It is production of our energy, now 56% in cogeneration based on wood pellets, and 32 biomass boiler, and 22% coal. It is our goal for 2024. 78% from cogeneration based on waste fuel, which will be the base, and then cogeneration based on wood pellets. That's number 2. What next? We've implemented self-consumption of electrical energy. We can compare how much we generate, above 11,000 of megawatt hours per year, and what's the consumption. We as the holding use a bit less. I have to say that it is not true that we fully satisfy our needs in this respect, because production is not ideally correlated with consumption, so part of the energy needs to be bought and sold at the balancing market. We believe that energy has to be produced from all the resources which are available to us, so 71% produced from wood pellets in cogeneration installation ORC, 23% using biogas from sewage treatment plant. It also works in cogeneration. Heat is recovered and used to heat up other elements, and there is a process of fermentation. There we have electrical or hydropower plant. It is quite small, but used perfectly well, because hydropower is used locally for providing propulsion for pumps, for water intakes and PV installations that we've been developing. After building energy units, our production will be even higher. It may reach almost 20,000 megawatts. And what we are planning, that's the breakdown of the electrical energy generation. You can see that the source based on waste fuel is highly stable. What next? We are planning to set up an energy cluster together with the municipality of the city of Krosno. We want to provide energy, electrical energy for all the municipal units in the city of Krosno. We are working for our local residents. We are working for the benefits of the environment as well. Thank you. That's all from me. Thank you very much for your presentation. And now it's time for the next speaker, the next presentation, this time by Wojciech Drozdowski, member of the Supervisory Board, MP WIG from Rzeszów.
Dzień dobry Państwu.
Good morning, ladies and gentlemen.
Elektryfikacji źródeł energii elektrycznej oraz optymalizacji kosztów produkcji.
To diversify energy sources and have cost-effective water and wastewater treatment costs. Our municipal water plant in Rzeszów decided to introduce green energy and green solution.
I mocy 1 megawata.
It's a 2 hectare and 1 megawatt PV solar plant. So this is our RES energy management system with different energy sources. At this point in time, we have a cogeneration of 1 megawatt, and then we have PV plant of 1 megawatt for waste treatment plant. And recently, we've just accepted a PV plant at the water treatment plant, and then we have tasks at smaller sites. And this PV plant at the water treatment plant to treat wastewater built in 2016-2017. It's 1 megawatt, and we have 4 frequency transponders, and they are installed in an air-conditioned room. We decided to introduce a different solution. In waste treatment plant, obviously, we have quite many challenges related to poisonous odors.
Jednym z ważnych aspektów budowy naszej farmy fotowoltaicznej było wykorzystanie
One of the aspects of our PV plant was to align the panels align panels to the sun, to have that special angle, and the alignment was so the alignment is along the east-west axis to have the maximum sun from morning until evening. And here on this slide you can see the inverter station, inverter unit with it's an air-conditioned unit with a low voltage cabinet separator protecting against excessive use. So this is PV789 biogas generators, 630 kilowatts of power. And on this slide, you can see the biggest power generation of the megawatt farm. So 995 megawatts, that was July 2019. So the farm was fully operational, operating at its full capacity, and had all its PV panels in place. And this is what we... So cogeneration is green, and you can see month by month, depending on the energy sources, how that works. Here we have a PV farm at the water treatment station. So here we no longer align the panels to the east-west axis, but then we have inverter units directly on the farm. And then in the water treatment plant, the farm is 1.2 megawatts, so with 400 frequency inverters and a freestanding transformer and power distributing unit. And then we have a power distribution plant. And we have repeaters and a remote monitoring system, monitoring cost effectiveness and operational effectiveness of the devices.
Ten wykres przedstawia nam zieloną linią.
And here on this graph, this green curve is the forecast production at generation at the conceptual level, and the red curve is the actual generation in 2020. And this is the energy balance of the PV farm. So blue is energy purchased from the power supplier, and yellow is our own power generation per month. And here we compare PV systems. So it's the water treatment plant and so both water treatment plants and different systems with different parameters depending on the parameter, depending on their size, they generate similar amount, similar power. So this is the water treatment plant and wastewater purification plant.
Kolorem jest różnica procentowa pomiędzy jedną instalacją a drugą instalacją. Widać wyraźnie, że zakład uzdatniania wody, który ma...
And we can clearly see that the water treatment plant that has 200 megawatts of installed power more needs much more energy here. So in this contract, our company has installed smaller size PV systems. So we install them on the facade of the building on the left side and on the roof of the garage unit on the right. And on the office building, 30 PV modules were installed on the facade and 14 PV modules on. So these are two separate systems with inverters. As for cogeneration, as I was saying at the very beginning, in 2005 we received a permit to co-generate power and heating. We set up the co-generators G1 and G3, 335 kilowatts of electrical power and 520 kilowatts of heating power. And G2 and additional co-generators were added later on, while some of them were serviced.
Produkcja energii elektrycznej przez kogeneratory.
Electricity generation through in cogeneration, 5,566 megawatt hours in 2020. By cooling the exhaust fumes, we recover heating, and heat energy recovery is substantial because that covers the entire demand for technological heat and household heating. So that recovered heat in 2020 was 15,800 gigajoules. Generally, we do not use energy from the, we do not buy energy from the outside. What we generate is sufficient. This is a combined power and heating, and we have desulfurization, biogas desulfurizing unit and cogeneration in numbers, in figures. As shown on this graph, since 2004 we've generated more than 77 gigawatt hours of energy from generation, and this is electrical energy consumption by our plant since 2013.
Jak widać, przepraszam. Tu jest zakup energii elektrycznej.
And here we have electricity that we were buying, electrical power that we were buying throughout all these years. And here we have the production from generation from PV farms, and this is the net price and overall cost. And these are costs that we didn't have. We produced the energy. So in 2000, we saved quite substantial portion of cost, and this is our PV system of the plant one. So we want to have additional PV units on our additional sites and buildings. At the water pump station, and here we've started construction of water tanks and special tanks, and we plan to install PV panels on their roofs. Thank you very much for the presentation. Our next speaker is engineer, Master of Science, the graduate of Rzeszów University of Technology. She will tell us about wastewater as a source of waste heat.
Good afternoon, ladies and gentlemen. I'm going to talk about energy recovery. Especially I want to focus on heat from wastewater. So heat recovery. And the wastewater is from the housing sector. So perhaps first I should say that there are some significant items I'm going to discuss during my presentation. Let me start from them. So I'm going to talk about energy consumption in the housing sector. I want to say why we need to focus on the heat recovery, and I will discuss some systems for heat recovery from grey wastewater, and I would like to show some typical configurations of systems for heat recovery, and I will mention energy efficiency also in this context. First of all, I'd like to highlight 4 important questions, namely whether heat recovery from wastewater makes sense. Is it technically feasible? There is also a question, can it be an important contribution in the energy balance of the housing sector? And then, does it have any impact on the environment? When we analyze the data from Eurostat for 2018, we can see that a household and the housing sector were responsible for 26% of the final consumption of energy, and you can see it in this slide that the biggest amount of energy was generated by heating flats and houses and preparing hot usable water. And then the next slide may be even clearer. Almost 15% of the energy used in the housing sector, in housing buildings, was generated by preparing hot or warm water, for example, for bath or shower. According to the data from Eurostat, almost 90% of energy which was necessary for flats and houses was from non-renewable energy sources. So there is a conclusion perhaps that we still need more research in order to prepare low or zero emission technologies And I think that heat recovery from wastewater should also be taken into account. We need more technologies in this field, and we should come up with new devices as well. As you can see in the slide, there is a general scheme showing heat recovery from the housing sector, from housing buildings. So water goes to various sanitary outlets, and the rest of the water, so wastewater, has lower temperature, and then it goes into wastewater installation. And at this stage, let me focus on heat exchangers, so on the very solution. As for the division of the devices, or devices for heat exchange, we can have the ones directly installed at the sanitary intake, but there are also devices at the outlet to the wastewater installation. So the first group, what is typical of here is horizontal devices, or pipe within a pipe, or spiral devices. We may also have heat exchangers inbuilt in the shower. And in the other group, in the second group, we have thermal pipes or heat exchangers in the form of a container with a coil. And there are also heat exchangers with retention of wastewater and retention of water from water supply system. And that's the other group. Here, I'd like to show an example of solutions which are available in the market. Solutions connected with heat exchangers. Number 3, the drawing number 3 shows a vertical heat exchanger, spiral heat exchanger, and they are often implemented in buildings with a large space, with a basement, especially in households. And then another example of another vertical heat exchanger is of a kind, a pipe within a pipe. And heat exchangers may operate individually as separate devices, but they may also operate in more developed systems, in bigger systems simply. Let me go back to the previous slide. A heat exchanger which is embedded next to the wastewater discharge points. It is a more compact device. As you may notice, it is often used in multi-floor buildings. If the space for embedding such a device is limited, that's why it is so compact. Something similar, slightly different structure, 2 heat exchangers for swimming pools, 2 different producers. And here I would like to tell you more about certain solutions worked out in the chair of infrastructure and water management. And we wanted to come up with highly efficient and compact devices. What was important were faults of the devices which are already in the market, and it was to be a device of new generation which was supposed to eliminate previous faults of the design. The first heat exchanger is installed in the shower, so I hope it is clearly visible. Have a look at the mid wall, the wall in the middle, and it is this wavy structure. It is to increase efficiency. It is a compact heat exchanger which can be installed in buildings, like multi-family housing in households, multi-floor buildings. And here, a vertical spiral heat exchanger. A typical feature of that device is this spiral conduct for water supply system water, it is to prolong the contact time with water. It is to have a positive impact on efficiency of heat reception, I mean the heat from wastewater. Here another example. Again, it can be installed in the shower. And then a horizontal device. It is like pipe within the pipe, this particular model. Look at the dividing structures. It is to change the nature of the wastewater into turbulent wastewater. It is done on purpose to have the highest efficiency of heat reception. At this stage of the presentation, I'd like to show 3 typical configurations of heat recovery systems. So have a look. I hope these drawings are clear. And the first one, or actually all of them, includes basic elements, so heater, and you can see all similar elements, and there is the vertical heat exchanger here, like pipe within a pipe. Number 1 shows the solution where water is initially heated up from exchanger is directed to the mixing valve. In the second configuration, what is typical of the second case is water is heated up, goes to the heater, and then in the third option, in the third system, water is heated up and directed to the heater and to the mixing valve. You may be wondering why or whether such configurations have an impact on efficiency of the heat recovery system. So perhaps I should say, what is the efficiency of heat recovery system? We may calculate it using the degree of for the difference of temperatures. It is the first equation, or we can focus on the energy consumption in order to prepare warm water in the system without a heat exchanger and in the system with the heat exchanger. And now let me show you the results of the research on a real-life model in realistic conditions. It was the research for the system with a vertical solution, pipe within a pipe, and as it was noticed, the highest efficiency of the system was achieved in the third option, third variant, and water was heated up initially. It was sent both to the heater and the mixing valve. Additionally, it was pointed out that together with increase of temperature, the efficiency went up as well. And the next graph shows efficiency of the installation for a horizontal heat exchanger that you have seen in one of my slides, installed at the shower. And here efficiency of heat recovery was lower, did not exceed 31%. So let me sum it up. There were 4 questions I've asked at the beginning of my presentation. Heat recovery from wastewater is possible at the stage of generation, transport and usage of wastewater, and according to the research results, it is justified if there are multi-floor buildings and households in installations for preparing warm, usable water and wastewater installations, because it is translated into lower energy consumption. If you think about water that you need to warm up if you want to have a bath, and basically it is translated into lower greenhouse gases emission and lower cost of maintenance of the building. Let me also say that an important advantage of heat recovery systems is that it is independent on weather conditions, and I think it is an additional benefit, quite significant, and it influences the comfort of the usage of the installation. Additionally, I'd like to say that heat recovery systems can be of interest, especially if there are passive buildings, and the very structure of passive buildings limits the amount of energy which is necessary for the building, for heating up the building, for example, but it doesn't have an impact on the energy which is necessary for heating up water, to have warm, usable water. That's all from me. Thank you very much for attention. Thank you for your interesting presentation. Now it's time for Tomasz Mirowski from the Institute of Mineral and Energy Economy of the Polish Academy of Sciences. The floor is yours.
Well, good morning, ladies and gentlemen.
Dzień dobry Państwu.
Madam Chairman, Mr. Chairman, ladies and gentlemen. I'll be skipping some slides because of the time pressure, and I'll try to be brief. I'll be referring to other speakers and their presentations. The one about heat recovery, well, you need to generate heat first, and then prevent losses of the heat. And then there were some presentations about alternative fuels, RDF, about deployment of different renewable energy sources in the energy sector. And the topic that I have is another topic from related to households, and that is at the micro scale level. So here again we have the energy transformation and the issue of greenhouse gas reduction, and the issue of balancing greenhouse gases in the sector. So here, slowly but steadily, we are moving on to the initial balancing of sources.
Jest obszerna. Tu co prawda bardzo mało.
So this is quite a rich topic. So on my graphs, you can see the structure of primary energy generation from renewable energy sources. So that is based on our most recent report on energy. On the left graph you have Poland and the share of fossil fuels, 65%. So that's the highest share of primary energy in fuels, in the processed fuels, and in the EU fossil fuels, that's 40%. So this share in Poland, it's quite substantial. I think that it's going to change by 2025, by 2030, but we're unable to reduce it very much. And that is also because the stream of material which are used for generating such fossil fuels, well, that must be taken care of, because otherwise that will go to another stream, which may cause more difficulties when it comes to selective waste collection and energy generation. Also note the share in the structure of energy consumption in households. In case where per capita the energy media are our natural gas and the biomass, solid biomass. And here on this graph, the shares for Poland, the share for biomass is, for natural gas is nearly 20% per capita, and for solid biofuels is it's nearly 14%, and the EU, the shares are quite higher. So in Germany, for example, there will be nearly 40% the share of solid biofuels, and as for moving away from fossil fuels, we are increasing the share of natural gas for heat production and generation of hot water. And some countries with quite widespread gas distribution network, they're moving away from natural gas, and they try to avoid increasing the share of natural gas in households. Similarly, in Germany, permits are refused for houses heated or powered by fossil fuels. And I wanted to tell you more about CO2 emissions and consumption of biomass and natural gas. On this slide, you can see the CO2 emission per 1 kilowatt hour of generating heat in the central heating devices in households. So we have this demand for energy, depending on the type of buildings. We have these energy efficiency certificates prepared by heat energy efficiency surveyors and experts. So that is taken into consideration. We're assessing the CO2 emission. But for biomass, its emission is not zero, but we assume that it's that is like that. And then, when Poland is struggling with the issue of low emission and low effectiveness of heating devices, we can see then we have this Pure Air program. We have another program which is Stop the Smog. And there is a number of technologies that may receive subsidies, heat pumps, PVs. Well, do not entirely meet our expectations when it comes to the CO2 generation, because for heat pumps, the emission indicator is almost comparable to the heat boiler, heat boiler powered with the condensate, and we have that heat distribution network with a high CO2 share. And well, that may change when some energy comes from PV, and that PV generated energy powers the heat pump. Well, but it doesn't always work like that. We know that when we have the demand for heat, PV typically has the lowest generation capacity in such periods.
Oraz kotły wykorzystujące biomasę.
Gas boilers and biomass powered boilers. Well, they're characterized by very high efficiency technologies, and they're very often used and chosen by users for their operational capacity. So we have some capacities now.
Daje nam wymiana starego kotła na
We have all these parameters. They're very interesting. Like we have this comparison of parameters for an old style coal-powered boiler, and the parameters for state-of-the-art or modern heating capacity of a brand new boiler. Well, it all depends on how you calculate the CO2 emission, and we calculate heat losses in case of heat transmission along high distances.
W przypadku stosowania paliwa biomasowego w postaci
Using biomass fuel such as pellets, the emission percentage is different, and then we have the state-of-the-art boiler powered with that environmentally friendly pellets, where here parameters are even better. Then we have non-system heating generation. Nowadays, we can see quite intensive struggle of the system heating in Poland. It is ineffective. It has, well, the heating systems in Poland are ineffective in terms of their energy production, and that has a high impact on using or consumption of energy in households, in single-family units, multi-family houses. All these effectiveness parameters are taken into consideration when calculating the primary energy consumption coefficient.
roku bardzo zaostrzyły te standardy.
Conditions and technical requirements. The standards are quite strict, and nowadays it's quite difficult to build a house with such condensation standards without using other technologies. And here on this slide, you have non-system and system as non-system heating generation in Poland. 20% that's biomass, 50% that's coal.
GUS mówią o tym, że w Polsce spala się 10 milionów ton węgla. Nie wiem, może pan dyrektor mnie skoryguje, czy to jest...
Correct me if I'm wrong. So coal must be replaced with a different fuel.
W tym torcie najwięcej zajmie miejsca. Według moich analiz i
So from what I can see, and on the basis of my studies, comparing Poland to other countries, the part that was powered by oil and coal, well, that has been replaced by biomass. So the policies have changed, then been adjusted, readjusted.
I poluzowanie.
And we can see that there are more lags. So biomass, fossil fuels are still there. Now that's the statistics, where we are and what choices are made by the Poles when it comes to replacing old sources of heating at their homes. It's about replacing their old coal-powered boilers. You can see that the share of coal-powered boilers in total heat generation devices is quite substantial. So that is related to this clean air technology. And then coal boiler, they are still chosen by clients, and then condensate-powered boilers. They have the biggest share, the largest share in here. Well, ladies and gentlemen, I will skip this slide. Perhaps we could move on to the closing slide. And this is the concept of the circular economy. Well, I'm not going, and biomass generation, I'm not going to discuss it, but as you can see, this component is contained in here, in this new concept of circular economy. And my conclusions are that the green economy and the Green Deal and this effort at achieving climate neutrality, well, these are challenges that we're facing at the household level too, and we'll have to balance our CO2 emission. We have this energy poverty concept and biomass approach as the source of energy. So as a result of wood processing, etc. So that might be a solution which may partially meet the demand for green energy, which is climate neutral. So, and then we have a very high share of coal and natural gas in the system transformation. We need to exit the fuel. We need to abandon the strategy not only for environmental reasons, but also because of changing technologies.
Także ten postulat jest bardzo ważny i
This is an important demand. And for me, the concept of greenwashing, greening natural gas, well, I think that is going to help us to improve our, to reduce our carbon footprint in business. Also, end consumers will demand to green energy, green heating, and partially green natural gas. Thank you. I thank you all, dear panelists, dear speakers, for presenting us your topics. And I have this information from the organizers. It's been a tradition at each panel that awards are given for the most interesting contribution. So the most interesting contribution was Mr. Sobolewski's contribution.
Dziękuję bardzo. Gratuluję. Bardzo dziękuję. Mogę jedno...
Congratulations. May I say just one word? I thank you very much for this honorable mention, for this award. I think that we should be proudly announcing what we've achieved. I enjoy very much listening to this panel. So many years you were struggling to have that system. If you managed to implement it in other cities in Poland, well, I think that we appreciate that it took us so many years to get there. Thank you very much again. I'll see you later.
Szanowni Państwo, organizatorzy przewidzieli jeszcze jeden punkt programu w tym momencie w tejże auli, mianowicie rozdanie.
There will be announcing the results of the poster session. Thank you. Now it's time for a lunch break.
Konferencji. Jako przewodniczący jury będę miał przyjemność te wyniki ogłaszać. Pana doktora poproszę o pozostanie, ponieważ pan doktor Mirowski jako drugi członek jury również bardzo przyczynił się do wyboru. Proszę Państwa, sesja posterowa odbywa się już od dawna. Ja również kolejny rok jury przewodniczę. Z przyczyn pandemicznych ona stała się troszeczkę inna niż była. Przeprowadzana jest w formule online. W tym roku było posterów mniej niż kiedyś, bo zwykle było około 30, w tym roku było 13, co pozwoliło jury na rozwinięcie wysoce dużego i głębokiego zainteresowania poszczególnymi posterami i jury wybrało 5 najlepszych, a następnie w drugim etapie, zadając kolejne pytanie, będąc namolnym, wybrało najlepsze postery i przyznało pierwszą nagrodę, 2 nagrody drugie i 2 nagrody trzecie. Jeśli chodzi o nagrodę pierwszą, w tym muszę powiedzieć, że tutaj zgodność członków jury była po prostu jednoznaczna. Uznaliśmy, że najlepszy poster przygotowali pani magister inżynier Sylwia Gubernat, pan doktor inżynier Adam Masłon i pani doktor inżynier Joanna Czarnota pod kierownictwem naukowym pana profesora Piotra Koszelnika i poster dotyczył usuwania i odzysku fosforu ze ścieków jako elementu gospodarki o obiegu zamkniętym. Bardzo bym prosił autorów, jeśli są na sali, o odebranie nagród. Pani Sylwio, zapraszam.
I proszę jeszcze. Dziękuję bardzo.
Czy są inni autorzy? Dobrze, to może to zrobię. Proszę Państwa, w tym roku była znaczna przewaga posterów o charakterze technicznym, co spowodowało, że pan doktor miał ogromnie dużo pracy, ponieważ zasada jest taka, że w jury uczestniczy zawsze przedstawiciel nauk technicznych i nauk społecznych i w związku z tym przyznaliśmy 2 drugie miejsca. Pierwszy moment. I 2 postery zdobyły drugie miejsca. Zapraszam panią Darię Rzemieniak. Poster Postrzeganie bezpieczeństwa ekologicznego w wybranych grupach wiekowych. Ja właściwie dzisiaj ją widziałem już, natomiast nie wiem, dlaczego nie ma jej na sali. Proszę Państwa, pani przeprowadziła na poziomie pracy licencjackiej badania odnośnie postrzegania bezpieczeństwa w grupach wiekowych, badania empiryczne, co więcej takie, które nie miały, w których teza mogła być niepotwierdzona, bo jak wszyscy wiemy jako wykładowcy, najprościej zrobić takie badania, gdzie nie może nie być potwierdzenia tezy. Jury było tym bardzo zachwycone. Drugie, proszę Państwa, drugie miejsce otrzymali pani magister Magda Podgórska oraz pan magister inżynier Piotr Narloch. Metody oczyszczania biogazu do biometanu. Zapraszam. Gratuluję, bardzo ciekawy i prosimy Piotra nie ma?
Jest. No gdzieś na Auli, której siedzi.
To proszę Pani przekazać, dobrze? No i proszę Państwa, przyznaliśmy jeszcze dwa trzecie miejsca. Otrzymują je za poster Tygiel Kulturowa, a zarządzanie bezpieczeństwem produktu pani magister inżynier Joanna Małkowska i pani doktor Marzena Hajduk-Stermachowicz. Zapraszam pana inżyniera Stermachowicza, który odbierze w imieniu czcigodnej małżonki i pani Joanny. Gratulujemy serdecznie. To nie jest pierwszy student, a jest studentka pani doktor, która zdobywa nagrodę, więc gratuluję serdecznie. Gratulacje, proszę przekazać. Dziękuję bardzo. Proszę się jeszcze tutaj przygotować zdjęcia. Co będziemy zdejmować? Oraz zapraszam pana magistra inżyniera Pawła Kuta i panią doktor habilitowaną inżynier Katarzynę Pietrucha-Urbanik. Wykorzystanie oprogramowania symulacyjnego do projektowania instalacji fotowoltaicznych. Czy mamy autorów posteru na sali? Nie ma. To organizatorzy przekażą te nagrody. Później ja bardzo dziękuję. Muszę powiedzieć, że możliwość odbycia sesji posterowej online, zwłaszcza pierwszego etapu, jest znakomitym pomysłem, ponieważ żyjemy możliwość naprawdę zadawania pytań i poświęcenia bardzo odpowiedniej ilości czasu na każdy poster. Dziękuję bardzo.
System. Zmieniamy świat dla przyszłych pokoleń. Natura to skarb. Dbamy o środowisko. Podejmujemy działania, aby przyszłe pokolenia cieszyły się światem, jaki znamy. Niezbędna jest transformacja energetyczna i my jesteśmy jej częścią. W Centrum Badawczo-Rozwojowym tworzymy innowacje w skali świata. W naszej fabryce produkujemy ogniwa, moduły fotowoltaiczne, systemy mocowań, szyby z powłokami kwantowymi. Szyby, które świecą. Fotowoltaiczne żaluzje. Fotowoltaiczne fasady wentylowane. Fotowoltaiczne fasady. Fotowoltaiczne świetliki. Kolorowe moduły fotowoltaiczne. Rozwiązania Smart City. Dostarczamy kompletne rozwiązania systemów fotowoltaicznych zintegrowanych z budynkami. Szyby, które grzeją. Parapety, które grzeją i ładują. Szklane grzejniki. Szyby ze zmienną przeziernością. Chronimy zdrowie. Wirusobójcze przegrody szklane. UV-Box. COVID-detektor. Przyczyniamy się do ochrony planety i ograniczenia efektu cieplarnianego. ML System. Zmieniamy świat dla przyszłych pokoleń.
Sieć LTE 450 to niezawodna i bezpieczna, szerokopasmowa transmisja danych na potrzeby energetyki. To nowoczesne możliwości komunikacyjne, które możemy porównać do tych wykorzystywanych na smartfonie. LTE 450 umożliwia monitoring dużej liczby urządzeń, transmisję danych, przesłanie dokumentacji technicznej, map, zdjęć, obrazu wideo i komunikację głosową. LTE 450 to system wykorzystujący częstotliwość 450 MHz. Specjalne pasmo dedykowane sektorowi energetycznemu. To odejście od ograniczeń radiowych systemów wąskopasmowych na rzecz sieci wielousługowej LTE, gdzie pojemność sieci i zdolność transmisji danych jest nawet kilkaset razy wyższa. Jakie są główne korzyści sieci LTE 450? To podniesienie bezpieczeństwa poprzez efektywne wsparcie służb dystrybucyjnych w przypadku awarii, tak aby szybciej reagować i usuwać ich skutki. To zdalne zarządzanie infrastrukturą energetyczną w celu poprawy ciągłości dostaw energii, czy też zdalny odczyt liczników energii umożliwiający tworzenie lepszych taryf dla odbiorców. To wsparcie rozwoju odnawialnych źródeł energii, OZE. LTE 450. Nowoczesna technologia, bezpieczeństwo, niezawodność, przyszłość.
Od tysiącleci człowiek odkrywa świat oraz mechanizmy nim rządzące. Napędza nas pragnienie poszerzania wiedzy i lepszego zrozumienia świata. Potrzebna jest do tego odwaga, która pozwala nam docierać tam, gdzie nikt wcześniej nie dotarł. I odpowiedzialność, która sprawia, że naszą wiedzę wykorzystujemy dla wspólnego dobra. Podstawowym obszarem naszej działalności jest wydobycie gazu ziemnego, ropy naftowej oraz sprzedaż tych surowców. Jesteśmy liderem rynku gazu w Polsce, notowanym na GPW. Działamy globalnie. Stale poszerzamy wiedzę, prowadzimy badania i inwestujemy w nowe technologie. Ma to kluczowe znaczenie dla ekspansji i przyszłości naszego przedsiębiorstwa. Jesteśmy wiarygodnym i pewnym dostawcą dla naszych partnerów biznesowych i klientów. Gwarantujemy stałość dostaw i najwyższą jakość produktów. Zapewnia to naszym kontrahentom poczucie bezpieczeństwa i warunki stabilnego rozwoju. Strategia działania PGNiG opiera się przede wszystkim na poszukiwaniu i eksploatacji złóż znajdujących się na terenie kraju i za granicą. Dzięki temu Polska wzmacnia swoją niezależność energetyczną. Chcąc dywersyfikować źródła pozyskiwania surowców, importujemy gaz z rynków zagranicznych. Istotna część przyszłych dostaw będzie pochodzić z Ameryki Północnej. Poszukujemy i eksploatujemy złoża ropy naftowej i gazu ziemnego na norweskim szelfie kontynentalnym, a także w Pakistanie i innych częściach świata. Całość tych działań sprawia, że jesteśmy kluczowym gwarantem bezpieczeństwa energetycznego Polski. Gaz ziemny jest najlepszym rozwiązaniem dla każdego przedsiębiorstwa, które pragnie działać w zgodzie ze środowiskiem naturalnym. W Wykorzystując zasoby ukryte w naszej ziemi, troszczymy się jednocześnie o przyszłe pokolenia. Naszym celem jest ciągły rozwój i dostarczanie efektywnych rozwiązań energetycznych. To dzięki temu jesteśmy dzisiaj obecni niemal w każdym polskim domu. PGNiG. Odkrywamy przyjazną energię.
Energia elektryczna towarzyszy nam w każdej chwili życia. Za stały i bezpieczny przesył energii elektrycznej w całej Polsce oraz bilansowanie krajowego systemu elektroenergetycznego odpowiadają pracownicy polskich sieci elektroenergetycznych. Energii elektrycznej nie da się przechowywać, dlatego w każdej chwili należy produkować jej dokładnie tyle, ile zostanie zużyte. Oszacowanie zapotrzebowania na energię elektryczną i jej bilansowanie to jedno z najtrudniejszych i najważniejszych wyzwań, z którymi polskie sieci elektroenergetyczne mierzą się każdego dnia. Nasza sieć to ponad 14 600 km linii 220 i 400 kV. Wraz z dynamicznym wzrostem zapotrzebowania na energię elektryczną rozwijamy sieć elektroenergetyczną, by sprostać wyzwaniom nadchodzącym w kolejnych dziesięcioleciach. Przy wszystkich naszych inwestycjach minimalizujemy wpływ na środowisko naturalne i otoczenie. Wspieramy społeczności lokalne i naszych sąsiadów. W naszych prognozach dotyczących zapotrzebowania i popytu uwzględniamy zmiany zachodzące na rynku energii. Wyprzedzamy je, aby zapewnić bezpieczeństwo energetyczne naszego kraju. Bierzemy aktywny udział w transformacji energetycznej Europy. Jesteśmy częścią jednolitego, zintegrowanego europejskiego rynku energii elektrycznej. Krajowy system elektroenergetyczny jest szczególnie ważny dla bezpieczeństwa państwa. Dlatego przykładamy ogromną wagę do fizycznej ochrony naszej infrastruktury i cyberbezpieczeństwa systemów. Polskie sieci elektroenergetyczne realnie wpływają na polską gospodarkę. Polskie sieci elektroenergetyczne. Energia w dobrych rękach.
Życie to energia. Być może nie zastanawiałeś się, skąd się bierze, jaką drogę musi przebyć. Ale dzięki nam masz pewność, że zawsze będzie tam, gdzie jej potrzebujesz. Już od ponad 15 lat Gaz-System zarządza siecią przesyłową w Polsce. Zapewniamy bezpieczeństwo i ciągłość dostaw. Co roku przesyłamy miliardy metrów sześciennych gazu. Stale rozwijamy się, budując tysiące kilometrów nowych gazociągów. Współtworzymy zintegrowane systemy przesyłowe w Europie, dzięki takim projektom jak dwukierunkowy gazociąg łączący Polskę i Danię, korytarz północ-południe czy interkonektory. Będąc filarem bezpieczeństwa energetycznego kraju i regionu, rozwijamy inwestycje umożliwiające dostawy gazu z nowych źródeł i kierunków. Rozbudowujemy terminal LNG w Świnoujściu. Jesteśmy też odpowiedzialni za powstanie terminalu pływającego w Zatoce Gdańskiej. Zatrudniamy ponad 3000 pracowników, których łączy pasja i profesjonalizm w dostarczaniu czystej, konkurencyjnej cenowo i stabilnej energii. Dążymy do zrównoważonego rozwoju, wspierając lokalne społeczności i chroniąc środowisko. A ponad wszystko zmieniamy oblicze polskiego gazownictwa oraz integrujemy rynek gazu w Europie. Gaz-System. System, który łączy.
Gazownictwa to największa spółka grupy kapitałowej PGNiG. Jako narodowy operator systemu dystrybucyjnego i europejski lider tej branży, przez prawie 200 000 kilometrów gazociągów codziennie dostarczamy gaz do ponad 7 milionów odbiorców. Stale czuwamy nad bezpieczeństwem i ciągłością jego dostaw. Chcemy, by z błękitnego paliwa korzystało jeszcze więcej mieszkańców Polski. Dlatego realizujemy strategiczny program rozbudowy infrastruktury dystrybucyjnej.
Inwestujemy w tworzenie nowych gazociągów, rozwijamy nowoczesne technologie i podnosimy efektywność podejmowanych działań.
Stawiamy także na gazyfikację wyspową. Dzięki stacjom regazyfikacji skroplonego gazu LNG zapewniamy szybki i bezpieczny dostęp do tego paliwa tam, gdzie go wcześniej nie było. Dzięki naszym działaniom wzrasta liczba odbiorców gazu, a proces przyłączenia do sieci dystrybucyjnej PSG jest łatwiejszy niż kiedykolwiek wcześniej.
Wystarczy zgłosić się do jednego z prawie 200 miejsc obsługi klienta w całym kraju lub skorzystać z internetowego portalu przyłączeniowego.
Polska Spółka Gazownictwa. Dostarczamy paliwo gazowe w sposób ciągły, bezpieczny, z poszanowaniem środowiska naturalnego. Polska Spółka Gazownictwa. Wybieram gaz.
Energy gives power. Telecommunications gives connections. Banking gives stability. Big data gives knowledge. Smart city gives new possibilities. Healthcare gives strength. Insurance gives safety. Administration gives support. Defense gives security. IT gives freedom. ASECO. Technology for business, solutions for people.
partner biznesowy dla firm, które chcą się rozwijać w innowacyjnych branżach. Firm, które szukają finansowania lub terenów inwestycyjnych w specjalnych strefach ekonomicznych. ARP udziela pożyczek na finansowanie inwestycji i kapitału obrotowego, realizację kontraktów, wdrożenie działań zwiększających efektywność prowadzonej działalności gospodarczej oraz na restrukturyzację. ARP udostępnia przedsiębiorcom swoją ofertę finansową w centrach obsługi przedsiębiorców. W dniu obchodów 30-lecia spółki ARP otworzyła 7. Centrum Obsługi Przedsiębiorców w Warszawie. Agencji Rozwoju Przemysłu bliskie są innowacje. Sieć otwartych innowacji. Jest to program grantowy, w ramach którego firmy mogą ubiegać się o grant na zakup licencji lub prawa własności do innowacyjnej technologii. ARP skutecznie ratuje od upadku firmy ważne dla polskiej gospodarki i społeczeństwa. Wdraża i realizuje program restrukturyzacji, który prowadzi do powrotu na ścieżkę rozwoju. Agencja Rozwoju Przemysłu zarządza 2 specjalnymi strefami ekonomicznymi, w ramach których utworzyła 3 europarki: Mielec, Wisłosan oraz Kobierzyce. ARP to partner biznesowy dla firm. Zapraszamy do współpracy.
System. Zmieniamy świat dla przyszłych pokoleń. Natura to skarb. Dbamy o środowisko. Podejmujemy działania, aby przyszłe pokolenia cieszyły się światem, jaki znamy. Niezbędna jest transformacja energetyczna i my jesteśmy jej częścią. W Centrum Badawczo-Rozwojowym tworzymy innowacje w skali świata. W naszej fabryce produkujemy ogniwa, moduły fotowoltaiczne, systemy mocowań, szyby z powłokami kwantowymi. Szyby, które świecą. Fotowoltaiczne żaluzje. Fotowoltaiczne fasady wentylowane. Fotowoltaiczne fasady. Fotowoltaiczne świetliki. Kolorowe moduły fotowoltaiczne. Rozwiązania Smart City. Dostarczamy kompletne rozwiązania systemów fotowoltaicznych zintegrowanych z budynkami. Szyby, które grzeją. Parapety, które grzeją i ładują. Szklane grzejniki. Szyby ze zmienną przeziernością. Chronimy zdrowie. Wirusobójcze przegrody szklane. UV-Box. COVID-detektor. Przyczyniamy się do ochrony planety i ograniczenia efektu cieplarnianego. ML System. Zmieniamy świat dla przyszłych pokoleń.
Sieć LTE 450 to niezawodna i bezpieczna, szerokopasmowa transmisja danych na potrzeby energetyki. To nowoczesne możliwości komunikacyjne, które możemy porównać do tych wykorzystywanych na smartfonie. LTE 450 umożliwia monitoring dużej liczby urządzeń, transmisję danych, przesłanie dokumentacji technicznej, map, zdjęć, obrazu wideo i komunikację głosową. LTE 450 to system wykorzystujący częstotliwość 450 MHz. Specjalne pasmo dedykowane sektorowi energetycznemu. To odejście od ograniczeń radiowych systemów wąskopasmowych na rzecz sieci wielousługowej LTE, gdzie pojemność sieci i zdolność transmisji danych jest nawet kilkaset razy wyższa. Jakie są główne korzyści sieci LTE 450? To podniesienie bezpieczeństwa poprzez efektywne wsparcie służb dystrybucyjnych w przypadku awarii, tak aby szybciej reagować i usuwać ich skutki. To zdalne zarządzanie infrastrukturą energetyczną w celu poprawy ciągłości dostaw energii, czy też zdalny odczyt liczników energii umożliwiający tworzenie lepszych taryf dla odbiorców. To wsparcie rozwoju odnawialnych źródeł energii, OZE. LTE 450. Nowoczesna technologia, bezpieczeństwo, niezawodność, przyszłość.
Od tysiącleci człowiek odkrywa świat oraz mechanizmy nim rządzące. Napędza nas pragnienie poszerzania wiedzy i lepszego zrozumienia świata. Potrzebna jest do tego odwaga, która pozwala nam docierać tam, gdzie nikt wcześniej nie dotarł. I odpowiedzialność, która sprawia, że naszą wiedzę wykorzystujemy dla wspólnego dobra. Podstawowym obszarem naszej działalności jest wydobycie gazu ziemnego, ropy naftowej oraz sprzedaż tych surowców. Jesteśmy liderem rynku gazu w Polsce, notowanym na GPW. Działamy globalnie. Stale poszerzamy wiedzę, prowadzimy badania i inwestujemy w nowe technologie. Ma to kluczowe znaczenie dla ekspansji i przyszłości naszego przedsiębiorstwa. Jesteśmy wiarygodnym i pewnym dostawcą dla naszych partnerów biznesowych i klientów. Gwarantujemy stałość dostaw i najwyższą jakość produktów. Zapewnia to naszym kontrahentom poczucie bezpieczeństwa i warunki stabilnego rozwoju. Strategia działania PGNiG opiera się przede wszystkim na poszukiwaniu i eksploatacji złóż znajdujących się na terenie kraju i za granicą. Dzięki temu Polska wzmacnia swoją niezależność energetyczną. Chcąc dywersyfikować źródła pozyskiwania surowców, importujemy gaz z rynków zagranicznych. Istotna część przyszłych dostaw będzie pochodzić z Ameryki Północnej. Poszukujemy i eksploatujemy złoża ropy naftowej i gazu ziemnego na norweskim szelfie kontynentalnym, a także w Pakistanie i innych częściach świata. Całość tych działań sprawia, że jesteśmy kluczowym gwarantem bezpieczeństwa energetycznego Polski. Gaz ziemny jest najlepszym rozwiązaniem dla każdego przedsiębiorstwa, które pragnie działać w zgodzie ze środowiskiem naturalnym. Wykorzystując zasoby ukryte w naszej ziemi, troszczymy się jednocześnie o przyszłe pokolenia. Naszym celem jest ciągły rozwój i dostarczanie efektywnych rozwiązań energetycznych. To dzięki temu jesteśmy dzisiaj obecni niemal w każdym polskim domu. PGNiG. Odkrywamy przyjazną energię.
Energia elektryczna towarzyszy nam w każdej chwili życia. Za stały i bezpieczny przesył energii elektrycznej w całej Polsce oraz bilansowanie krajowego systemu elektroenergetycznego odpowiadają pracownicy polskich sieci elektroenergetycznych. Energii elektrycznej nie da się przechowywać, dlatego w każdej chwili należy produkować jej dokładnie tyle, ile zostanie zużyte. Oszacowanie zapotrzebowania na energię elektryczną i jej bilansowanie to jedno z najtrudniejszych i najważniejszych wyzwań, z którymi polskie sieci elektroenergetyczne mierzą się każdego dnia. Nasza sieć to ponad 14 600 km linii 220 i 400 kV. Wraz z dynamicznym wzrostem zapotrzebowania na energię elektryczną rozwijamy sieć elektroenergetyczną, by sprostać wyzwaniom nadchodzącym w kolejnych dziesięcioleciach. Przy wszystkich naszych inwestycjach minimalizujemy wpływ na środowisko naturalne i otoczenie. Wspieramy społeczności lokalne i naszych sąsiadów. W naszych prognozach dotyczących zapotrzebowania i popytu uwzględniamy zmiany zachodzące na rynku energii. Wyprzedzamy je, aby zapewnić bezpieczeństwo energetyczne naszego kraju. Bierzemy aktywny udział w transformacji energetycznej Europy. Jesteśmy częścią jednolitego, zintegrowanego europejskiego rynku energii elektrycznej. Krajowy system elektroenergetyczny jest szczególnie ważny dla bezpieczeństwa państwa. Dlatego przykładamy ogromną wagę do fizycznej ochrony naszej infrastruktury i cyberbezpieczeństwa systemów. Polskie sieci elektroenergetyczne realnie wpływają na polską gospodarkę. Polskie sieci elektroenergetyczne. Energia w dobrych rękach.
Życie to energia. Być może nie zastanawiałeś się, skąd się bierze, jaką drogę musi przebyć, ale dzięki nam masz pewność, że zawsze będzie tam, gdzie jej potrzebujesz. Już od ponad 15 lat Gaz-System zarządza siecią przesyłową w Polsce. Zapewniamy bezpieczeństwo i ciągłość dostaw. Co roku przesyłamy miliardy metrów sześciennych gazu. Stale rozwijamy się, budując tysiące kilometrów nowych gazociągów. Współtworzymy zintegrowane systemy przesyłowe w Europie, dzięki takim projektom jak dwukierunkowy gazociąg łączący Polskę i Danię, korytarz północ-południe czy interkonektory. Będąc filarem bezpieczeństwa energetycznego kraju i regionu, rozwijamy inwestycje umożliwiające dostawy gazu z nowych źródeł i kierunków. Rozbudowujemy terminal LNG w Świnoujściu. Jesteśmy też odpowiedzialni za powstanie terminalu pływającego w Zatoce Gdańskiej. Zatrudniamy ponad 3000 pracowników, których łączy pasja i profesjonalizm w dostarczaniu czystej, konkurencyjnej cenowo i stabilnej energii. Dążymy do zrównoważonego rozwoju, wspierając lokalne społeczności i chroniąc środowisko. A ponad wszystko zmieniamy oblicze polskiego gazownictwa oraz integrujemy rynek gazu w Europie. Gas System. System, który łączy.
Dzień dobry Państwu. Miło mi.
Good afternoon, ladies and gentlemen. It is my pleasure to welcome you back to the next panel, which is going to focus on the Baltic Sea related issues, obviously in the context of energy and also in the context of critical energy infrastructure challenges and threats. So let me welcome all the panelists. Witold Skomra from the Department of Critical Infrastructure Protection at the Government Security Center. There is also Professor Piotr Mickiewicz from the University of Gdańsk. Professor Mariusz Ruszel from Technical University of Rzeszów, as well as Spiritus Movens, the father of the whole idea of the conference. Many thanks for that. Then Maciej Krzesiński, Director for Marketing and International Cooperation from the Port of Gdynia Authority.
Dołączą do nas również, właściwie już dołączyli, tak?
There are also
pan prezes zarządu Lotos Petro Baltic,
President of the Management Board of Lotos Petro Baltic, Grzegorz Strzelczyk, and Michał Piekarski, PhD, University of Wrocław, representing the Polish Society of Sciences on Security. I'm sure it will be a highly interesting panel, yet because you have a look at the watch, you can see we are delayed, so I have to inform you that I'm going to stick to time limits. There are 6 panelists, topics are very broad, but I believe it is a good practice to leave at least a few minutes for Q&A. So perhaps it is a good idea to make 6 minutes of introduction, up to 7. If you can do it in a shorter time, it would be absolutely great, because from minute number 8, I'm going to give signals that you are supposed to wrap it up. So the first speaker will be Director Witold Skomra. We've been talking before the panel, so I guess that a good starting point will be EU legislation and the context connected with a notion of resilience. Quite a fashionable notion recently, so the floor is yours. Thank you very much indeed. Ladies and gentlemen, we often use the notions like risk, security, safety, without thinking, especially with the risk, whose risk it is and what is at risk. With security, we are not defining what kind of security we refer to. Security associated is usually associated with physical safety. Nowadays, the dominant threats are cyber attacks, and now this physical security is less adequate or less problematic. So in a nutshell, the most important ideas, the most important legislative activities nowadays. In the European Commission, there are two directives in the pipeline. They are interconnected actually with each other. One of them is NIS2 about cybersecurity, and in parallel there is a directive, Critical Entities Resilience, which is about improving resilience of managing entities. Managing what? There is a hot debate how to bring some order into it. What's the sequence? As for the first step, everyone agrees we have to protect services, not facilities. So the point is that, well, we want to have electrical power in our sockets. That is definitely to be protected. Then the second stage is more difficult to define, but the dominant opinion is that after we select key services, the second step would be to define the infrastructure absolutely necessary to maintain critical services. And only in the third step, we have to point at the entities which are responsible for maintaining the infrastructure. And then the other element, also of importance. Now risk is not really a likelihood times result. No, we are talking about increasing resilience or eliminating vulnerabilities. The point is that nowadays we cannot account for all the causes for threats, but we can improve general resilience of the environment in which a given threat may be disseminated. So it is the end of thinking, all right, we are going to catch all the thieves. We are beginning an approach, you need solid door. And it doesn't really matter then how often your home is visited by a thief or a burglar. So resilience is a broader notion, that's obvious. It is not only about physical security, because as the moderator has mentioned, we have three strategies. We may be so resilient that we will withstand the attack. We may be so flexible that even if we are thrown off the balance, we'll go back to our initial condition, or we can adapt. And that's what is happening in the energy sector. Since we cannot maintain the current system of organization, the current solutions, technological solutions which are now in place, we cannot fight it. We have to adapt to the future state. So adaptation as the third way of building resilience. And around these three notions, resilience, flexibility, adaptation, works in the European Commission are focused on these three notions. Works on safety, oriented on preserving key services. There is one more element, quite recent, threats resulting from interdependence of the systems of entities, a very important element that we need to add to the standards notions connected with security. So to technological security, continuity of operations, and so on and so forth, there are interdependencies. And yesterday we talked about offshore and underwater infrastructure, ships, ports, installation ports. All these elements are interconnected, so each element influences every other element, and if one element is out, it may lead to the loss of a service, and the service, maintaining a service, is our priority, not really the facilities but services, because facilities are needed to maintain the service, but the service is the priority. So that's the picture. If I may, perhaps I will ask an additional question, because I guess it is a highly interesting topic, because these three strategic approaches, I don't know whether we can call them autonomous strategies, so resilience, flexibility and adaptation, because the environment is very complex. As you have mentioned, there are there is lack of autonomous systems, there is interconnectivity between many systems. So the question is, or a request, could you comment on that? Namely, can we really precisely define and diagnose the reality? Or are we capable of adequately, in a complex way, of defining all these interdependencies? Because in political sciences, for some time now, it is mentioned that unpredictability and lack of precise definition or a certain degree of chaos is what is typical of modern times. So would you say that the diagnosis is complete, or the strategies that you are preparing leave like a certain room for things we don't really know yet? Well, philosophically speaking, we can say that if we prepare protection against threats very well, protection against future threats is also important, because we can't foresee and diagnose future threats sometimes, but still we have to handle their consequences. Technologically speaking, it is possible, because the COVID is an excellent example. Very fast we could see interconnections between companies, and for example we realized that the oxygen supplies will be critical for the system of healthcare on the 15th of March. So before even anyone realized how important it is, we were aware of that on the basis of experiences from other countries. And then we turned to operators of critical infrastructure to capture the entities that they depend on. Unfortunately, the result of this inquiry exceeded my expectations, because 128 operators pointed at 5,000 other entities that they depend on. When I started to verify that, they exaggerated a little bit, because the companies that ended up on this list had some reliefs in the labor law due to the COVID. So, for example, they could exceed over time, they could withdraw a person from their paid leave. So they added some companies to the list. Operators added some not really that necessary companies to the list. So these were not precisely the most important interdependent companies, but operators can point the entities on which they depend, and some of them expect that key providers will be included in governmental regulations. They will enter some lists of facilities which are subject of obligatory protection, or indexes or lists of critical infrastructure. So there is awareness among operators, but it will be a lengthy process, obviously. Ladies and gentlemen, let us move on to the second panelist, who is an eminent expert on various aspects connected with the Russian Federation. More than that, yet it would be unacceptable for us not to take full advantage of such a great expert and his knowledge. So now it's time for Professor Piotr Mickiewicz to take the floor, and he will tell us more, well, unfortunately, in a nutshell, but he will tell us about main strategies or main elements of strategies of the Russian Federation in the context of the Baltic Sea, and also in the context of the energy policy.
Good afternoon, ladies and gentlemen. Well, this task is not an easy one. Well, actually, this is like an equation with two unknown factors. Looking from the point of view of the Russian policy, we have three flag documents on the energy policy. So this is the strategy for economic safety of the Russian Federation, the doctrine, and the most recent energy strategy. And they show that, at least to my knowledge, for the fourth or the fifth time, the Russians want to turn the fuel sector into the locomotives, the pulling train of the entire economy. And then if we look at all the assumptions and all the key concepts underlying the program, we could build the whole plan here. And the variables I'm talking about are, first, the situation where the significant part of the development process is including two energy companies, which is Gazprom with its satellites and Rosatom companies. As a result of the COVID volatility, in the light of the Russian policy and building the energy resistance, which they nicely describe as reasonable energy policy, I would say that Gazprom is the key element here. So they basically use the same money to build inside and outside, and this is a paradox. External investment is financed by state loans, so such investment is less expensive. Then we have this Gazprom context. Perhaps I would need to use some statistical data here, but I don't think I need to quote all the data here. They're available in English, they're available in Polish. So I don't think that we need to use these figures right now. So Gazprom survived all the serious financial disruptions through its very unusual policy towards Europe, and that would be suspending gas supply, etc., etc. The main developmental factor will be changed in such a way that most pre-environmental investment will be stopped. Then we have land transport, maritime transport, and that will be connected to expand on the Russian Federation's export capacities. And here we had it in the Western Siberia and St. Petersburg. So the key plans for the region, they were based on the doctoral thesis of the the president of the Russian Federation, and it assumes a concept, and that assumes the expansion of the system for expanding and processing fossil fuels, and combining that with a transportation and shipping system. So Russians understand it as sustainable export growth, and internally we're talking about higher resistance energy resistance, and in this case we have this very important component when it comes to avoiding excessive energy generation. So how would that translate, or what impact does it have on the Baltic region? From the economic point of view, I would say that the impact is not huge. From the political point of view, that is a serious challenge, because once Nord Stream 2 is launched, and once the transportation system from Central Siberia is launched, and then we have the maritime the sea transport, maritime transport system. There will be no longer this need to use handling terminals for energy carriers from the Bay of Finland. Well, I think that I will hear in a moment that there will be a container transport, etc., etc. But basically, there is this whole array of political impacts on the system of safe cargo transport on the Baltic. So I've been talking about it for years. So we have this concept, defense concept, expanded Russian defense concept, which is going to include the Skagerrak Bay, and that is related to the disruptions in transporting liquid gas to the gas port in Świnoujście. And we should be talking a lot about protecting our offshore wind farms on the Baltic. Yesterday we learned and confirmed what we know, that our offshore wind turbines will be located mainly on the Baltic Sea coast, so we should protect these farms against sabotage, against submarine sabotage. So I don't think we're going to see any sabotage actions from the surface level. This is a paradox that Russians transferring the way from the transportation of fuel carriers, they have additional means of political impact on production systems to produce energy and energy supplies in the area of Baltic, and that affects Poland too. Thank you. Perhaps I should clarify that, but in the context of the next panelist, that exchange of smiles between professor and doctor here, they come from the fact that they're both gentlemen. They have their hearts. They left their hearts in a city over the Baltic Sea. That was a slip of a tongue. So now, over to Professor Mariusz Ruszel. But then Professor Mickiewicz was talking about potential closing of the window in Baltic Straits. Well, I think that now is the opportunity to request that Mr. Ruszel tells us about concepts related to V4, the Visegrad group, and in this group, Poland, in a certain to a certain dimension, is a maritime state. Then, so since the group consists of Hungary, Czech, and well, these countries, they attempt at being sea countries, maritime countries.
Professor Mariusz Ruszel z pewnością.
That Professor Mariusz Ruszel will tell us more about all these aspects. Professor, the floor is yours.
Drodzy Państwo, tak nawiązując do pytania.
Thank you very much. The Baltic Sea is a window to the world for the V4 countries, especially from the perspective of the gas system. Obviously, it has some infrastructural limitations, because if you look at it, All four countries of the Visegrad Group consume about 42 billion cubic meters of gas a year. 2 states out of 4 and Hungary have their own extraction, which to some extent covers the current demand. For Poland, it is 4 billion cubic meters. For Hungary, it is about 2 billion cubic meters. So these countries have depended heavily, all 4 of them have depended heavily on supplies from the Russian Federation. And if we look at the logical structure taking place there after the Second World War, it was the gas pipeline infrastructure was developed in such a way that the gas was to flow from the east to the west. So there was a certain dependence of Central Europe on eastern supplies. And now if we look at the Baltic Sea as an opportunity that could change that, what kind of assets do we have? We have LNG terminal, Świnoujście, 7.5 billion cubic meters. It can be developed up to 10, and there is the Baltic pipe, another 10 billion cubic meters. So in total, about 20. If you add to that floating LNG, about 4 billion cubic meters, more or less it is 24 billion cubic meters. There is Polish and Hungarian own extraction, so in total it is like 30 billion cubic meters. People may say that's a lot, because it gives us a certain potential of satisfying not only our internal need in Poland, about 19 billion cubic meters, but it gives a certain opportunity for export of gas to adjacent countries. But if we look at the assumptions of the gas system and the fact that under energy transition it is mentioned that gas will be a transitory fuel and Poland is to consume 34 billion cubic meters of gas, there is a simple question. Would you say that the infrastructure that we have will be sufficient for the Visegrad Group countries, or perhaps it is just a projection? Which will actually provide Poland in current gas supplies and future gas supplies when we need more of that. So that's one issue I wanted to highlight, and then the other one. Poland is coming to an end of the Jamal contract. For the Czech Republic it's a bit longer, for Slovakia it is by 2028. So these are long-term contracts with Gazprom, so any kind of export of gas further on through the Baltic Sea to other states of the Visegrad Group will be extremely expensive. Secondly, there is a very limited debate also among the experts about the following, that theoretically we have a single gas market, a single energy market in the EU, but on the other hand, there is contracting capacity for gas interconnectors. Let me give you an example. Between Germany and Czechia, in White House, there is interconnector which is contracted for 100% of capacity by 2035. So, what kind of market are we discussing if one company has a monopoly on the interconnector? And such interconnectors within the Visegrad Group, if you look at the borders of these states, are much more numerous. And that is why even now we can identify the entities, including Gazprom, which contracted these gas capacities, and the situation will not be that rosy. What may happen under joint projects like North-South Corridor, namely, if we complete our own infrastructure in the Baltic Sea, if we develop interconnectors towards the Czech Republic and Slovakia, then theoretically we can give a certain political potential to our neighbors when they are going to renegotiate. But a simple question, do they want that? We may want that, do they? Would you say that Hungary wants that, the Czech Republic wants that? What about the Czech? Do they want that? We don't have simple, clear answers, especially if you compare the price of gas. I did a study 2 years ago. I checked the price of gas in Hungary for the last 5 years, then in Slovakia, Czech Republic and Poland. And Hungary has the lowest price for gas since 2016 out of all V4 groups. Countries for households and the industry. Why? It is not due to economic reasons, it is due to political reasons, and there is full dependence on the Russian Federation. And a question arises whether our neighbors will be willing to make political decisions which will have an impact on a certain risk of changing prices of gas for them, because it may mean that it will change competitiveness of other economic sectors, which depend on gas and on gas prices. And the next question, what may make our neighbors to make such political decisions? Theoretically speaking, a bigger military involvement of NATO, perhaps military contracts, or maybe strengthening the Baltic Sea by autonomous systems and integration of the energy sector with the military sector. Thank you very much indeed, Professor. And, well, yes, you've asked important questions. Professor Ruschel has delineated a certain time frame within which we will have to think about that within V4 countries. So perhaps a remark from me, it would seem that several years is a long time perspective, a few or more than that, but the complexity of the situation and the significance of the issue, well, if we think about that, I have to say we are looking forward to all these answers. Now let us move on to other topics. Now I'm focusing on my agenda very much. Now it's over to Director of the Port of Gdynia Authority. Maciej Krzesiński will be our next speaker. Could you... Well, I know you'd like to, but I also want to ask you to tell us more about wind farms in connection with your city and energy policy in general. I'm sure it will be an excellent supplementation of all the contributions that we have heard so far. I'm also looking at our online guests, or not really guests, but co-panelists. So, Director, now over to you, the floor is yours. So perhaps in a nutshell, let me talk about ports. I don't want to talk about Gdynia only, because here I feel like a representative of ports, Polish ports in general. You have to bear in mind that we have 3 ports of greatest significance for Poland, but there are also minor ports that can be taken advantage of. And I have to say that Polish ports are not only about wind energy, because we are important players on the raw materials market, which flows through Polish ports with a wide stream. There is petroleum ports, and there is Szczecin, Świnoujście, fuels, then gas, various formulas, LNG in Świnoujście, in Gdańsk. There will be a similar situation very soon. Very soon, maybe I'm too optimistic, but it will happen in Gdynia. There is transshipment of LPG, which has a great significance for the economy. So, as for raw materials, and various energy carriers are quite numerous. They are transshipped in Polish ports. These are millions of tons a year. And I think we are an important location, or important point on the Polish map. And not only an energy carrier comes through that, it is also important for the European Union, including the Visegrad Group countries, because think about the fuel. The fuel coming through the Gdynia terminal, serviced by PERN, it goes further on to the Czech Republic, mostly. So these are like examples, one of many. In the context of wind farms, yes, that's a huge challenge ahead of us. Ports have to be treated as a certain element of a very complex structure that needs to arise, actually, needs to be created, and we want to look at the ports as part of a certain whole, not only a single most important item, because sometimes I think that many depends on the port. The port is so important. If it is not there, what will happen? Well, the Polish offshore can be built without the installation port in Poland. Well, but if it happened, it would be about huge losses for us. So it is definitely in our interest, well, justified interest, even though installation port erection. And in the next several years, there will be more ports like that. I can see at least the potential for two, looking at the location of Polish farms and, in general, all the wind farms in the Baltic Sea, because location and distances between potential wind farms and the installation ports, this distance really matters, so it will simply shift. I'm hoping for Polish ports to be able to provide services for other wind farms and wind projects, including those in other countries like the Baltic states. And if we have well-prepared infrastructure, we'll be able to safeguard the possibility of building wind farms also in Baltic states. Let me go back now to something else. A port is a port. We can build it, we will build it. But there is another issue rarely discussed and connected with security. Because building the port is one matter, but protecting the port, protecting the infrastructure, protecting of what we build, protecting of and providing services of the elements which will be erected offshore. It is a huge topic, and I will fully agree with professors here. I guess it is neglected or underestimated, and this topic will have to be developed. I hope we'll perhaps come up with some conclusions during our discussion. Ports are getting more and more active, not only the big ones, the smaller ones as well, the yacht ports as well, and it poses many challenges in designing and construction of ports, but later on in maintenance and operations of the ports. Many thanks. And now our next panelist, ladies and gentlemen, is president of the management board of Lotos Petro Baltic, and it is Grzegorz Strzelczyk. So I'm not going to pretend, well, perhaps I should say in a very straightforward way. I was asking what Mr. Strzelczyk is going to talk about, so perhaps without further ado, I will introduce the next speaker. Well, there were some topical suggestions, but they were quite numerous. I don't want to lead to any chaos. So I guess over to you, your contribution, your opinions, especially Lotos Petro Baltic is an entity which is extremely experienced if it comes to issues related to the Baltic Sea. So I guess you are the best person to talk about the pertinent subject matter.
Bardzo proszę.
Dziękuję bardzo za zaproszenie. Dzień dobry Państwu, witam serdecznie.
Thank you very much for invitation. We are the oldest operators of the Polish economic zone operating in the Polish offshore. We're an oil and gas company. We've just celebrated our 30th anniversary. So since 1990, we've been operating under our own brand as Lotos Petro Baltic. We're exploiting oil and natural gas that comes with it. And as a company, I believe that we might reach a statement that we are a critical infrastructure ourselves. And the key thing in our business, in our company, is safety of people, and then safe environment. What we do is, what we do poses a considerable risk for the natural environment. So I must say that we're interested in building the strong door to prevent our risks from going outside, we understand that safety and security is important, but technology is one thing. From the direction of Kaliningrad come the highest risk for the infrastructure in the period of the past 4-5 years. There have been some incidents, and they are the source of hazards at our concessions. So whatever is happening on the sea, it's easy to control. We work there on an ongoing basis, and we have the strong support of our security forces. We operate in protected zones, so everything which happens on the surface is predictable. But I agree with Professor that the biggest risks come are submarine risks, risks to the exploitation systems. And I think that the surface is responsible for maritime security, and especially in the Navy, we have these risks, and this is something that we should focus on. Then the next challenge are sea wind waves, sea wind farms. So their construction, underwater transmission lines, etc., that has to be watched carefully in terms of safety. And here again, we deal with threats which are under the water, under the sea surface. Then we have the third element, which we hasn't mentioned yet. The Baltic pipeline reached the Polish border. That's the pipeline to the Polish territorial waters, to the Polish shore, and that will be certainly be the focus point of attention of our security forces. So that was my introduction, and I subscribe to Professor's view that what's underwater is very important. Sir, thank you so much. I must say that I agree quite often with Professor Mickiewicz, and our last panelist, Dr. Piekarski, PhD. He represents the University of Warsaw and the Polish Society for Security Sciences. He also suggested that he would like to dwell on aspects of Baltic security in the energy-related aspect. Well, safety and security, we are aware that nowadays this is a phenomenon which is omnipresent. So, sir, perhaps you could at least, because of lack of time, could you please at least give us a sketch or a very brief catalog of hazards, risks, and challenges in this area, and that is going to be a perfect recap of what we heard. Well, good afternoon. When it comes to the catalog of threats, catalog of hazards, let me use again this metaphor of the door. So considering the current geopolitical situation and current energy security risks, the key risk and susceptibility is critical infrastructure and energy infrastructure. So it's Baltic pipe, wind farms, wind turbines, the floating terminal in the Gdańsk, in the Bay of Gdańsk. So there might be a hypothetical organization of those who feel deprived and who are sponsored by superpowers, say Russia, and that may cause damage to the infrastructure as such and will cause operational disruption. It's like what happens if we have this explosion on the route from Świnoujście to Szczecin? And what would be the response? Imagine that we have such an attack 30 years ago. It would be easy to say because that was the state entity because of the measures used. But nowadays there are so very many unmanned devices, and one can easily imagine that some terrorists, they stole or developed such a submarine device. And these phenomena may also surface and emerge during crisis where the demand for energy is the highest. So, say a political crisis in Baltic states, Belarus, etc., combined with a situation when there is a power failure or shortage of gas supplies. So we can easily say that we can buy. So we could, in such situation, we might not be able to buy gas from abroad. And these are external risks. And there are also some internal risks. And let me go back to this metaphor of the door again. So the door is a patched structure of weaker and stronger parts. Let us look at the regulations. What type of law should be applied when there is an explosion or an attempt at explosion on the Baltic Sea? So would the law on protecting the right of sailing on the Baltic, on perhaps an anti-terrorist legislation should take over and have the priority? Then we have resources which are distributed in terms of quantity and quality. We have so many services responsible for maritime security. It's the border guard, then we have some military units. And when we speak about maritime security from the military point of view, way back, it was the Navy with its vessels and aircraft and coastal defense that could be used. Nowadays, vessels are in the Navy, and then we have some coastal defense system with the Navy, but then aircrafts are in the military aircraft command. So we have this dispersion, fragmentation, or distribution of resources, and in crisis, that might be this critical factor. So when we speak about responding, when we speak about acting here, well, we need to think about the internal risks. we need to tackle our internal risks first, because they affect external risks. So we had that issue on one of our conferences. So these resources, well, the door should be made solid when we think about the cost, when we are talking about maritime security. In particular, when we talk about the infrastructure, which is submarine infrastructure, the measures, well, they contain whatever we need in crisis and in the times of peace. A patrol boat on the sea is not going to detect anything which is any submarine factors. And then if we have a vessel for detecting submarine hazards or mines, is capable of detecting such threats. That's all from me. I thank you, Professor. Ladies and gentlemen, I'm under a very big impression. I'm very much impressed by our discipline. We have 12 minutes left for debate, but since we had a small delay, I would suggest that we consider it our joint success. I would like to reverse this traditional conference formula that panelists, after their contributions, have the time for debate, because first you had the time, you had the opportunity to exchange opinions over lunch, I guess, and then I believe that our distinguished guests and the audience, they haven't had the opportunity to ask questions, so perhaps we should reverse the formula and perhaps let us try and find out whether the persons who are here with us, who honored us with their presence, have any questions to the panelists. If they do, I strongly encourage you to ask questions. Otherwise, okay, I don't think I had doubts about you, Professor. May we ask for a mic?
Wyśmienicie.
Bardzo dziękuję.
Pani profesor ma delikatny głos. Słychać pani profesor.
O, słychać mnie, super.
Tak
dziękuję
jest.
bardzo. Do pana profesora.
Now I think you can hear me, and there is a question to Professor Mickiewicz and to Professor Ruschel, the future, because now we have hydrogen strategy of the Russian Federation. What's your opinion of this document and of the hydrogen strategy? So Nord Stream 2 being used for transporting this raw material to Europe. What do you think about that? Professor, I think since the beginning it was one of the assumptions, well, because I don't think a consortium involving also German components had to assume that from the start. There is only a question of which kind of hydrogen will be sent there. Will it be in line with the German interest? I guess, Martin, you know more about that. I'm sure the infrastructure is in place, but the question is about economic policy of Germany. Will they be interested in importation? When? And I think that Germany has a great diversification here, because they may use gas pipelines in Europe and have it closer to home. But as for technological viability, it can be done, obviously. As for hydrogen doctrine of the Russian Federation, I still hope that the plans are excellent, but implementation is so much worse. I hope it will be like that. Professor, over to you. Yes, I agree with Professor Mickiewicz. I think Nord Stream 2 was not built to put gas aside so soon. So I guess it was also the conclusion from yesterday's panels that gas will be mixed with hydrogen. The issue is in what ratio? 2, 4, 5, 10. There are signals in some documents that may amount to 30%. That's the first question. Germany, in their strategy, write down that they can satisfy their own hydrogen potential, hydrogen demand to 16%, which means they will import it. They mentioned 3 countries, Russia, Norway and the Netherlands, as the importation countries, because they take gas from there. So in the coming months, there will be a debate in the European Union, I would say, which will dilute the discussion about colors, because Norway said clearly that hydrogen will be produced from gas, pointing to application of CCS, so using CO2 in the deposits with oil in order to extract even more gas from the deposit and show at the same time that they are climate friendly. So they care for sustainable development. There are 2 more items, or 2 more remarks perhaps. The first remark, I would think about Ukraine in this context. There will be a German activity, namely there will be attempts for underground storage for gas in Ukraine, because if we think about the hydrogen market being built, they need to think about hydrogen and its storage on the way. And the storage capacity, which is based on Konferencja, would have a potential like that. Ukraine has the biggest gas storage capacity in Europe, much bigger than Germany. And the last item, the last remark, which is important in this discussion, is shareholders. Let us look at where Gazprom has its shares in Europe. Gazprom privatized gas storages in the Netherlands, in Belgium. I could go on with this list, but who needs that? The list is very long. So there might be time that what was bought via companies or capital funds will be used when there will be a new kind of game on the table based on hydrogen, but instruments can be very similar. There is another question or another hand in the air. Could you approach the microphone? Good afternoon, Legal Marine. I have a question to Mr. Skomra from Governmental Security Center. What do you think about protection of critical infrastructure offshore, like a gas installation, hydrogen installation, or offshore wind farm, if at the moment no services, no institutions can protect this offshore installation because water police doesn't have specific units? They should be the first reaction team, and the services that could support them is the border guards, because they have the right equipment, but they don't have competences for that. So the question is whether the Government Security Center is carrying out some analyses and is raising awareness among decision makers that our critical infrastructure offshore has no service, no authorities that would protect it effectively. Could you be brief, because I can hear announcements that we are running out of time. What will be of key importance will be selecting services. If we stop thinking about facilities and start thinking about services that we can share responsibility between the operator and the services and the institutions of the state. If we focus on facilities, there is a rule that the owner is responsible for the protection of the facility. You can't do that in examples like you've quoted. So it would be a kind of partnership, I believe, because it will be about maintenance of services. That's a broad issue. It's not only about protection. A simple example. Yesterday someone said that without certain guarantees of the price, no one will invest in the enterprise which will not be profitable in the long run. If the state needs an investment like that, it needs to support it financially at least. The same will pertain to security, protection and current maintenance of the nuclear energy sector. So this discussion is coming closer, we are approaching it, and well, this facility-oriented approach needs to be replaced with a service-oriented approach, and the responsibility needs to be shared between operators and the state. Thank you. I do apologize for hurrying you. All right, just one sentence. We have to also remember that the price of electricity in the socket will have a component like assessed risk and estimated protection connected with the risk. So it is one of the elements that we need to calculate very well, because if we don't do that, we may have the most expensive electricity in Europe, if not globally. Ladies and gentlemen, I can hear announcements that we have to wrap it up. The voice in my ear is very persistent, so if I may, I'd like to say 3 short things. I think that there were many questions in the audience which were not voiced. Maybe it is not good, but perhaps it is good there was no more time for the discussion among the panelists, because, well, obviously I have my questions, my remarks as well. Anyway, many thanks to Professor Mariusz Ruszel. I'm smiling at him and nodding at him because I'm just suggesting that we should go back to this topic, to the subject matter. And perhaps we should devote more time to that. And then I'd like to say thank you to our online participants. We can see them on the screen. I guess it was a challenge. I guess it was less of a pleasure for you because we sit nicely next to each other. We have this natural contact, so I can see it was more difficult for you to join us and to participate in our debates. So thank you to you, and many thanks to our panelists on stage in Rzeszów. And then thirdly, a very pleasant obligation, because you already know that organizers introduced an interesting tradition, a very nice tradition, I would say, that participants choose the most interesting speaker. I don't know whether it is the best turn of phrase, but the speaker you would like to honor for the best contribution. And many thanks to all of you gentlemen, definitely so. These were very interesting contributions and great starting points for further debates, but participants selected Piotr Mickiewicz as the most interesting participant, so he receives an award. Congratulations, Professor Mickiewicz. Many thanks for the discussion, and I do hope you do not mind me as the moderator for limiting your time. All the best. I hope we'll continue our discussion during other events. Many thanks, Professor. You are the winner, Professor Mickiewicz. Many thanks to all the panelists. Congratulations. All the best.
I raz jeszcze, nie wiem w którą to stronę, i panu prezesowi.
Dziękuję bardzo. Dziękuję bardzo.
Dziękuję bardzo. Dziękuję bardzo.
ML System. Zmieniamy świat dla przyszłych pokoleń. Natura to skarb. Dbamy o środowisko. Podejmujemy działania, aby przyszłe pokolenia cieszyły się światem, jaki znamy. Niezbędna jest transformacja energetyczna i my jesteśmy jej częścią. W Centrum Badawczo-Rozwojowym tworzymy innowacje w skali świata. W naszej fabryce produkujemy ogniwa, moduły fotowoltaiczne, systemy mocowań, szyby z powłokami kwantowymi, szyby, które świecą. Fotowoltaiczne żaluzje. Fotowoltaiczne fasady wentylowane. Fotowoltaiczne fasady. Fotowoltaiczne świetliki. Kolorowe moduły fotowoltaiczne. Rozwiązania Smart City. Dostarczamy kompletne rozwiązania systemów fotowoltaicznych zintegrowanych z budynkami. Szyby, które grzeją. Parapety, które grzeją i ładują. Szklane grzejniki. Szyby ze zmienną przeziernością. Chronimy zdrowie. Wirusobójcze przegrody szklane. UV-Box. COVID-detektor. Przyczyniamy się do ochrony planety i ograniczenia efektu cieplarnianego. ML System. Zmieniamy świat dla przyszłych pokoleń.
Sieć LTE 450 to niezawodna i bezpieczna, szerokopasmowa transmisja danych na potrzeby energetyki. To nowoczesne możliwości komunikacyjne, które możemy porównać do tych wykorzystywanych na smartfonie. LTE 450 umożliwia monitoring dużej liczby urządzeń, transmisję danych, przesłanie dokumentacji technicznej, map, zdjęć, obrazu wideo i komunikację głosową. LTE 450 to system wykorzystujący częstotliwość 450 MHz. Specjalne pasmo dedykowane sektorowi energetycznemu. To odejście od ograniczeń radiowych systemów wąskopasmowych na rzecz sieci wielousługowej LTE, gdzie pojemność sieci i zdolność transmisji danych jest nawet kilkaset razy wyższa. Jakie są główne korzyści sieci LTE 450? To podniesienie bezpieczeństwa poprzez efektywne wsparcie służb dystrybucyjnych w przypadku awarii, tak aby szybciej reagować i usuwać ich skutki. To albo zdalne zarządzanie infrastrukturą energetyczną w celu poprawy ciągłości dostaw energii, czy też zdalny odczyt liczników energii umożliwiający tworzenie lepszych taryf dla odbiorców. To wsparcie rozwoju odnawialnych źródeł energii OZE. LTE 450. Nowoczesna technologia, bezpieczeństwo, niezawodność, przyszłość.
Od tysiącleci człowiek odkrywa świat oraz mechanizmy nim rządzące. Napędza nas pragnienie poszerzania wiedzy i lepszego zrozumienia świata. Potrzebna jest do tego odwaga, która pozwala nam docierać tam, gdzie nikt wcześniej nie dotarł. I odpowiedzialność, która sprawia, że naszą wiedzę wykorzystujemy dla wspólnego dobra. Podstawowym obszarem naszej działalności jest wydobycie gazu ziemnego, ropy naftowej oraz sprzedaż tych surowców. Jesteśmy liderem rynku gazu w Polsce, notowanym na GPW. Działamy globalnie. Stale poszerzamy wiedzę, prowadzimy badania i inwestujemy w nowe technologie. Ma to kluczowe znaczenie dla ekspansji i przyszłości naszego przedsiębiorstwa. Jesteśmy wiarygodnym i pewnym dostawcą dla naszych partnerów biznesowych i klientów. Gwarantujemy stałość dostaw i najwyższą jakość produktów. Zapewnia to naszym kontrahentom poczucie bezpieczeństwa i warunki stabilnego rozwoju. Strategia działania PGNiG opiera się przede wszystkim na poszukiwaniu i eksploatacji złóż znajdujących się na terenie kraju i za granicą. Dzięki temu Polska wzmacnia swoją niezależność energetyczną. Chcąc dywersyfikować źródła pozyskiwania surowców, importujemy gaz z rynków zagranicznych. Istotna część przyszłych dostaw będzie pochodzić z Ameryki Północnej. Poszukujemy i eksploatujemy złoża ropy naftowej i gazu ziemnego na norweskim szelfie kontynentalnym, a także w Pakistanie i innych częściach świata. Całość tych działań sprawia, że jesteśmy kluczowym gwarantem bezpieczeństwa energetycznego Polski. Gaz ziemny jest najlepszym rozwiązaniem dla każdego przedsiębiorstwa, które pragnie działać w zgodzie ze środowiskiem naturalnym. Wykorzystując zasoby ukryte w naszej ziemi, troszczymy się jednocześnie o przyszłe pokolenia. Naszym celem jest ciągły rozwój i dostarczanie efektywnych rozwiązań energetycznych. To dzięki temu jesteśmy dzisiaj obecni niemal w każdym polskim domu. PGNiG. Odkrywamy przyjazną energię.
Energia elektryczna towarzyszy nam w każdej chwili życia. Za stały i bezpieczny przesył energii elektrycznej w całej Polsce oraz bilansowanie krajowego systemu elektroenergetycznego odpowiadają pracownicy polskich sieci elektroenergetycznych. Energii elektrycznej nie da się przechowywać, dlatego w każdej chwili należy produkować jej dokładnie tyle, ile zostanie zużyte. Oszacowanie zapotrzebowania na energię elektryczną i jej bilansowanie to jedno z najtrudniejszych i najważniejszych wyzwań, z którymi polskie sieci elektroenergetyczne mierzą się każdego dnia. Nasza sieć to ponad 14 600 km linii 220 i 400 kV. Wraz z dynamicznym wzrostem zapotrzebowania na energię elektryczną rozwijamy sieć elektroenergetyczną, by sprostać wyzwaniom nadchodzącym w kolejnych dziesięcioleciach. Przy wszystkich naszych inwestycjach minimalizujemy wpływ na środowisko naturalne i otoczenie. Wspieramy społeczności lokalne i naszych sąsiadów. W naszych prognozach dotyczących zapotrzebowania i popytu uwzględniamy zmiany zachodzące na rynku energii. Wyprzedzamy je, aby zapewnić bezpieczeństwo energetyczne naszego kraju. Bierzemy aktywny udział w transformacji energetycznej Europy. Jesteśmy częścią jednolitego, zintegrowanego europejskiego rynku energii elektrycznej. Krajowy system elektroenergetyczny jest szczególnie ważny dla bezpieczeństwa państwa. Dlatego przykładamy ogromną wagę do fizycznej ochrony naszej infrastruktury i cyberbezpieczeństwa systemów. Polskie sieci elektroenergetyczne realnie wpływają na polską gospodarkę. Polskie sieci elektroenergetyczne. Energia w dobrych rękach.
Dzień dobry Państwu.
Good afternoon, ladies and gentlemen. My name is Artur Stec. I represent the Technical University of Rzeszów. I would like to welcome our internet audience and you, ladies and gentlemen. We have this panel about Ignacy Łukasiewicz, the pioneer of the oil and gas industry. We have our distinguished panelists with us. We have 5 panelists here with us, and then we have 2 panelists connecting online with us. So let me first welcome Director of Ignacy Łukasiewicz Museum of Oil and Gas Industry in Bóbrka, Barbara Olejarz. The director is with us online. And let me also welcome Professor Paweł Grata, PhD, who is the Vice Rector for Science. Let me welcome the President of the Foundation of the Oil and Gas Industry in Bóbrka, Ryszard Rabski. He's the chairman of the board of that museum foundation. Then we have Mr. Jan Semp, who also represents the museum. At the same time, he also represents here oil and gas school complex in Krosno. Jan Semp prepared a joint presentation with the director of the school. And then we have Ania Kołaczkowska, who
Polityki energetycznej, przepraszam, tak, i gospodarzy.
Represents the Institute for Energy Policy, and then we have Grzegorz Ostasz, professor, who is Vice Rector of Rzeszów University of Technology. And then we have Professor Grzegorz Zamojski, who is the head of the unit of the economic department of this technical university.
I o wielkiej postaci.
Gentlemen, we'll be talking about this great man. We'll be soon celebrating 200th anniversary of Ignacy Łukasiewicz. We might be describing some people as eminent general, eminent president, great general. But when we speak about great Ignacy Łukasiewicz, we may be saying that he was a great oil and gas inventor, a great patriot, but a great man first and foremost. So first, I would like to give the floor to Professor Grzegorz Zamojski, who presented a presentation about early years of Ignacy Łukasiewicz. In terms of time frame, if you have 9 minutes for each and every presentation, and I will be signaling the end of your presentation. So I have the honor of starting this panel. Ladies and gentlemen, I'm talking about the early years of Ignacy Łukasiewicz, until his 20s, mid-20s, because I identified that Łukasiewicz was strongly based in Rzeszów in 1846. At that time, he was arrested and imprisoned. But this topic will be covered by Professor Ostasz. We know that Łukasiewicz was born in 1822 in the town of Duszniki in the Mielec, current Mielec administrative district. And it is still uncertain when Ignacy, at what point Ignacy and his parents and his siblings, where the whole family moved down to Rzeszów. But we know that his elder brother Alexander was attending the secondary school from 1823, and it may have been connected with the fact that in 1823 Józef Łukasiewicz bought a house in Rzeszów, and this house survived until this day. So on the slide that you can see on the display, you can read the information. So we have that note dating back to 1824, informing that in 1823 Ignacy Łukasiewicz's father bought that house in Pijarska Street, which was basically in front of the so-called academic church in one of the main streets of Rzeszów. So information about Ignacy Łukasiewicz, his daily life, well, but that information is hardly available. There are very few sources that survived. We have some information about property, assets, then the information regarding involvement of 3 sons of Józef Łukasiewicz, their attendance in the secondary school, and the fact that they possessed a house. They owned a house in Rzeszów because they were paying taxes on the property. So the materials are kept in Rzeszów archives, municipal archives.
Które wspominają, potwierdzają fakt zakupu, fakt posiadania przez Józefa Łukasiewicza domu przy ulicy.
There is some information confirming the fact that Łukasiewicz owned the house in that street, so that is confirmed by the cadastral register. And then the fact of this house ownership is evidenced by tax, proof of tax payment. Such taxes were paid by house owners, and we're convinced actually that the family
Rzeszowa w latach 20. Świadczy o tym.
Family moved down here in 1820s.
Ignacego Aleksander, jak i jego starszy brat.
Łukasiewicz's brothers and he himself. They all attended the secondary school in Rzeszów. But we know for certain
Pierwszymi nauczycielami byli nauczyciele prywatni.
But that they first had been receiving private tutoring, homeschooling.
Dom na umieszczenie i miejsce, gdzie znajdował się budynek należący do rodziny Łukasiewiczów.
There was this building owned by the family of Łukasiewiczes, as shown on this map dating back to 1841. So this is where the building was located. So that picture was taken 3 years ago and does exist until now, and the building was in the direct neighborhood of the area with the district pharmacy owned by Edward Hibel, who was a local resident.
Know
that between 1833 and 1837, for 4 years, Ignacy Łukasiewicz was attending the secondary school of Rzeszów. On the slide, you can see the information of his registration when he registered in the secondary school of Rzeszów. And that was his place of origin, the profession of his father, and land administrator. And then we can see his grades.
Półtora minuty.
Ten rok był rokiem szczególnym dla
It was a very special year for the family of Łukasiewicz's. His father died. So this is the picture of his grave at the old cemetery of Rzeszów, and from the windows of his house, young Ignacy could see the building of his secondary school.
Łukasiewicza znajduje się grób blisko związanego z...
And then nearby there is, near that there's his father's grave, there is the grave of Edward Hibel, who was a friend of Łukasiewicz. And then we recognized that in 1846, we may only suspect for the reasons why he did, that Łukasiewicz sold a part of his part of the property to his sister.
Stasza o zaprezentowanie wystąpienia na temat...
Grzegorz Ostasz is going to talk about other parts of Ignacy Łukasiewicz biography. He is going to talk about independence activity mostly. Independence activity, it means all kinds of activities aiming at regaining independence by the Republic of Poland. Let me remind you a statement of unknown author that Ignacy Łukasiewicz started as a crazy romanticist and ended up as a very down-to-earth and practical person, a great innovator, patron of many institutions, and the Technological University of Rzeszów among them. Also participated in independence activities when Poland was under partitions, and his biography is very well known. But everyone focuses on his activities as a pioneer in the petroleum industry. Let me just add, to refer to the first speaker, that during his years in Rzeszów, in middle school, Łukasiewicz started to act in conspiracy, and he started to participate in underground activities. It was like a relay race of the Polish youth, because there were various associations of young people. Even at the beginning of the 19th century, there were different conspiracies, association of Polish people with Karol Lewita. So there were many young people in Polish history in the 19th century, and all of them fought for the independence of Poland. After he graduated from middle school, he had to leave school and started work as a pharmacy assistant at the pharmacy in Łańcut, where he developed his contacts in conspiracy milieus, among other people with Karol Chodziński, who was a painter for the Potocki's family. Łukasiewicz was quite a secretive person, slightly tough and reticent, and actually in his conspiracy activities it was very much desired that he was reticent and discreet. And during his work at the Łańcut pharmacy, he became part of the conspiracy network of chemists who work for the Count Potocki, who was very active in a conspiracy in Łańcut. But actually the leader of this conspiracy unit was under supervision of the Tsarist Russia police. So we had to delegate some activities to Łukasiewicz, and Łukasiewicz ended up in arrest. He was investigated and he was questioned by the Russian police due to his conspiracy activity. And after 14 months of working and living in Łańcut, in 1841 he moved back to Rzeszów, and he started to work at the pharmacy previously owned by Edward Hibel, and at the back rooms of the pharmacy many conspiracy activists met. So they met there, they organized meetings with envoys of the Polish society, Count Wiesiołowski and Edward Dębowski among them. I guess Edward Dębowski was the best-known conspirator of that period. Some of clandestine meetings were held at the parish house of the then vicar priest Jan Tarasiewicz. So, just to give you a fuller picture, let me quote the description of the then Rzeszów of the 1840s. It was a clean provincial town, welcoming travelers with a stone bridge, and it was like a capital city of the district with some eminent buildings like former nunnery that nowadays was the official building, and towards the east there was a castle of the Lubomirskis that used to be the fortress. Now it was the building of the court. And then Edward Dębowski started a permanent contact with Łukasiewicz, who became, as they called it, a revolutionary agent, because the revolutionary fight for independence was to be coupled with social changes. So one of revolutionary agents was Ignacy Łukasiewicz. And the job of these agents was about collecting intelligence about the military power of Austrian army and collecting information in general. So his work in the pharmacy made it easier for him to prepare uprising in Rzeszów and the neighborhood, and rebuilding Poland and its previous borders from the end of the 18th century. The pharmacy was a convenient point because actually it allowed to organize clandestine meetings in a quite discreet way. Besides the furniture, the layouts allowed to hide many secret materials like forbidden literature. At the ground floor, at the back, there was a room where Łukasiewicz lived, and it also provided good conditions for secret meetings. And then Łukasiewicz recruited a large group of conspiracy activists among young people, shop assistants, officials, and they were supposed to be involved in an uprising in Rzeszów. In 1846, February, in Rzeszów Luftmaschine, which was a hotel back then, one of the leaders of planned uprising, Count Wiesiołowski, presented a plan of a military action to Łukasiewicz. I should mention that Łukasiewicz had contacts with Wiesiołowski and Dębowski, and it is commemorated by the plaque on the townhouse called Luftmaschine. And according to some assumptions, which were quite fantastic, the city was to be attacked by conspirators from 4 sides, and they were not well prepared, poorly equipped with weaponry. So actually it was part of a fantasy. It was not a very practical plan. And then they went to Łańcut to encourage other conspirators to join in, but conspirators in Łańcut were more realistic and realized it wasn't very practical and down to earth. So only in Rzeszów these fantastic plans were to be implemented. And maybe, well, as legend has it, the uprising was planned for the 17th of February 1846, and It was the carnival time in Rzeszów. It was the time for the carnival ball, and it was to be the starting point, the starting point for the uprising, because the Austrians were supposed to be surprised by that. But for the whole country, actually, the uprising was to start several days later. So actually, Rzeszów to be the first city to start the uprising. But one of Austrian military leaders, Legalish, an honorary citizen of Rzeszów, and Łukasiewicz is even now not an honorary citizen of Rzeszów, paradoxically. So the Austrian leader forbade the ball, and then counteraction was started against conspirators, and the Austrians had many moles actually, and they arrested conspirators arriving at Rzeszów, but also local conspirators active here, especially leaders of the conspiracy. So on the 19th of February, Łukasiewicz was arrested with Jan Tałasiewicz and tailor Jan Czarnecki, who was to set fire on his own home to give the signal to start the insurrection. So you have to see it is quite an original concept to start the uprising. Łukasiewicz was denying everything. It was a very efficient tactic. He knew something about revolution only from the newspapers, but he didn't know anything about the conspiracy as he claimed. So the first stage of investigation failed, actually, the Austrians, and everyone was actually released from arrest apart from Łukasiewicz, who went to prison in Lviv, and he spent 2 years in prison in Lviv. There were several investigations organized by a special cell, police and court cell. Then he was released, but he was obligated to remain in Lviv and come to court whenever he is required to. And afterwards, he decided to give up on conspiracy activities. He was more focused on petroleum, even though in other biographies it is mentioned that even as a student he was involved in conspiracy activities. Well, it is not really well confirmed in the documents, but obviously the Polish cause was very close to his heart, and he supported many people after the uprising, many participants of the uprising later on. And then in the political arena, towards the end of his life, when he was 55, he was elected for the national parliament in Galicia, in Lviv, and he carried out his public and social missions. Let me quote, he was a worthy citizen. He didn't have magnificent speeches, there were no standing ovations, but he was simply very persistent, very modest, working very hard to the benefit of his country. You've run out of time, just 2 more sentences, let me wrap it up. And let me quote the former rector of the University of Rzeszów, who, when he was a young guy, he was a soldier of the Home Army, and he said it is good Łukasiewicz was not a conspirator for a very long time, because thanks to that he did not die as a conspirator, but he became an innovator and an eminent innovator on the global scale. Okay, thank you very much. Anna Kozicka-Kołaczkowska is going to talk about the private life of Ignacy Łukasiewicz, and it is entitled To Make You Smell, Honorata and Ignacy Łukasiewicz. The floor is yours.
Ladies and gentlemen, Ignacy Łukasiewicz married when he was 35, and he married a 20-year-old woman. Her maiden name was Stachelska, Honorata Stachelska. Young Ignacy, well, that's Ignacy when he was about around 30, and we must admit that he looks very different from what we know for portraits. He was a handsome man. Let's be quite clear about it. So biographers were contemporary biographers can see, and actually were treated as a taboo, that Łukasiewicz, he married a daughter of his own sister. Actually, that fact, has at some point become very popular, and I think that this topic it's worth covering, because Łukasiewicz we should hear all the truth about this part of his biography, because the truth is that throughout the history from early 19th century to the end of 19th century, marriages in families were socially accepted. They didn't cause any objections, and they required certain permits, but they were not received as a surprise by the society. And nowadays there is this internet coverage, and I imagine a student who comes across such information. So, for example, we have that
kolejny przypadek tekstu.
Incestuous marriage of our scientists.
Coś tutaj źle robię. Nie. No trudno. O, właśnie. Kolejny przypadek.
Here we have another fragment of a text. It's like copy and paste concept of multiplying information. As a biographer of Łukasiewicz, I just simply cannot let it go. So try to use the time allotted to me for explaining. So first, I think that his contemporaries should be mentioned here. So these are protagonists of Fredro's dramas. Although Fredro was born 29 years before Łukasiewicz, but Łukasiewicz survived him by 5 years only. And Fredro, Polish drama writer, he was not light-spirited. I mean, he was portraying his neighbors, he was portraying the small nobleman, well, his compatriots who lived in his neighborhood, in his area, who lived in the area of Lviv and in the area of the city of Przemyśl. So that was the same area, same mentality, same lifestyle, same habits, same customs, and same values, such as verbum nobile, nobleman word or promise. Actually, Fredro, the drama writer, was actually allegedly accused of promoting noble lifestyle.
Chciałabym przeczytać taki fragment. Chcielibyśmy zaprezentować Panie.
Please read this fragment. This is a part of the drama called The Dames and Soldiers.
Rzecz skończę.
Słucham.
Ponieważ chcesz służbę porzucić.
Ale ja nie chcę służby porzucać.
A co to kryć?
Szczerze mówię.
Na wsi chcesz osiąść.
A nie.
So this is a role play from this drama, first drama.
Abyś się ożenił.
Czyś wać panna szalona?
Rzecz nie ma co mówić.
Chciałem powiedzieć, chyba byłbym szalony.
A to dlaczego?
Mnie w tym wieku brać żonę? Co za myśl. Nigdy małżeństwa nie byłem przyjacielem, a tym bardziej teraz. W obozie posiwiały. Szabla i koń to moje były kochanki. A jeślim czasem pokochał, to po huzarsku. Póki dobrze, póty miłość. Ja teraz mam się w amory wdawać? Byłbym szalony, a jeszcze szaleńsza ta, co by się za mnie wybierała.
Ja więc dziś mówić nie będę.
Gadaj sobie, wać pani, gadaj do sądnego dnia, ale nie o moim ożenieniu.
Cierpliwości. Ożenienie ożenieniu nierówne.
Zawsze diabła warte.
Nie wiesz, kogo za żonę ci przeznaczam?
Nieciekawym.
Moje Zosie.
To dziecię?
Ma lat 18.
A ja 56, 4 lata starszym od wać pani.
Bez rachuby, bardzo proszę.
Nawet podobno wać pani 53.
Same widzę obelgi. Odnoszę za moje dobre serce.
Za dobre chęci dziękuję, a układu nie przyjmuję.
Zastanów się tylko, uparty majorze. Dziewczyna na wsi, bogobojnie wychowana, cały swój los zawdzięczać ci będzie. Będzie kochała, szanowała więcej jak ojca niż męża. A ty otoczony dziećmi.
Trudno.
Będziesz błogosławił chwilę, w której zostałeś powolny moim zamiarom. Nie gardź, proszę cię, szczęściem, które ci się zdarza. Szanowni państwo, ludzie...
Okay, ladies and gentlemen, the 19th century society as all the contemporaries, as all artists, and well, people of social circles did not see any reason to condemn or look down on marriages suggested in that play and in that role play, a marriage between an 18-year-old and a 56-year-old, between an uncle and his niece. And only later on, there was some
grupy krwi jako A, B i AB i 0, a przecież też informacje zawarte w kodzie genetycznym.
Later on, it was discovered, and it was discovered that there was this specific blood group conflict between closely related family members. And the Emperor Franz Joseph of Austria, he married Sisi, allegedly the most beautiful woman of Europe of the time. So, actually, ladies and gentlemen, in what we read in the internet is quite confusing, it's quite misleading, and the information does not reflect the spirit of the epoch. So that marriage was quite what was practiced at the time, and now we'll have contribution from Professor Paweł Grata, Ignacy Łukasiewicz, pioneer, visionary leader of the oil industry in Galicia in the third quarter of the 19th century. Thank you very much, ladies and gentlemen. My apologies for being online. I'm in Rzeszów, but my schedule is packed. I must say that I'm a bit stressed because after the role play, my contribution seems very modest and very crude, but I must say that achievements, so Łukasiewicz's achievements in the area of technology and invention was quite formidable. My contribution is more about summarizing his achievements.
Nowatorskie inscenizacje, których na pewno nie będę Państwu oferował. Patrząc na rolę Ignacego Łukasiewicza, ja tutaj...
Looking at the role of Łukasiewicz, I agree with one of the previous speakers. I think that it was excellent that Łukasiewicz abandoned, that he was no longer involved in his fight for freedom and independence of Poland, because he did much more for his motherland as a pioneer, as the pioneer of the oil and gas industry. From my point of view, the crucial thing is that it's worth remembering that the fact that oil and gas industry was so developed, that oil and gas was consolidated and it was promoted. Well, these facts are much more important than other things. He became very well known because of patenting his invention, but that was the means to the goal, which was to develop and grow oil and gas industry. So from the time of his arrival to the Subcarpathian region, to Jasło, to the city of Jasło, he was showing that he ended up in Bóbrka, in the first oil and gas well. He was the founder of the first oil well in Bóbrka, and that came through because of his determination, his enthusiasm, and then he created the first oil refining plant. This path to success was rough, but he was so determined. He was a visionary, and he knew that all will be fruitful. The company that he set up in 1861 generated a lot of income for its stockholders. The Bóbrka mine was generating 1/4 of oil and gas in the entire Galicia region. It was of very high importance for the biggest for the very early phase of oil and gas industry in Galicia. And thus several important areas of his activity. So he was an inventor. He was a founder of oil and gas companies, but he was also a person who managed the mine, to the well, when he remained the manager of Bóbrka mine after exiting the company. He built other oil refining plants, and he was the animator of oil prospecting. He was drawing here people, attracting here people who were excellent engineers. He imported steam machinery and equipment. He was employing the right people, and he worked for his own companies, and he understood the importance of the technical progress for the entire industry. So I would emphasize this aspect, that he was not only thinking about his own revenue, his own profits, but he understood that it was so important to train and educate people. He was taking part in international trade fairs and exhibitions, and that all was showed and demonstrated his ability of grasping entrepreneurship and industry. And I'm interested in social policy, and I admire him as the founder of a savings and deposit organization in the coal industry, in mines, such traditions were not always present, but Łukasiewicz succeeded in creating a very solid, very comprehensive system of insurance, care and benefits for the employees of Bóbrka log wells. And only years in the interwar period, such solutions were commonly applied. That he exited that company, that came as a surprise to everyone. But he exited that company because he wanted to go beyond certain boundaries. He was trying to work towards a growing oil and gas sector. He was testing wells in many other locations. He was testing locations, and he was investing his money, and he was trying to open new sites. So he wasn't consuming his income, but he was supporting new enterprises. And there are stories that he used to borrow, to lend money to young entrepreneurs, entrepreneurial people. He was supporting peasants who were supporting him and assisting him in transporting oil. And he initiated a mining and later on an oil board. He was supporting the industry and supported the creation of the oil legislation. So his committee supported and created that legislation. And well, actually, in 1888, 25th anniversary of lighting the first kerosene lamp was celebrated. And he formed an organization for oil and gas entrepreneur, and that showed the importance of Łukasiewicz for the industry. So he was the creator of the industry in Poland. He was the innovator, and we call him the founding father of that industry in Poland. If it wasn't for him, Galicia wouldn't become the oil superpower. And let me finish with that, and over to you. Thank you, Professor. Thank you very much for this very interesting contribution.
Now it's time for the next speaker from the school complex in Krosno. He also represents of the museum, and he's going to talk about 130 years of oil and gas education in southern Poland in the Subcarpathian region. Good afternoon, ladies and gentlemen. It is a great honor for me to present the presentation about, to be precise, 136 years of petroleum education in the Subcarpathian region, and co-author is Joanna Kubit from the school complex named after Ignacy Łukasiewicz in Krosno. I'm the other author. I represent the Museum of Oil and Gas Industry named after Ignacy Łukasiewicz in Bóbrka. We are meeting at the Technological University named after Ignacy Łukasiewicz as well. So let me start by saying that the first ideas connected with establishing a school, these were ideas by Ignacy Łukasiewicz, and it happened in 1875 that he started to make attempts for opening what was called then a lower mining school. 2 years later, in 1877, out of Łukasiewicz's initiative, the first petroleum congress was set up in Lviv. And as a result of the discussions and meetings during the congress, the National Society of Petroleum was established. It was the first organization bringing together experts from the field. I will tell you more about this National Society later on, but let me just say that in 1878, the current head of the district mining office in Lviv, engineer Henryk Walter, well known to petroleum experts, submitted an outline and a conspect for future vocational schools suggested by Łukasiewicz. It lasted for some time because it was as late as 1885 that this project was actually implemented, and unfortunately it was 3 years after Łukasiewicz's death. So in October 1885, a petroleum school was opened. It was called a Practical School of Canadian Drilling, funded and controlled by founding fathers, namely by the National Society of Petroleum, and the school was established in the place called Ropianka. You can see archival photos, you can see the conditions for work for pupils. So you can see that the building is not very impressive. The building no longer is there, but in Ropianka we made attempts to have a monument commemorating this first school building, and there is the special plaque commemorating this first school. The school in Ropianka operated for 3 years only, and about 50 people graduated from that school in this period of time. It was headed by engineer Zenon Suszycki, who became the director of the oldest oil mine in Bóbrka. That is why he moved to Wietrzno, and the school, the drilling school, was moved there, and then he was called the Drilling School of Wietrzno, and it operated there for a few years, so 1888, 1896, and it was graduated by like 160 people in that period, and then 1896, the next step was taken, because Władysław Długosz discovered new deposits of oil in Borysław. There was a drill which led to this discovery, and he obtained the daily flow of about 40 tons per day. So due to that, again, the school was moved, and it received a new name, a lower mining and drilling school. Then, in 1908, its name was changed into the National Mining and Drilling School. In 1914, it ceased to operate due to the beginning of the First World War. In 1920, activity of the school was resumed. It was called the former National Mining and Drilling School, and it was operating in the summertime as well, interestingly enough, because it organized specialized courses combined with work in the oil mine for university students. In 1928, it was taken over by the oil department and the mechanics department of the Technical University of Lviv. So it was a new school, a new name, or perhaps a new name to be more specific, and it was supervised by the supervisory office in Lviv. And some photos were found from that period. So you can see a set of photos of graduates from 1933. In 1939, the Second World War broke out, so the school was actually suspended, but despite of that fact, it operated to some extent and it received a different name, Burilścik School. My father graduated from that school. He was a master of rotational drilling and stroke drilling master. And then in 1942, as the German army took over Borisław, and then a state school, drilling school in Borisław was set up with Polish as the teaching language, whereas in Jasło there was a branch of the school till June 1944. The military front stopped in September near that place, and the school was still operating in June the same year. In the post-war period, all oil experts moved to the Western oil territories, as we call it, but then in 1945 the new personnel had to be educated and qualified. It happened due to the initiative of the Oil Institute, and then in 1946, in order to improve the level of education, Arnold 111 training mine was established near Krosno. There was a special building for lecture rooms and for a boarding building. And then 1947, on the 1st of March this year, the oil school in Krosno was established. The Oil Institute opened the middle school for industrial mining, oil mining in Krosno. The first location was post-refinery building, now in Buczka Street. Now it is Naftowa Street. In the past it was Buczka Street. There is a photo like that, students in front of the building. There is also a painting to the left. 1 minute left for your presentation. Okay, so I will speed it up. 1950. 2 schools were established there, like technical secondary school and vocational school for oil industry. 1951, out of the initiative of the Oil Institute, a new building was built in Kolejowa Street. After 16 years, in 1967, there was a ceremony of opening the new building of the school. There was a new name given for the school, and this time the school was named after Ignacy Łukasiewicz. Then there were more changes, like the whole avalanche of organizational changes for a vocational school, technical secondary school. Yet it is the photo of the school, 1951. And then we are reaching 2020, and now we have oil and gas school complex. It was connected with the educational reform in Poland, so now we have a school complex named after Ignacy Łukasiewicz. There is a photo from the 1960s to the left and the current photo to the right. That's all from me. Thank you for your attention. Many thanks. And now it's time for Director Barbara Olejarz from the Ignacy Łukasiewicz Museum of Oil and Gas Industry in Bóbrkach. He's going to talk about a quiet and peaceful man, Ignacy Łukasiewicz, in the memories of the epoch. Over to you, Director.
Good afternoon, ladies and gentlemen.
Czy jest widoczna?
Can you see my presentation? Yes, we can.
Tak, widzimy prezentację.
Tak, widać prezentację, tak, widzimy.
Dziękuję bardzo.
For nearly 15 years, I've been studying Ignacy Łukasiewicz, largely focusing on his professional life in the area of Bóbrka. But I'm also looking for traces of interesting humanistic behavior, and we have some descriptions of who he was. I've been reading memoirs and diaries of the epoch. He was a man, a person with a very big heart and extremely bright person. First, I thought that his portrait was presented by his contemporaries was unrealistic, and I was even more passionate in my search for some information and details that would change that image of and that impression of that brilliant and excellent person. And then eventually I realized that we shouldn't be opposing that concept that he was a brilliant and extraordinary, but also a very modest person. And it was then that when I came across the quote from August Golański, and it turned out, and it was as early as in 1882, August Golański wanted to give this message that there were some louder and more brilliant men than he was, but he was man of many merits. And he said, we should recognize this honor because we may presume that it will be later on denied. We should commemorate his name, the name of the inventor, and commemorate him and his achievements to future generations. So we should remember that Ignacy Łukasiewicz was the creator of the oil and gas industry. That the words that he shared to Tytus Trzecieski, that oil is going to change the image of the world and Galicia, these words were a prophecy. In 1854, he set up this Búbrka plant. In 1870s and the 80s, when there were so many new wells in the area, the one in Búbrka was the model well because of his management and administration. Practically everything that happened in the oil industry originated from Búbrka, from this location. Búbrka was also the location where, with very exceptional work relationships, that well generated about 25% of all oil production in then Eastern European Galicia. Everybody remembers Łukasiewicz as a person who was very modest and happy and always in good spirit. And he was very hardworking and he was a very good manager and administrator. His charity work was also emphasized and recognized, as well as his modesty. And the impact of the oil industry on the area was also beneficial. All those who commented on the development of the well site and Búbrka didn't have any interest in writing that. There were writers, there were travelers who were describing the beauty of that region. They were comparing that region to the most beautiful regions of Germany. The contemporaries of Łukasiewicz wanted to honor him, and in 1878 in Chorkówka there was a gala, and Łukasiewicz received a medal to the creator of the oil industry, commemorating the 25th anniversary of opening the production. Łukasiewicz was a very modest person, so he didn't feel he deserved that medal. But actually, there is one thing we can be certain, that owing to his activity, owing to his industriousness, the entire area changed. We're celebrating 140th anniversary of Łukasiewicz's death, and we should remember his achievements, his deeds, and we should have it in our hearts and minds. Thank you very much, Director, for your contribution. So let me give the floor to the President of the Chairman of the Board of Łukasiewicz Oil and Gas Industry Museum Foundation in Bóbrka.
Dzień dobry Państwu.
Afternoon, ladies and gentlemen. Perhaps I will begin by saying that, well, I want to talk about achievements of Ignacy Łukasiewicz. We are talking about 1853, and then Ignacy Łukasiewicz, the creator of kerosene lamp, or actually the fuel that he applied in a lamp. So he distilled kerosene out of oil. And it has been a certain beginning, and it was called the beginnings of a new sector, which was the petroleum sector. And the next year, Ignacy Łukasiewicz moves to Gorlice, where he meets a nobleman and oil expert, philanthropist, Tłuszczyszewski, who brings samples of oil in order to show it to already well-known Ignacy Łukasiewicz, who was the authority and expert on oil in order to check the quality of the raw material. Ignacy Łukasiewicz realized they are of the highest quality, and he was very much interested in that raw material, and quite soon well, it was not like signing anything, but first decisions were made about starting the first company running activities in Bóbrka. Tłuszczyszewski and Ignacy Łukasiewicz are setting up a company in order to search for oil and extract it later on. And very soon, they became successful, because oil becomes a raw material which is highly desired. Bóbrka has been developing very fast, and in a few years, the owner of the land, Tłuszczyszewski, who is the third founder of the company, but the company is taking very specific shape. And we can say that the industry started to change the whole area. because the whole area was developing dynamically, and because we realized how great achievements were made by Ignacy Łukasiewicz. So Ignacy Łukasiewicz wanted to pass on to the next generations all of his achievements. So here on the plinth, founded on the 18th anniversary of the opening of the first oil mine, there is an inscription to commemorate the establishment of the Sip oil mine, 1854, Ignacy Łukasiewicz, 1872, so the 18th anniversary. Because Łukasiewicz had a certain idea, namely he wanted to commemorate these achievements, and his successors and societies functioning later on in the post-war and pre-war periods, all these associations were set up in order to open a museum. And in 1961, in Bóbrka, an open-air museum is opened. It documents all the achievements of Ignacy Łukasiewicz and protects it. The area of the museum is actually the area where mining activities are taking place all the time. So there is a functioning mine, and technologies are changing, the industry has been developing, and perhaps the elements of the landscape which were typical of the Bóbrka mine may disappear soon. So there is the Association of Engineers and Technicians, which decides to open a museum in 1961, and that's when they started to document and collect all the documents, all the papers, all the information about that place. And it is a unique place globally because it collects documentation of the development of the petroleum industry. The 20th century was called the century of electricity, steam and oil. Oil was the leader, and it was actually driving the development of the sector. We could see a fast development of economies, of cities, of various regions. Perhaps very soon we are going to talk about alternative fuels, and it's been mentioned here during this particular conference, but this fuel is still dominant. It is still a driving force for development of many sectors. And here, flagship objects that we present in our museum. These objects are presented in the slide from 1860 and 1878. So devices pumping oil all the time. In Franek, it is in buckets, and in Janina, it is more modern, I would say, and these devices are still on the territory of the museum. They belong to the Bóbrka Foundation, and the owner of this deposit is Polish oil and gas company, the Sanok department. We are pleased with that fact because we have a great partner taking care of these facilities and these objects, these exhibits, and helps us to support and maintain the museum and its activities. After 1961, thanks to the initiative of actually the whole oil sector and various oil experts, the museum area was divided into sectors, like the sector of the old mine and another sector of search and drilling. So various elements of former infrastructure were preserved in the area. Main elements of infrastructure, auxiliary elements like a blacksmith workshop, the old office, with warehouses for tools. So the house of Łukasiewicz was also preserved, and at the moment it houses a pharmacy and a lab. So it is a continuation of various efforts aiming at preserving the heritage of Ignacy Łukasiewicz. Here, a bird's eye view, and you can see the facilities in individual sectors of the whole museum territory. What is very important for us is documenting Łukasiewicz's heritage, and in 2004 a big modern pavilion was opened, which is created for exhibition purposes. There are temporary exhibitions, permanent exhibitions. There is a mining room, there is a refinery room, and a gas industry room, because the gas industry becomes part of the whole sector a bit later on. But you can see how we can manage the territory of the whole plot, because there is 22 hectares of forest, and it is an example how you can show the whole series, the whole range of all the elements that were important at various stages of development of the oil sector. As a result of all these works and attempts and efforts of all these people, as a result, the museum and the foundation received the title of the Monument of History. It happened on the 100th anniversary of Poland regaining independence as a country. So we are among 100 of the most significant places connected with our national heritage. It is post-industrial heritage, to be more specific here. What is typical of the museum, what is typical of the foundation, is that the mine is operational all the time. There is extraction of the deposits all the time there. And we also receive more and more exhibits to our museum. And the most important thing for us is maintaining these areas, these facilities in the best possible condition. I'm sure if you visited Bóbrka, or if you visit it in the future, you will see that all these facilities are in excellent condition, especially the ones which are witnesses of Łukasiewicz's activities. And I have to say here that the success and the achievements, like entering the list of 100 monuments of history, actually it pushed us towards next steps, because this year we are part of the list of nominees for the UNESCO list, and in the near future, I mean very soon, on the 29th and the 30th of September, in the territory of our museum, there will be a world conference connected with extraction. And the first oil mines in this area called on the UNESCO list. We realize that oil was not located in Poland only, but in other countries as well. So that is why we are convinced that a joint UNESCO list, together with Canada, the United States, France, our friends from Romania and the Czech Republic, and our friends from these countries will support us in our efforts to end up in the UNESCO list and to commemorate the whole heritage of Ignacy Łukasiewicz. Thank you very much for your attention, and visit us in Bóbrka. Thank you very much to all the panelists. For the last hour, we had a chance to listen to various events from Ignacy Łukasiewicz's life, from his childhood through his young age, where he was deeply involved in patriotic activities. And then we talked about his professional life connected with the oil industry. Besides, we could talk about his heritage and his achievements. We learned about traditions connected with the development of oil education there, and we learned quite a lot about the place which is closely connected with Ignacy Łukasiewicz, namely the mine in Bóbrka. There is a saying that it doesn't matter how you begin, it matters how you end. But actually, in case of Ignacy Łukasiewicz, both the beginning and the end of his life was very impressive. So I think of a message that Łukasiewicz leaving this world left behind such a great heritage and so many achievements. Thank you very much for attention and a bit of information. The best speaker was Anna Kołaczkowska. Thank you very much indeed. Congratulations.
Jakże mi miło. Dziękuję bardzo. Ojej. Dziękuję bardzo.
Gratuluję.
Dziękuję oczywiście tym, którzy się przyczynili.
Congratulations, many thanks for people who voted for me. Thank you very much indeed. It's been a great pleasure. Thank you. Congratulations, many thanks to all the panelists. Thank you for inviting us here. That's all for now.
Dziękujemy, pani dyrektor.
Bardzo miło. Dziękuję.
Właśnie zgłosiłem się na Państwa konferencję.
Nie słyszę Pani przekaz.
Jest mail, do widzenia.
System. Zmieniamy świat dla przyszłych pokoleń. Natura to skarb. Dbamy o środowisko. Podejmujemy działania, aby przyszłe pokolenia cieszyły się światem, jaki znamy. Niezbędna jest transformacja energetyczna i my jesteśmy jej częścią. W Centrum Badawczo-Rozwojowym tworzymy innowacje w skali świata. W naszej fabryce produkujemy ogniwa, moduły fotowoltaiczne, systemy mocowań, szyby z powłokami kwantowymi, szyby, które świecą. Fotowoltaiczne żaluzje. Fotowoltaiczne fasady wentylowane. Fotowoltaiczne fasady. Fotowoltaiczne świetliki. Kolorowe moduły fotowoltaiczne. Rozwiązania Smart City. Dostarczamy kompletne rozwiązania systemów fotowoltaicznych zintegrowanych z budynkami. Szyby, które grzeją. Parapety, które grzeją i ładują. Szklane grzejniki. Szyby ze zmienną przeziernością. Chronimy zdrowie. Wirusobójcze przegrody szklane. UV-Box. COVID-detektor. Przyczyniamy się do ochrony planety i ograniczenia efektu cieplarnianego. ML System. Zmieniamy świat dla przyszłych pokoleń.
Sieć LTE 450 to niezawodna i bezpieczna szerokopasmowa transmisja danych na potrzeby energetyki. To nowoczesne możliwości komunikacyjne, które możemy porównać do tych wykorzystywanych na smartfonie. LTE 450 umożliwia monitoring dużej liczby urządzeń, transmisję danych, przesłanie dokumentacji technicznej, map, zdjęć, obrazu wideo i komunikację głosową. LTE 450 to system wykorzystujący częstotliwość 450 MHz. Specjalne pasmo dedykowane sektorowi energetycznemu. To odejście od ograniczeń radiowych systemów wąskopasmowych na rzecz sieci wielousługowej LTE, gdzie pojemność sieci i zdolność transmisji danych jest nawet kilkaset razy wyższa. Jakie są główne korzyści sieci LTE 450? To podniesienie bezpieczeństwa poprzez efektywne wsparcie służb dystrybucyjnych w przypadku awarii, tak aby szybciej reagować i usuwać ich skutki. To zdalne zarządzanie infrastrukturą energetyczną w celu poprawy ciągłości dostaw energii, czy też zdalny odczyt liczników energii umożliwiający tworzenie lepszych taryf dla odbiorców. To wsparcie rozwoju odnawialnych źródeł energii OZE. LTE 450. Nowoczesna technologia, bezpieczeństwo, niezawodność, przyszłość.
Od tysiącleci człowiek odkrywa świat oraz mechanizmy nim rządzące. Napędza nas pragnienie poszerzania wiedzy i lepszego zrozumienia świata. Potrzebna jest do tego odwaga, która pozwala nam docierać tam, gdzie nikt wcześniej nie dotarł. I odpowiedzialność, która sprawia, że naszą wiedzę wykorzystujemy dla wspólnego dobra. Podstawowym obszarem naszej działalności jest wydobycie gazu ziemnego, ropy naftowej oraz sprzedaż tych surowców. Jesteśmy liderem rynku gazu w Polsce, notowanym na GPW. Działamy globalnie. Stale poszerzamy wiedzę, prowadzimy badania i inwestujemy w nowe technologie. Ma to kluczowe znaczenie dla ekspansji i przyszłości naszego przedsiębiorstwa. Jesteśmy wiarygodnym i pewnym dostawcą do naszych partnerów biznesowych i klientów. Gwarantujemy stałość dostaw i najwyższą jakość produktów. Zapewnia to naszym kontrahentom poczucie bezpieczeństwa i warunki stabilnego rozwoju. Strategia działania PGNiG opiera się przede wszystkim na poszukiwaniu i eksploatacji złóż znajdujących się na terenie kraju i za granicą. Dzięki temu Polska wzmacnia swoją niezależność energetyczną. Chcąc dywersyfikować źródła pozyskiwania surowców, importujemy gaz z rynków zagranicznych. Istotna część przyszłych dostaw będzie pochodzić z Ameryki Północnej. Poszukujemy i eksploatujemy złoża ropy naftowej i gazu ziemnego na norweskim szelfie kontynentalnym, a także w Pakistanie i innych częściach świata. Całość tych działań sprawia, że jesteśmy kluczowym gwarantem bezpieczeństwa energetycznego Polski. Gaz ziemny jest najlepszym rozwiązaniem dla każdego przedsiębiorstwa, które pragnie działać w zgodzie ze środowiskiem naturalnym. Wykorzystując zasoby ukryte w naszej ziemi, troszczymy się jednocześnie o przyszłe pokolenia. Naszym celem jest ciągły rozwój i dostarczanie efektywnych rozwiązań energetycznych. To dzięki temu jesteśmy dzisiaj obecni niemal w każdym polskim domu. PGNiG. Odkrywamy przyjazną energię.
Energia elektryczna towarzyszy nam w każdej chwili życia. Za stały i bezpieczny przesył energii elektrycznej w całej Polsce oraz bilansowanie krajowego systemu elektroenergetycznego odpowiadają pracownicy polskich sieci elektroenergetycznych. Energii elektrycznej nie da się przechowywać, dlatego w każdej chwili należy produkować jej dokładnie tyle, ile zostanie zużyte. Oszacowanie zapotrzebowania na energię elektryczną i jej bilansowanie to jedno z najtrudniejszych i najważniejszych wyzwań, z którymi polskie sieci elektroenergetyczne mierzą się każdego dnia. Nasza sieć to ponad 14 600 km linii 220 i 400 kV. Wraz z dynamicznym wzrostem zapotrzebowania na energię elektryczną rozwijamy sieć elektroenergetyczną, by sprostać wyzwaniom nadchodzącym w kolejnych dziesięcioleciach. Przy wszystkich naszych inwestycjach minimalizujemy wpływ na środowisko naturalne i otoczenie. Wspieramy społeczności lokalne i naszych sąsiadów. W naszych prognozach dotyczących zapotrzebowania i popytu uwzględniamy zmiany zachodzące na rynku energii. Wyprzedzamy je, aby zapewnić bezpieczeństwo energetyczne naszego kraju. Bierzemy aktywny udział w transformacji energetycznej Europy. Jesteśmy częścią jednolitego, zintegrowanego europejskiego rynku energii elektrycznej. Krajowy system elektroenergetyczny jest szczególnie ważny dla bezpieczeństwa państwa. Dlatego przykładamy ogromną wagę do fizycznej ochrony naszej infrastruktury i cyberbezpieczeństwa systemów. Polskie sieci elektroenergetyczne realnie wpływają na polską gospodarkę. Polskie sieci elektroenergetyczne. Energia w dobrych rękach.
Energy gives power. Telecommunications gives connection. Banking gives stability. Big data gives knowledge. Smart city gives new possibilities. Healthcare gives strength. Insurance gives safety. Administration gives support. Defense gives security. IT gives freedom. ASECO. Technology for business. Solutions for people.
ARP to partner biznesowy dla firm, które chcą się rozwijać w innowacyjnych branżach. Firm, które szukają finansowania lub terenów inwestycyjnych w specjalnych strefach ekonomicznych. ARP udziela pożyczek na finansowanie inwestycji i kapitału obrotowego, realizację kontraktów, wdrożenie działań zwiększających efektywność prowadzonej działalności gospodarczej oraz na restrukturyzację. ARP udostępnia przedsiębiorcom swoją ofertę finansową w centrach obsługi przedsiębiorców. W dniu obchodów 30-lecia spółki ARP otworzyła 7. Centrum Obsługi Przedsiębiorców w Warszawie. Agencji Rozwoju Przemysłu bliskie są innowacje. Sieć Otwartych Innowacji. Jest to program grantowy, w ramach którego firmy mogą ubiegać się o grant na zakup licencji lub prawa własności do innowacyjnej technologii. ARP skutecznie ratuje od upadku firmy ważne dla polskiej gospodarki i społeczeństwa. Wdraża i realizuje program restrukturyzacji, który prowadzi do powrotu na ścieżkę rozwoju. Agencja Rozwoju Przemysłu zarządza 2 specjalnymi strefami ekonomicznymi, w ramach których utworzyła 3 europarki: Mielec, Wisłosan oraz Kobierzyce. ARP to partner biznesowy dla firm. Zapraszamy do współpracy.
Szanowni Państwo,
Ladies and gentlemen, let me welcome you to the next panel. I'd like to welcome our panelists, but also participants here in the room, on the internet. We are going to talk about energy security. So let me introduce our panelists, both the ones on site and the ones online. Professor Sabina Kutz. I will skip academic titles perhaps, but Paweł Michał, Łukasz Wesołowski, Piotr Bajor, Maciej Bukowski, Jacek Brożyna and Wojciech Stachyra. And I guess that's the order in which we are going to give our presentations. In order not to prolong, I'd like to give the floor to the first speaker. We have Professor Sabina Kutz with us, so over to you. Good afternoon, ladies and gentlemen. Let me welcome everyone. Dear moderator, ladies and gentlemen, co-panelists, and everyone in the audience, our online participants. We have learned during the pandemic time, we've learned to cooperate differently, to meet differently, to give presentations differently. So today, I'd like to present the results of work of my team at the chair of architecture, the Technical University of Kraków, and I want to talk about Erasmus Plus grants. And since 2020, we've been working on these two grants. The topic of my presentation is Erasmus Plus grants, Euro education and Euro integration as pillars of energy security in the common EU energy market. So, Erasmus Plus grants are new technologies, Euro integration, Euro education. New technologies cause the changes in the ways of functioning of societies, and we need to make the best use of them. Companies from the European Union need to increase their competitiveness using talents and innovations. Euro integration is about supporting social integration, scientific, educational integration, increasing understanding between cultures and strengthening the sense of belonging to the community. What is also significant, it is about prevention of certain favorable phenomena. Euro education, in turn, is about youth organizations and the possibility of training for them in order to develop their professionalism. It is also about support for educators of the youth. Euro education is about synergy between various sectors of education. That is why Erasmus was prepared in such a way in order to support participants and participating countries for efficient usage of human potential of Europe. At the same time, because there is a principle that we need to learn throughout our lives. So there is formal education, informal education, lifelong education, and that is why the program increases possibilities for cooperation and mobility in membership countries, and especially it pertains to higher education. Euro education is about implementation of international educational projects like Erasmus Plus grants. Energy consumption and greenhouse gases emission is a significant, or is caused by the construction sector in a large extent. Euro integration and Euro education for engineers is of key importance in energy policy of Poland and the European Union for processes of sustainable development and green economy. And under joint activities of academic institutions and research institutions in Europe, grants were launched, and they are to focus on preparing strategies for sustainable construction materials, composites, natural materials, locally sourced materials, and preferred elements from glued timber in order to have more balance in energy efficiency in the construction sector. So our university operates in a consortium with partners from 6 member states of the European Union. In the first grant, the leader is the University of Lisboa, Portugal, in the second, the University from Latvia. Projects are fully in line with EU requirements. They fit in these trends of Euro integration, Euro education, on scientific research and educational activities. They are focused on preparing innovative interdisciplinary e-learning applications of project-based learning for students, teachers, and entrepreneurs. It is about sustainable, efficient solutions in the construction sector. First of all, they are to provide access to certain solutions for local and national and international target groups. The first grant, Back to Future, is oriented on preparing and providing innovative interdisciplinary course of using sustainable traditional materials in the construction sector, teaching on the project-based learning and mixed approach. What's the origin of this idea? The problem of energy consumption, and greenhouse gases emission, because as early as the 19th century, the construction materials were introduced, such as steel and concrete. They replaced the traditional solutions, and they became carriers of 3 and 5 emission of greenhouse gases. So they replaced traditional and locally sourced materials like clay, timber, rock, straw, cork. Now we are trying to go back to tradition. We are trying to create an educational platform which will show to us that it is feasible, that we can replace what was produced for many years, that we can replace it with the love to traditional materials, locally sourced materials, and on that basis we can come up with less energy-consuming technologies. This grant is very significant from our perspective. Why is that so? Because it will allow us to use sustainable local materials to produce, to create, simply to build architecture. The most important thing is what kind of results we will achieve. And results of the grant need to be disseminated. It is important how the results will be used later on, both in education of young people, of adults, of teachers and entrepreneurs. The cooperation on educational platform is of paramount importance. And the other grants, which tries to show to us that we can produce sustainable high-performance building solutions with wood. They don't need to be low. These buildings may be tall as well. Now, we introduce wooden buildings mostly. This grant will allow us to recognize this topic and to investigate into it better, and where we can produce wooden buildings which will be higher. Here we want to come up with a certain results, like an educational module within our consortium, in order to carry out research for high-performance building solutions. We want to improve competences among students, teachers, entrepreneurs, the competences in high constructions made of wood. Due to our cooperation, we have EU integration And then later on, it can be applied not only locally, but on an international scale among international target groups. And here, a comparison of energy consumption. Initial information for our research studies and analysis, well, we used these comparisons, the comparisons of data which are published in various places, namely publications on environmental protection, publications on architecture, construction. So here, the first element to the right at the bottom shows how CO2 emission and how energy consumption go up when we have production of individual materials like PVC, timber, aluminum, steel, cement. Other graphs show these processes as well. The one to the right at the top is quite interesting because it shows how in the construction of a single family housing of different materials, how much and what we emit. It is a structure for a single family, so concrete, steel, timber, then finish of the surface of the floor, walls, roof, and then windows. Here you can see quite clearly that wood production allows us to reduce the pollution and reduce greenhouse gas emission. And what is significant for us, namely an example of analysis, it looks very well, it is very clear, I would say it is self-explanatory. The analyses like that are prepared for various materials, various systems, various cycles. And here we have a life cycle of a forest. A forest begins to grow, it starts to produce oxygen, the fauna and flora is developing there, clean water appears, and when CO2 reaches the forest handles that. The forest processes into oxygen. The forest is getting more and more beautiful, gives us more and more opportunities to be used by human beings for recreational purposes, for example. And at the end of the day, because there is this whole economy around it, timber becomes a construction material for us. And here, one more scheme showing how much of CO2 is generated by 1 acre of a forest and how much oxygen we have from that. So these drawings show us just a fraction of how analyses that we carry out under the grant, how these analyses may be presented, how they may be shown, how they may make an impact on our awareness, on the subconscious, how we can learn from analyses like that. And what are my conclusions? The conclusions are quite simple and straightforward. If under educational programs such as Erasmus Plus grants, which provide access to students, access to studies, education, through workshops, lectures of university teachers, study visits to industrial sites. And thanks to that, they learn more about the energy sector, energy-related problems. Thanks to that, these workshops, study visits, these methods, state-of-the-art tools, a broad range of professional contacts will enable us to look for solutions for existing current problems. And For example, here, in this particular context, energy-related problems. So the Erasmus example shows to us that we have to find our own niche in these grants, our fragment to work on, which needs to bring some results. And this Euro education and Euro integration, which is part of the grants, and which we experience as well under these grants, will allow us to increase energy security. Why? Because if these two processes will be continued, I think we can safely think about the future. And we can be calm about the future, because it will be the future of energetically safe Europe. Thank you very much for your attention. Thank you, Professor.
Thank you very much for such a concise summary of your work results of your work and results of the work of your team. When speaking about energy security, we need to emphasize the issue of competence, of security, and the concepts that you covered. As a member of the academia, I work at the in Warsaw, at the University in Warsaw. I can see that our students demonstrate manifest a growing interest in such energy security initiatives. As you rightly mentioned, we might end up having our graduates who have full awareness of energy security challenges. We thank you so much for your very interesting contribution. So now we can move on smoothly to the next presentation. Professor Piotr Bajor from Jagiellonian University in Kraków. Professor Bajor will tell us about the energy dimension of regional security in Central and Eastern Europe. Professor, may you please tell us more about the CE region in this context?
Te kwestie, które pani profesor
That was quite interesting. That was very interesting to listen to what the previous panelist said about educating new people for energy security, and I can see that students demonstrate a growing interest in this area. I would like to look at the energy security from a different perspective, but undoubtedly that fits into matches and fits into the presentation that was given before me. So I would like to refer to the geopolitical aspect. I would like to look back at what happened recently and assess energy security in our region. So I would like to give a broader perspective of political nature, which fits well into a certain trend of growing security, energy security. So we're looking back at consequences of the conflict in Ukraine. Speaking about energy security in the CE, let me look at these issues from the point of view of the challenges that we're facing. So, Nord Stream 2 pipeline construction is coming to an end. Considering U.S. position on sanctions and a certain certain concepts here, well, that all changed the entire picture. And at this Congress, during many panels, well, that entirely changed the security concepts in the in Europe, I remember that for very many years when I was analyzing the Ukrainian natural gas market and the gas transmission system and transport system in Ukraine, when Ukraine was quite effective in defending itself against the takeover of the system by Russian Federation in 1990s, and earlier on there was some documents on this joint participation in this project and management of the transportation system in Ukraine of key importance from the point of view of Ukraine. So that, and then I remember the concept of the transit system that Russia wanted to take over. So after Yushchenko came to power, he claimed political and energy independence. He said that if Ukraine were to be truly independent politically, Ukraine had to be independent in terms of energy sources, and that was highly unpopular. That cost him social support, but that policy of independent channels or routes of supply was continued. So the Ukrainian gas pipeline system, we know how important it is from the point of view of supplies and transit. For very many years, the Russian Federation, Gazprom, was attempting to take that over, and that forced the Russian Federation to diversify its gas routes and gas supply concepts. So again, there was this major change. About a decade ago, the first pipeline, the first part of the Nord Stream pipeline was launched, and that made the countries highly independent from the Ukrainian supply. So that had major consequences. From that point of view, we should consider certain conditions that determined the situation.
Ono narodzi bardzo duże reperkusje dla.
As I said during the panel, that that has certain consequences for the region and long-term consequences for the EU. So there are certain solidarity-related consequences that will definitely have this long-term impact. But from this point, it's worthwhile to analyze concepts or concerns related to the actions that affected the current situation. Well, we are aware of the events that have been recently widely commented and analyzed. I mean, the consequences that caused that investment project to be implemented. I would like to look from a broader point of view. I would like to go back to 2014.
Hipotezę związaną z tym, że ówczesna, nazwijmy.
Well, my point is that not very effective delivery of the energy union concepts caused that situation that in 2014, in response to events in Ukraine, there was this suggestion, this proposal of to adopt a uniform energy policy towards Russian Federation. It was about diversifying supplies, and the Russian Federation responded by opening more its eastern direction.
I skutkach w Szanghaju podpisania przez.
There was this Shanghai gas agreement signed between the Russian Federation and China for delivery of 38 million of cubic meters of natural gas to the Russian market.
Gazu można powiedzieć, że
The volume of the gas, these were not huge volumes, but that was a political and economic manifestation of the Russian Federation to show to the EU that there was an alternative route for transporting gas. Considering Russian-Chinese relationship, that was of importance because up to that point, there were long-term negotiations and leaders of both countries could not reach an agreement as regards the fee per the price for 1,000 cubic meters. These were huge amounts and huge deliveries. So that had these long-term consequences that can be that we can see until now, because that market was had an impact on the EU and the EU market. So that had an impact in the context of the energy policy of China and its economic growth, in particular in the context of deficit of supplies and deficit of gas. We know that China consumes more than 300 million cubic meters of gas, and the deficit is 120 billion cubic meters.
Chin. No i na razie to jest zaspokajane w ten sposób przez zwiększenie importu gazu LNG obecnie z 19.
So, and that is supplied by LNG import from 19 countries. Some entities joined it.
Gaz środkowoazjatycki, który płynie.
We have that the gas, natural gas from Central Asia. So, depending on the continuation of the economic development of China, China will need to secure gas supplies from the territory of Russia, the Federation. When you talk to the Chinese, they swear that they are not going to repeat the mistakes of the Europeans, and they're going to develop that direction of gas deliveries from Central Asia. But as I mentioned, the concept of the eastern leg, or diversifying gas supplies from the Russian Federation, well, that largely translated onto the EU policy. That EU policy has largely caused the situation that we have right now, and that affects stability and security of the region. So I'm not going to repeat the concepts presented during previous panels, but undoubtedly the current situation related to completion of the investment will be related to the regional security and other aspects. And as I already said, in my opinion, in the longer run, that is going to translate on or have impact on the European policy.
Professor, thank you very much for this interesting presentation. We often say that energy security is important also in the community perspective, in the EU context. So I believe that this aspect of Central and Eastern Europe, also from the perspective of our country, which is like a connector between the East and the West, it is also a significant topic. So many thanks for this comprehensive approach to the topic, including the presentation of the Chinese policy. I guess it is valuable for our better understanding of the subject matter. The next speaker will be still connected to the region, and it will be delivered by Jacek Brożyna from Rzeszów University of Technology, and he's going to talk about assessment of the Visegrad Group countries' climate and energy targets for 2030. Jacek Brożyna is an online panelist. Over to you. Thank you, Professor, for giving me the floor.
Szanowni Państwo, kraje Grupy Wyszehradzkiej.
Ladies and gentlemen, the Visegrad Group countries, as members of the European Union, are obliged to carry out a common climate and energy policy. In my presentation, I'd like to discuss the targets of this policy for 2030 and the likelihood of their realization. It is a far-fetched perspective, and many things may happen on the way, but let me discuss the targets, how ambitious they are, what is the perspective of individual countries from the Visegrad Group, and what are threats in their implementation. Before I move on to that, before I discuss targets for 2030, let me discuss targets which were defined for 2020. Now we are towards the end of 2021, but still I have some data only for 2019. Still the data for 2020 is not fully available, so we cannot fully assess whether the targets were really met or not. That is why on the basis of the data that was available till 2019, I created a forecast by 2020 or for 2020, and here in this slide, in a very simplified form, I marked the chances for implementation of these targets for 2020. So in green, high likelihood of meeting the targets, orange, a threat, red, very limited chances for meeting a given target, almost none. Now, no country should have problems with reaching greenhouse gas emission reduction, so that's the first column. It should be attained. We shouldn't perhaps call it a reduction, because the target was about the possibility to increase emission as compared to 25 for the Visegrad Group countries. But what is positive is the Czech Republic and Slovakia, which are quite successful in implementing 3 out of 4 targets. As for Poland, 2 targets will be reachable, and for Hungary only 1. Now let me move on to the targets for 2030. In this slide, these targets are mentioned one by one, and I marked the targets of the countries in orange. I mean the ones which were lowered or are worse as compared to the targets for 2020. And you may notice Hungary. So they don't have a more ambitious goal, or at least they should remain at the same level, but they changed their targets, and they are less ambitious and lower. That is why I'm going to focus on Hungary in a moment. As for greenhouse gases emission, we have negative values for each of the countries, and you may notice Slovakia's position, because they are quite cautious. It is minus 12%, but their plans, national plans, assume reduction by 20%. Now let me move on to individual countries. Here I will discuss them in an alphabetical order. You will see the structure of primary energy production for a given country, and then forecasts of attaining their targets for 2030. And you can see that for the Czech Republic, the country depends heavily on fossil fuels, which are the main source. Well, they make up 50% of the energy mix in this country, and the Czech Republic at the moment did not define the date by which they want to withdraw from coal. almost half of the energy there is produced from RES, and nuclear energy like 47%, so almost 50%. As for prospects of attaining the targets by the Czech Republic by 2030, we can see that as for greenhouse gas emission and its reduction, the purple line, it is minus 14%, but you may notice in the graph that this target was attained actually in 2019. So the trend is downwards, and I can see no threat, nothing will change by 2030, and the target will be reached. As for RES share, in the perspective of 2020, the Czech Republic attained this goal, actually back in 2013. And the prospect for 2030 is that this target will be also reached even earlier. What is more difficult for the Czech Republic is attaining goals in primary energy consumption and final energy consumption, because these values are not as close to the targets, but they are in a certain proximity. There are big fluctuations for primary energy as for final energy. The fluctuations are smaller, but they are closer to the value which was defined in the targets for 2030. Another country is Hungary, and primary energy, basic energy is from the nuclear energy and RES. It is like 2/3 of the energy, and Hungary focus on development of nuclear energy, and in the next 2 years they want to complete 2 more units of the nuclear energy power plant in Pax. Even though fossil fuels are slightly above 9% of energy sources for Hungary, as you could see in the previous slide, the country has to achieve a small reduction of greenhouse gases, but like minus 7%. And you can see it was actually achieved by 28. As for increasing share of RES, it may be difficult for Hungary to achieve because, as you can see on the slide, in recent years there is a slight downward trend, and they are rather focused on nuclear energy development. And the last issue is energy consumption. Here, I said at the beginning of the presentation that Hungary cannot handle this problem because they only define such targets which they are already meeting, so they are much worse than the targets that they had for 2020. And then Poland. Our energy sector is based on fossil fuels mostly. They make up 3/4 of the energy mix. This value is the highest not only among V4 countries, but throughout the European Union as well. We should be positive about the increase of RES, because now it amounts to several percent in Poland. And if we analyze the data we have had so far, if we look at prospects and forecasts for the future, it is difficult to say whether every target or any target will be attained by 2030, because we either have a trend that we can see for greenhouse gases, or there are big fluctuations, and forecasts for 10 years ahead are very difficult to be prepared. I would say that it will be very difficult to double the share of RES in the energy mix, but it obviously may change. To a large extent, it is up to the national policy. And the last country in the V4 countries is Slovakia. This country has the best situation. 90% is clean energy, so nuclear energy, almost 60%, RES, more than 30%. These are values which are the best among V4 countries group, but these are also the best values throughout the European Union. As for reduction of greenhouse gases emission by 2030, it was established at the level attained by this country in 2011. So there is no threat here. It seems nothing will change for the worse. A situation is similar for areas share in the mix. Slovakia negotiated less than ambitious goals. They should be attained by Slovakia very soon, so much earlier than 2030. It is very difficult to say what will happen with implementation of reduction of energy consumption, primary and final energy consumption, because these values are at a similar level in recent years and they are very close to the target for 2030. And it is my last slide with a brief summary of what I've said before. In the first table, there is red, green. For countries, we have the most beneficial and the least beneficial energy mix. So Slovakia was the best, Poland was the worst. In the second table, you can see countries which I think will be successful in attaining their targets and the countries for which it will be much more difficult. I'm talking about the targets for 2030. Unfortunately, the most negative outlook, well, the most negative situation is for Poland, so we need to do really a lot in order to reach these goals of the energy and climate policy. That's all from me. Thank you very much for your attention. Many thanks for this interesting presentation, and it was focused on important topics of energy and climate policy and its goals, especially in the context of the European Green Deal. And here, this presentation shows to us that despite the fact that we are a certain political conglomerate, namely the Visegrad Group, still we differ very much within the Visegrad Group when you look at the functioning in the energy sector. So there are different prospects for the future for attaining our energy and climate goals for 2030. What will be the final results? I think we'll learn about it in the near future, but I guess these are highly valuable analyses and they give us a certain opinion as to where we should make more efforts in order to attain the targets. And now it's time for our next speaker. It will be a presentation by Wojciech Stachyra from Maria Curie-Skłodowska University. He will talk about networks of grand strategies, energy security of Poland, and changes in the Eurocentric gas pipeline network. The floor is yours.
Bardzo dziękuję.
Thank you and good afternoon, ladies and gentlemen. In my contribution, I would like to tell you about my main occupation over the past 6 months. Well, I'm looking for the answer to this question, whether by creating formal mathematical models of certain structures, and these pipelines are undoubtedly such structures, can we say more about such structures? Can we squeeze anything out of them? Can we go deeper in analyzing their operation and their structure? So that comes instead of an introduction. So that is a quote from The Art of War by Sun Tzu, which is the source, an inexhaustible source of interesting quotes. So here we have this fantastic contrast of winning the battle and distinguishing sun from moon. And there are some very obvious activities. So there might be several interpretations of the quote, but mine is as follows. Since it is not obvious, that's why I can see the sense and the meaning of a single lightning. Perhaps it is not an obvious thing to see the sense of the single connection which is of interest to us, Nord Stream 2. The very statement that is of a geopolitical nature doesn't bring anything to our comprehension of the concept, because the whole thing is about defining the importance, the meaning of that concept and the mechanism that gives the status to such connection. So this is just general intuition. However, here we focus on several connections here. So, well, my area of political science is not very much appreciated by European political scientists. Well, and the question is how to model a network. When we look at your network of colleagues and friends, well, it is quite complicated. And when we try to draw it on a piece of paper or sheet of paper, you will see on next slides that it's quite complex. So we need to simplify the concept. We need to cut the cake into pieces and eat it piece by piece. So we are creating a formal model of the network of the grid. So this is a structure built of the V, which are grid network participants like you from the set A. So these are directional infrastructural connections, pipelines, and the two mysterious letters C and W. And from the formal point of view, these are functions, but these are subordinations. So W assigns the pipeline capacity and not the flow to each and every pipeline. Now let us go back to the question, to the main question. When working on with these two objects, C and W, we can define, and that could be done from the point of the structure and from the point of function. By using C and W, we define the distribution. Distribution in the sense, how are we going to cut the analytical cake? And the pieces that I would like to have, the pieces of torch, are the so-called trees and forests. So this is a forest structure consisting of three trees. Well, mind the definition above. A forest is an acyclical graph, and the coherent forest is a tree. So that's how it is, and that's what it is. So now we would like to cut our graph. How would we like to do that? So let us look at the ideal world without, let's imagine that we have this perfect world without politics. As a political scientist in such a world, I would need to change my profession because I would be redundant. So, and we would like to transmit as much gas as possible through the pipeline to our colleagues by building the lowest number of connections possible. And then by removing any connection, we can see that a tree falls apart and we have two trees as a result. So then we have systems, and these are the systems that we're interested in. Well, some may say that the world is not perfect, but since the economic logic is disrupted by politics, moving away from the tree structure, this is the concept of having that analyzed in the network. So it is not only Europe, this is also Central Asia, North Africa, Middle East. And so we need to have that strategy here. And let us now move to models. So what's my knife? How would I like to cut it? So I have the same algorithm, which is based on the existing algorithm. So that's the algorithm, and the concept is as follows. When I take the graph and I use a slightly modified algorithm, I cut out this tree that contains all countries, all states, and has the biggest flows, and I mark it. And I cut it out in such a way that the countries are copied and graphed and cut out and transferred. And I take what I have left, I mark it and cut it out and put it aside and go back. And I mark it and cut it out until there's no more pipelines to cut out, and I have the states left, and I look at my pieces of cake. So I have 3 pieces, but let me look at 2 of them. So that's the complete model. So the peaks with that that reflect countries. This is what the network looked like before Nord Stream 1, and this is what our network is going to look like. Once we have Nord Stream 2 and the Baltic pipe, that is the network, and with the pipeline Poland-Slovakia and Poland-Lithuania. This is what we're interested in. And then we have Eastman that connects us with other parts of Europe. So let us try and cut this cake. So the first piece of the cake looks as follows. So this is the tree that accumulates the biggest flows, and that has been created for the cake before these connections were made and before Nord Stream 1 was built. So see that the connection between Russia and Germany runs as follows. Russia, Belarus, Poland, and then Germany. Now, what happens then? We're no longer connected. Poland is no longer connected with Germany. The connection with the largest capacity was transferred directly between Russia and Germany. What does it mean? That means that our Poland-Germany connection was formally pushed down to a lower rank tree that generates smaller flows of lower strategic importance. So that means that the connection between Poland and Germany has been structurally deprived or discriminated. So our connection was pushed down and replaced by a more effective connection. And this is the tree that will be created when all the pipelines will be created. So here, us and Belarus, we're still in this side tree branch, and the tree trunk is right there, but it's not entirely visible. It's 110 billion of cubic meters of capacity every year. So we can see that connections are less abundant. So we compare, what we're comparing here is Russia, Ukraine, Kazakhstan. So Nord Stream 2 is the largest in this part of Europe. And now let us move on to the next piece of cake that I've cut. So once we cut all the pieces, we cut them out of the cake, and we just take the countries which are interconnected in the last piece. These states are the key crossroads here, because here at every step the algorithm was removing something. It was like a ranging bull. So the algorithm was just removing these parts mercilessly. So they survived, and it turns out that they were the key and the most important peaks or summits. And see that these summits were so important. So we have Ukraine, Hungary, Slovakia, Poland, and Germany, Belgium, Turkey, Bulgaria, and the UK. And that resembles the intermarium area. So to illustrate it, let me show it this way. I cut out all these summits, and the whole structure fell apart. This is no longer in an interconnected joint system. We have
drugi Europy Wschodniej plus
system of Eastern Europe, Central Europe. We have one system which is in the Balkans, and one very small connection between what I think it is between Denmark, and that's it. So our network no longer works as one system. So without these countries that I listed, our system cannot be operational. So whatever happens in our direct environment by itself is of strategic importance. And my final model, we have these direct neighbors in the network. So these are the states which are directly connected with these states. So it's like internal crossing. So formally, we are talking here about these are bottlenecks or choke points in the political science.
Czyli jak się taki punkt zablokuje, to całość zaczyna się właśnie krztusić, zaczyna niedomagać. Bardzo obrazowe określenie przyznają Państwo.
It is quite picturesque when you think about that along the following lines. So let me sum it up. Nord Stream 2 is the natural consequence of Nord Stream 1. Nord Stream 2 just increases capacity of the first one, will double it and overlap to some extent, but it will be the double value, not 50 but 100, but it will be the same connection. So it is like strengthening the structural changes which are already in place. On the other hand, when you look at this German peak or German summit, it has many connections. There are 8 connections there, but 4 out of them are entering, so they provide Germany with gas, and the other 4 are outgoing, so they distribute gas further, but they are much smaller ones, which means that Germany, in order to become a regional hub, would have to increase capacity of existing connections, and secondly, some of them will have to have the reverse direction, especially the connection with Austria, the Czech Republic, and perhaps with Poland. But yes, there is a gas pipeline from Germany to Poland, but it's of local significance. It is like 1 million of cubic meters annually, so it is negligible because the smallest measure was 1 billion cubic meters annually, so it is really insignificant. The third conclusion, Poland belongs to this collective core and collective choke point, as I called it, of the network. So the structure of the network and its functionality give us an opportunity of exerting an influence on the whole system. And the strategic game for modeling and for who rules, whose structure is the most beneficial, well, is strongly dependent on the emphasis, whether the emphasis is on Poland, on Slovakia, on Germany, perhaps, as it happens by Russia and Germany. And then another summary, or another conclusion here. Construction of Baltic Pipe and Poland-Lithuania gas pipeline allows to do rebranching. In theoriographs, we call it rewiring sometimes. Let me go back just for a second, very briefly. Yes, I know we have to wrap it up. Yes, that's precisely this model. When the Baltic Pipe was constructed, Norway sends gas to Denmark. We receive it from Denmark. We send it to Lithuania, but there is no connection. If we are cut off from Belarus, we are a branch, but the branch of the Norwegian structure, not the Russian structure. So it is much safer because it will not pressurize it as much as the Russian Federation, because the Russian Federation is a monopoly. And the last conclusion I didn't take into account, because I just want to say it to inspire someone, perhaps. In your opinion, well, I'm just quite curious, because my results show that we should move from a linear approach, one Nord Stream or the other Nord Stream, to a network approach, considering the whole system and assigning significance to the structure, not on the basis of the individual features, but on the basis of their position in the whole structure. So that's all from me. Thank you very much indeed. Many thanks. It was a highly interesting presentation, which closes actually our set of analyses on energy security. I guess that energy infrastructure is the key for energy security in general. So many thanks for this interesting and innovative presentation of the subject matter. The graphic form was very picturesque. It was like a lease of fresh air in analyzing these issues, ladies and gentlemen. The range of subject matter of today's panel was quite impressive, because we started from education, improving qualifications, competences in energy security through various aspects of a regional dimension of energy security, and we ended up with energy infrastructure. I would say that's the right direction of our analysis, which will allow us to understand these problems much better. Many thanks to our panelists for your presentations. Perhaps there are some questions from the room, from the audience. Anyone? No, no questions. There are no questions from the internet participants. So let me wrap it up and let me announce who is the best speaker in this panel, because organizers are introducing a new tradition. During every panel, the best speaker is selected, is voted for by our participants, and here the chapter chose Professor Bajor from the Jagiellonian University. So congratulations, Professor. It is my pleasure. Many thanks. Thank you very much for your participation. I didn't know about this tradition. I didn't know about this surprise, actually. So that's quite interesting, and I enjoy it very much. It is a nice element of such panel discussions. I'm very pleased. Yes, thank you very much indeed. Congratulations. Many thanks to the panelists, to participants, like physical participants, online participants. Thank you for following our panel discussions. Many thanks to all the panelists on site and online. Many thanks for your interesting contributions. And let me just say that every one of us has to take care of energy security in our small, limited scale. As people gathered in the room, we deal with education, research. So it is a good path to contribute to energy security thanks to our expertise, knowledge. From little blocks, we can build this bigger structure of energy security. So we should wish to each other that Poland and the European Union maintain this security at the highest possible level. Thank you very much. All the best. Thank you.
System. Zmieniamy świat dla przyszłych pokoleń. Natura to skarb. Dbamy o środowisko. Podejmujemy działania, aby przyszłe pokolenia cieszyły się światem, jaki znamy. Niezbędna jest transformacja energetyczna i my jesteśmy jej częścią. W Centrum Badawczo-Rozwojowym tworzymy innowacje w skali świata. W naszej fabryce produkujemy ogniwa, moduły fotowoltaiczne, systemy mocowań, szyby z powłokami kwantowymi, szyby, które świecą. Fotowoltaiczne żaluzje. Fotowoltaiczne fasady wentylowane. Fotowoltaiczne fasady. Fotowoltaiczne świetliki. Kolorowe moduły fotowoltaiczne. Rozwiązania Smart City. Dostarczamy kompletne rozwiązania systemów fotowoltaicznych zintegrowanych z budynkami. Szyby, które grzeją. Parapety, które grzeją i ładują. Szklane grzejniki. Szyby ze zmienną przeziernością. Chronimy zdrowie. Wirusobójcze przegrody szklane. UV-Box. COVID-detektor. Przyczyniamy się do ochrony planety i ograniczenia efektu cieplarnianego. ML System. Zmieniamy świat dla przyszłych pokoleń.
Sieć LTE 450 to niezawodna i bezpieczna, szerokopasmowa transmisja danych na potrzeby energetyki. To nowoczesne możliwości komunikacyjne, które możemy porównać do tych wykorzystywanych na smartfonie. LTE 450 umożliwia monitoring dużej liczby urządzeń, transmisję danych, przesłanie dokumentacji technicznej, map, zdjęć, obrazu wideo i komunikację głosową. LTE 450 to system wykorzystujący częstotliwość 450 MHz. Specjalne pasmo dedykowane sektorowi energetycznemu. To odejście od ograniczeń radiowych systemów wąskopasmowych na rzecz sieci wielousługowej LTE, gdzie pojemność sieci i zdolność transmisji danych jest nawet kilkaset razy wyższa. Jakie są główne korzyści sieci LTE 450? To podniesienie bezpieczeństwa poprzez efektywne wsparcie służb dystrybucyjnych w przypadku awarii, tak aby szybciej reagować i usuwać ich skutki. To zdalne zarządzanie infrastrukturą energetyczną w celu poprawy ciągłości dostaw energii, czy też zdalny odczyt liczników energii umożliwiający tworzenie lepszych taryf dla odbiorców. To wsparcie rozwoju odnawialnych źródeł energii OZE. LTE 450. Nowoczesna technologia, bezpieczeństwo, niezawodność, przyszłość.
Od tysiącleci człowiek odkrywa świat oraz mechanizmy nim rządzące. Napędza nas pragnienie poszerzania wiedzy i lepszego zrozumienia świata. Potrzebna jest do tego odwaga, która pozwala nam docierać tam, gdzie nikt wcześniej nie dotarł. I odpowiedzialność, która sprawia, że naszą wiedzę wykorzystujemy dla wspólnego dobra. Podstawowym obszarem naszej działalności jest wydobycie gazu ziemnego, ropy naftowej oraz sprzedaż tych surowców. Jesteśmy liderem rynku gazu w Polsce, notowanym na GPW. Działamy globalnie. Stale poszerzamy wiedzę, prowadzimy badania i inwestujemy w nowe technologie. Ma to kluczowe znaczenie dla ekspansji i przyszłości naszego przedsiębiorstwa. Jesteśmy wiarygodnym i pewnym dostawcą dla naszych partnerów biznesowych i klientów. Gwarantujemy stałość dostaw i najwyższą jakość produktów. Zapewnia to naszym kontrahentom poczucie bezpieczeństwa i warunki stabilnego rozwoju. Strategia działania PGNiG opiera się przede wszystkim na poszukiwaniu i eksploatacji złóż znajdujących się na terenie kraju i za granicą. Dzięki temu Polska wzmacnia swoją niezależność energetyczną. Chcąc dywersyfikować źródła pozyskiwania surowców, importujemy gaz z rynków zagranicznych. Istotna część przyszłych dostaw będzie pochodzić z Ameryki Północnej. Poszukujemy i eksploatujemy złoża ropy naftowej i gazu ziemnego na norweskim szelfie kontynentalnym, a także w Pakistanie i innych częściach świata. Całość tych działań sprawia, że jesteśmy kluczowym gwarantem bezpieczeństwa energetycznego Polski. Gaz ziemny jest najlepszym rozwiązaniem dla każdego przedsiębiorstwa, które pragnie działać w zgodzie ze środowiskiem naturalnym. Wykorzystując zasoby ukryte w naszej ziemi, troszczymy się jednocześnie o przyszłe pokolenia. Naszym celem jest ciągły rozwój i dostarczanie efektywnych rozwiązań energetycznych. To dzięki temu jesteśmy dzisiaj obecni niemal w każdym polskim domu. PGNiG. Odkrywamy przyjazną energię.
Energia elektryczna towarzyszy nam w każdej chwili życia. Za stały i bezpieczny przesył energii elektrycznej w całej Polsce oraz bilansowanie krajowego systemu elektroenergetycznego odpowiadają pracownicy polskich sieci elektroenergetycznych. Energii elektrycznej nie da się przechowywać, dlatego w każdej chwili należy produkować jej dokładnie tyle, ile zostanie zużyte. Oszacowanie zapotrzebowania na energię elektryczną i jej bilansowanie to jedno z najtrudniejszych i najważniejszych wyzwań, z którymi polskie sieci elektroenergetyczne mierzą się każdego dnia. Nasza sieć to ponad 14 600 km linii 220 i 400 kV. Wraz z dynamicznym wzrostem zapotrzebowania na energię elektryczną rozwijamy sieć elektroenergetyczną, by sprostać wyzwaniom nadchodzącym w kolejnych dziesięcioleciach. Przy wszystkich naszych inwestycjach minimalizujemy wpływ na środowisko naturalne i otoczenie. Wspieramy społeczności lokalne i naszych sąsiadów. W naszych prognozach dotyczących zapotrzebowania i popytu uwzględniamy zmiany zachodzące na rynku energii. Wyprzedzamy je, aby zapewnić bezpieczeństwo energetyczne naszego kraju. Bierzemy aktywny udział w transformacji energetycznej Europy. Jesteśmy częścią jednolitego, zintegrowanego europejskiego rynku energii elektrycznej. Krajowy system elektroenergetyczny jest szczególnie ważny dla bezpieczeństwa państwa. Dlatego przykładamy ogromną wagę do fizycznej ochrony naszej infrastruktury i cyberbezpieczeństwa systemów. Polskie sieci elektroenergetyczne realnie wpływają na polską gospodarkę. Polskie sieci elektroenergetyczne. Energia w dobrych rękach.
Życie to energia. Być może nie zastanawiałeś się, skąd się bierze, jaką drogę musi przebyć. Ale dzięki nam masz pewność, że zawsze będzie tam, gdzie jej potrzebujesz. Już od ponad 15 lat Gaz-System zarządza siecią przesyłową w Polsce. Zapewniamy bezpieczeństwo i ciągłość dostaw. Co roku przesyłamy miliardy metrów sześciennych gazu. Stale rozwijamy się, budując tysiące kilometrów nowych gazociągów. Współtworzymy zintegrowane systemy przesyłowe w Europie, dzięki takim projektom jak dwukierunkowy gazociąg łączący Polskę i Danię, korytarz północ-południe czy interkonektory. Będąc filarem bezpieczeństwa energetycznego kraju i regionu, rozwijamy inwestycje umożliwiające dostawy gazu z nowych źródeł i kierunków. Rozbudowujemy terminal LNG w Świnoujściu. Jesteśmy też odpowiedzialni za powstanie terminalu pływającego w Zatoce Gdańskiej. Zatrudniamy ponad 3000 pracowników, których łączy pasja i profesjonalizm w dostarczaniu czystej, konkurencyjnej cenowo i stabilnej energii. Dążymy do zrównoważonego rozwoju, wspierając lokalne społeczności i chroniąc środowisko. A ponad wszystko zmieniamy oblicze polskiego gazownictwa oraz integrujemy rynek gazu w Europie. Gaz-System. System, który łączy.
Polska Spółka Gazownictwa to największa spółka grupy kapitałowej PGNiG. Jako narodowy operator systemu dystrybucyjnego i europejski lider tej branży, przez prawie 200 000 kilometrów gazociągów codziennie dostarczamy gaz do ponad 7 milionów odbiorców. Stale czuwamy nad bezpieczeństwem i ciągłością jego dostaw. Chcemy, by z błękitnego paliwa korzystało jeszcze więcej mieszkańców Polski. Dlatego realizujemy strategiczny program rozbudowy infrastruktury dystrybucyjnej.
Inwestujemy w tworzenie nowych gazociągów, rozwijamy nowoczesne technologie i podnosimy efektywność podejmowanych działań.
Stawiamy także na gazyfikację wyspową.
Dzięki stacjom regazyfikacji skroplonego gazu LNG zapewniamy szybki i bezpieczny dostęp do tego paliwa tam, gdzie go wcześniej nie było. Dzięki naszym działaniom wzrasta liczba odbiorców gazu, a proces przyłączenia do sieci dystrybucyjnej PSG jest łatwiejszy niż kiedykolwiek wcześniej.
Wystarczy zgłosić się do jednego z prawie 200 miejsc obsługi klienta w całym kraju lub skorzystać z internetowego portalu przyłączeniowego.
Polska Spółka Gazownictwa. Dostarczamy paliwo gazowe w sposób ciągły, bezpieczny, z poszanowaniem środowiska naturalnego. Polska Spółka Gazownictwa. Wybieram gaz.
Energy gives power. Telecommunications gives connection. Banking gives stability. Big data gives knowledge. Smart city gives new possibilities. Healthcare gives strength. Insurance gives safety. Administration gives support. Defense gives security. IT gives freedom. ASECO, technology, solutions for people.
ARP to partner biznesowy dla firm, które chcą się rozwijać w innowacyjnych branżach. Firm, które szukają finansowania lub terenów inwestycyjnych w specjalnych strefach ekonomicznych. ARP udziela pożyczek na finansowanie inwestycji i kapitału obrotowego, realizację kontraktów, wdrożenie działań zwiększających efektywność prowadzonej działalności gospodarczej oraz na restrukturyzację. ARP udostępnia przedsiębiorcom swoją ofertę finansową w centrach obsługi przedsiębiorców. W dniu obchodów 30-lecia spółki ARP otworzyła 7. Centrum Obsługi Przedsiębiorców w Warszawie. Agencji Rozwoju Przemysłu bliskie są innowacje. Sieć otwartych innowacji. Jest to program grantowy, w ramach którego firmy mogą ubiegać się o grant na zakup licencji lub prawa własności do innowacyjnej technologii. ARP skutecznie ratuje od upadku firmy ważne dla polskiej gospodarki i społeczeństwa. Wdraża i realizuje program restrukturyzacji, który prowadzi do powrotu na ścieżkę rozwoju. Agencja Rozwoju Przemysłu zarządza 2 specjalnymi strefami ekonomicznymi, w ramach których utworzyła 3 europarki: Mielec, Wisłosan oraz Kobierzyce. ARP to partner biznesowy dla firm. Zapraszamy do współpracy.